Hello and a very warm welcome to the RSGB Convention 2024, Day 2, Sunday, coming to you live from the Kents Hill Conference Centre near Milton Keynes. Lovely to have you with us. We've got a packed programme today of lots of presentations and talks that we've selected from the range that are going on here. Plus, of course, we've got quite a few guest interviews and we're meeting some of the special interest groups as well. Let's have a look at the programme of talks today. And as you can see, we start in just about 12 minutes time with QRP Fun or Folly, followed at 10:30 by radio astronomy, mapping the Milky Way's arms and demonstrating dark matter from your garden. At 11:30, receiving live TV from the ISS, and at 1:30, beginners 3D printing for amateur radio. At 2:30, solar cycle 25, prediction versus reality, and then we close at 3:15. Well, if you were with us yesterday, you'll know we've got a special event station going on outside, run by Cam Hams, GB3 HQ, and at all times that will be running today. You can work it, of course, and also we're going to it with a live link stream, and that's what we'll do now. We'll see you very shortly for the first talk at 9:15.
Tango for Charlie Yankee. Oh yes, thank you, Vice Chair. Thanks very much, and letting me know that there is a contest on. If you want to, I'm going to say good morning to the live stream. How are you doing, guys? Welcome along to the second day of the RSGB convention here at Kents Hill in Milton Keynes. So if you want to join me live on air, currently I'm on 7.141 megahertz, and been lovely to have you in the log. So Stuart, thank you very much for calling in. Mike 7 Tango, Charlie Yankee 73. Bye-bye. QRZ, this is Gulf Bravo 3, Hotel Quebec, the special event station for the RSGB convention at Kents Hill Conference Centre, Milton Keynes. QRZ. Sorry, the station ending Zulu? Yep, Roger, got you there, Mike. India 0, India Romeo Zulu, good morning to you. Welcome along to the RSGB convention, special event station here at Kents Hill. Operator name this way is Savannah, Sierra India Mike Oscar November Echo. And you're coming into me 10 over 9, lovely signal, 59 plus 10. So how copy? Mike India 0, India Romeo Zulu. This is Gulf Bravo 3, Hotel Quebec.
9 plus 10 into Northern Ireland, operator Davy, and lovely signal also. I believe we have some of our Mid-Ulster Amateur Radio Club guides there over at the convention this weekend. Over.
Yeah, indeed. Yes, fine, Davey. You are, yes, indeed. Well, we've got everybody from all over the place. Coming here to enjoy the convention. It's been going on really well. If you want to join the live streams, then you go to rsgb.org/convention, and from there follow the stream, the little breadcrumb trail till you get to live stream, and then you'll find the program for today as well on that link. come and join us if you haven't been able to make it down today. MI0 India Romeo Zulu. This is Golf Bravo 3 Hotel Quebec. Over.
MI0
7-3 David, thanks for calling. Ta-ta. QRZ, Golf Bravo 3 Hotel Quebec. Over.
No, I'm having a bigger problem.
Station HOA. QRZ, this is Golf Bravo 3 Hotel Quebec. Over. Golf 3 Zulu Hotel India. Hello there. Good morning again. Welcome back to the station. GB3 HQ. What have we got here? Ian, good morning to you. Yes, like yesterday. So how's things today with you? Go ahead. Yes, I managed to blag a cat. It's actually a rather nice cup of coffee. Jeff, that's just. So we've got people coming into the shack and just wondering. I'm glad you're watching the stream anyway. I hope you enjoyed the result of the work of everybody here today, because there's going to be many nice lectures to watch. With that, yes, you're coming in 5-9 plus 10 to me here in the convention this morning. Go ahead. All right then, Ian. I'll say 7-3. Thanks for calling in again. Bye-bye. QRZ. This is Golf Bravo 3 Hotel Quebec. Enjoying a very nice cup of coffee, huh? Papa Charlie 2 Foxtrot now. There's a contest call. Good morning, Golf Bravo 3 Hotel Quebec. Go ahead. Yes, good morning, Franz. Papa Charlie 2 Foxtrot from Golf Bravo 3 Hotel Quebec. The name this way is Simam, Sierra India Mike Oscar November Echo. Copying you 5-9 plus 20. Lovely signal here into Milton Keynes at the RSGB convention. Go ahead. Papa Charlie 2 Fox from Golf Bravo 3 Hotel Quebec. Thanks for calling in, Franz. Much appreciated. And catch you further down the log. 7-3 QRZ. This is Golf Bravo 3 Hotel Quebec. Mike 0 Delta India Sierra. Good morning to you. This is Golf Bravo 3 Hotel Quebec coming in 5-9 plus 5 here into the convention. The operator name here is Simam, Sierra India Mike Oscar November Echo. So her copy. Golf Bravo 3 Hotel Quebec. Over. Yes, Roger, that's Ian. Lovely. Thanks very much for letting me know I'm booming into mid-Scotland. That's lovely. We're suffering with a little bit of QR Nancy here because they've got some fancy stuff in the kitchens going on, and breakfast is still being served. So I get a bit of QR from the kitchens, lamps and so on. Breakfast, yes, breakfast. That's just It wouldn't be nice, eh? So that's it from me. Anyway, are you watching the stream at the moment? MM0 DIS. This is GB3HQ. Over.
Yeah, no problem. Thank you. No problem, Prof. Your frequency is very clear and no noise at all.
Okay, cheers, Ian. Thanks for calling in. Bye-bye. Golf Bravo 3, Hotel Quebec is clear. Call with CQ on 30 metres. GB3 HQ, over.
Mike November 0, India Foxtrot Golf.
Oh, that's a nice singer. Mike November 0, India Foxtrot Golf. This is Golf Bravo 3 Hotel Quebec. Good morning to you. This is that's a club call, isn't it? Yes. Good morning to you. Tell us all about your club. You're live on the live stream at the moment with Golf Bravo 3 Hotel Quebec. Go ahead.
Yeah, very good morning, Simone. I believe it's still you. I was on there a while ago with my own call sign, MI0IRZ, Daily in Northern Ireland. Yes, it is a club call. And we also have 2 or 3 other calls, but at the moment there's many people calling me. But that's our little club call here, Mike November 0, India Foxtrot Golf under 20 over.
Yes, Mike November 0, India Fox Golf. Yes, okay, fine. Good morning, David. Well, nice to speak to you again. And getting the club call activated, which is fabulous. And yeah, you're booming into 20 over 9 here into the convention. So thanks very much for calling. And we'll catch you further down the log. 7-3. QRZ, this is Golf Bravo 3 Hotel Quebec. Delta 1 Victor Kilo, guten Morgen, mein Herr. You are 5-9 into the RSGB convention at Kent's Hill in Milton Keynes. So how copy? Over. Delta 1 Victor Kilo, Golf Bravo 3 Hotel Quebec. Yes, good morning, Jorgen. Thank you very much for calling. My name is Simone.
We'll leave GB3HQ there. Good morning if you've just joined us. This is the live stream studio coming to you from the RSGB convention near Milton Keynes. Now we're ready for our first talk of the day, QRP Fun or Folly by Professor Dr. Bruce Macaulay.
Well, good morning and welcome to Lecture Room 2 here at the RSGB 2024 convention. This morning we have a talk all about QRP and it promises to be an exciting talk. Our speaker this morning is Professor Bruce Macaulay, G4ABX, who has brought along an exciting range of hardware in front of us as well, which I'm sure he will get into. A brief overview of Bruce. He was born in 1954 in Paris and discovered radio much the same way as I did in a family member introducing me to the hobby. But in his case, it was his grandfather giving him an AR-88 receiver and used it to listen to amateur radio operators on 160 metres. He went to Leicester Polytechnic as a Marconi-sponsored student to study a degree in electronic engineering. And there he fell under the tutelage of Bob Titterington, G3ORY. He is still a member of the De Montfort University Amateur Radio Society and operates competitions for. He discovered radiocraft while working for Eddystone Radio and then moved on to the automotive industry as well. This morning, let's welcome and give a big hand for Bruce Macaulay.
Hi, thank you very much indeed. Ladies and gentlemen, good morning. Good to see a lady in the room. Okay, so you've just had a bit about me, so I'll just do a tiny bit more. So there's the AR-88, probably not the actual AR-88, but an AR-88. So I was 7 when I got that, and I can still see my mother's face as my grandfather carried it in with my dad up to my bedroom. I got on so well with that for my 8th birthday I got a Philips Electronics Engineers kit, which were wonderful pieces of kit. The only problem with them was that by the first weekend I built everything that the kit could offer, so that was not very good. But it hooked me. Electronics, I realised that's what my career was going to be. Nothing always works. Right, so my first QRP rig. My first call sign was G8DJV. My car in the car park's got that on the back of it, and on the front, I hope, still. I built a Heathkit Tour, the lunchbox as it was known in the USA. Great piece of kit, valve, of course, crystal controlled, of course, because we're talking, I think I was 17 at the time, so I'm a bit more than that now, so it was a very long time ago. AM, transmit and receive, and in those days you would transmit on the frequency of the crystal that you had, because most of us only had one, and you'd tune the band up and down to see if you could find anybody coming back to your CQ call, which was good. And that really began the love affair that I had with Heathkit. Heathkit probably did more in those days for amateur radio than anything else and anybody else. I think it's not going to work, so... And there's my first HF QRP rig. And here it is, the physical element. So I built that, seems like hundreds of years ago, and still works today. Great piece of kit. But one of the things that you discover when you go HF QRP is that you do want a few sophistications. And one of the sophistications I wanted was size. So the mountain topper, this fella, darn sight easier to take when you're going to climb up a hill than that Heathkit. And I wanted a sophisticated but simple, lightweight CW, Morse code, transceiver for parks and summits on the air activities, POTA and SOTA. This mountain topper, as it's called, was designed by Steve Webber, KD1JV. This one runs 3 watts, roughly, on 40, 30 and 20 meters, and those are probably the most popular of the portable operating bands, because the antennas are not too large, essentially. It has a 500 Hertz crystal ladder filter, which is really quite good. The shape factor of the filter, its ability to reject unwanted signals is excellent for something so small. And although the receiver's got no volume control, so beware when you plug earbuds into this, make sure your earbuds have got an inline volume control, because this little rig has got sufficient output to be rather loud. I'm going to run it with a self-powered little speaker, so I think from that point of view that's perfectly loud enough for me when I'm operating out in the field. The rig weighs about 125 grams, 4.5 ounces thereabouts, and as I said, operates from 6 to 12 volts. 12 volts is a maximum voltage for this little rig. The output stage is 3 parallel FETs, and they haven't really got very much protection. So if you crank the voltage up too much, particularly with a high standing wave ratio on the antenna, then the 3 little FETs that are your output PA start to dissipate rather more power than they can handle. Okay, so let's take this little box of magic apart and have a look and see what's contained within. I built one of these as a kit many years ago. Gosh, it wasn't as sophisticated as this. And there you go. That's what's inside. All nicely assembled. Our low-pass filters are here. This for the 3 different bands. Antenna socket is an RCA rather than a BNC or an SMA. I guess SMAs weren't really in vogue when this kit was designed. And here are the 3 PA transistors, these fellas here. Exactly the same PA transistors as contained in this. There's 3 in there as well, and I blew up the 3 in here through running it without any form of ATU into too high a VSWR. But the good news is you can buy 10 of these replacements for about £6 on Amazon. And they were all good. They all worked, so no problem with that. But there you go. There's the transceiver. So headphones, or as I use, a self-powered loudspeaker, your paddle in there, your power in here. Give you a bit of advice, don't lose your power lead, because this is quite a specific socket. It's not the normal size that you would find, and antenna, of course. The other thing you have to do, it's not very sophisticated in terms of band changing, so you have to line up each one of these switches to whichever band you want to operate on. Otherwise you'll have a mixed low-pass filter output. So 40 meters, 30 meters and 20 meters. So that's put it on 20 meters. And pretty simple, really. So I'll put it back together. Okay, so let's sort this out and power it up and various things. So I'm just going to use my my Tracer 4 amp hour 12 volt battery. Apply the power of that. My antenna lead. I use my palm paddle, my tiny palm paddle as the paddle. And we'll use this fella, very inexpensive but quite useful loudspeaker. Turn it on. Right, the 2 that it signaled there, I'll just do that again. Turn it off. That tells you that it's on 20 meters. If I put it on 30 meters, it is 3, and if I put it on 40 meters, it gives you 4. Oh. I don't know whether that was somebody's calling CQ or somebody working somebody that I can't hear. Let's have a tune about. Right, so tuning, this brings it down the band and that takes it up the band. So if we push down on there, it'll just tune. You can't see what's going on, that's the only downside. Oh. Okay, somebody giving a 559. EA2, EW. Okay, so that was me just trying out whether or not having live video of the real thing and having the real thing as well was useful. So I'd be interested in your feedback at the end, whether it's good to have these videos injected. Right, another QRP rig, KX1. So I built this when I was at Leicester Polytechnic. So again, I was 19, I suppose, 20 in those days. But I built KX1s, and again, the very same one is still with me today, and one of my favorite QRPs. Built-in ATU, you can also have built-in battery, so it can be completely self-contained. A built-in keyer, so just the paddle needed. And it's got proper CW filters, so I'm kind of moving up into the quality of the CW filters. This is one of my oldest rigs. It's this one, the Argonaut 509, which was probably the first recognised QRP transceiver. This was left to me, bequeathed to me by a very good friend of mine from the Shetland Islands. But it's lived in a box for more than 40 years. And last winter I decided to restore it back to its full functioning glory. So that does SSB and CW, full break in CW. It's an absolute joy to use. 3 watts. You're getting a flavour here, sort of 2 to 3 watts, 3 watts, QRP. Bringing us up to date, the Zygo G90, if any of you have looked at any of the QRP offerings, then this is one that I've got. I use one of these for Parks on the Air. It's 20 watts. I'll explain why 20 watts is quite an interesting level for QRP operators as we move forward. This is very easy to use. It's very well built, small enough to be portable, quite heavy because it's steel cased, so it's also quite robust in that respect. And it has a useful, if rather small, panoramic display. Low receive current. If you're operating portable, I do quite a bit of portable operating, the amount of power your rig takes on receive becomes quite important. This little mountain topper I can run all day on a single PP9 battery. So I've got rechargeable PP9 batteries, and you can imagine therefore that the weight of the battery power is tiny as well. And the KX2, I think that's this fellow here. If I could only have one QRP radio, it would be this one. It's also one of the most expensive, unfortunately, so it's taken me quite a while to get one of those. That's the key for it. And the KX2, self-contained, so everything's in there, batteries, the ATU, it'll tune the literal wet noodle, that KX2. Brilliant piece of kit, all modes, SSB, AM, FM, CW, great QSK, so listening through the dots and dashes when you're sending Morse code. And I'll talk a bit more about Morse code as we move through. The Elecraft K2, so that's the kind of big brother to this. In the end, my ability to carry all this damn stuff decided what I would bring and not. So I bought the smaller one. But the KX2, probably one of the most sophisticated QRP kits on the market. You can still buy it today. And I built 2 of these. I built the first one, loved it, and stupidly sold it. And I missed it so much, I built another one. So it's a great piece of kit. Self-contained, all HF bands, tuner, battery, the lot. I've actually got mine split out, so I also have a 100-watt module version of this alongside it, so I can run it as a 100-watt rig if I want to, but absolutely superb piece of kit. Elecraft have kind of taken over from Heathkit, really, in my mind, although some of the Heathkit stuff was perhaps a little more affordable than the Elecraft kit. And then I suppose the pinnacle at the moment, I say at the moment because I think Yeso are bringing out something that might be quite interesting in a couple of months' time, the IC705. Now, I do have one of these. I didn't bring it today. Honestly, I've taken it out on portable operation a few times. It's a great QRP rig, bar one thing. As I'm a CW operator, the 705 uses relays for the transmit-receive. And I don't really like that. It's not purist enough for me in a strange kind of way. So it tends to live most of its life on digital modes in the shack. But a great piece of kit. And again, can be self-powered and will last pretty much all day if you're out operating portable. You don't want to spill any moisture on these rigs, however. Although they're physically robust, they don't cope well with the wet. Right, the elephant in the room with most of my rigs is Morse code. I was very fortunate. I learned Morse code at a young age. I went to night school to learn Morse code for 3 months. with a bunch of mates, and it was great fun. I think I was 14 when I passed my Morse test. So again, a very, very, very long time ago. But if you want to take advantage of, lightweight transceivers like these, they're not only lightweight, they're light in power consumption and they're light on your pocket, then you need to have Morse code to take advantage of these. Now, you don't need to be sending Morse code at 35 words a minute. People are very happy if you come on at 12 words a minute, or even 10 words a minute. So don't be frightened. There are specific frequencies on all the amateur bands for low power operators, QRP. And people are very forgiving if you're going to have a go with Morse code. So for those of you that think it's not possible, believe me, if I can do it, you can all do it. A bit about power and antennas. I mentioned that the Zygo G90 runs 20 watts. And 20 watts is great for SSB. 10 watts is kind of okay, but 5 watts will be very frustrating for those of you that are new to QRP operating. It's absolutely not like going on the band with a 100-watt rig. It's fine to have 5-watt rigs once you understand what can be achieved, but to start off with 5 watts SSB, you'll give up QRP. And it's quite interesting. I monitor all of the for sale sites. And it's amazing when a new QRP rig comes out, everybody rushes out and buys them. And then after 3 months or 6 months of running 5 watts, they realize that actually it's not very fulfilling, and they all come up for sale, which is when I buy mine. So all of these, that was a second-hand purchase, that was a second-hand purchase. So, you can save yourself a lot of money going QRP by buying the rigs that other people have got frustrated with. So I just advise that. 5 watts for CW is actually quite a lot. I've worked New Zealand on this little fella, running, that was 3 watts. So you can work the world. In fact, I worked New Zealand on that little fellow and that antenna using that mast. So you don't need 3-element beams either. When the conditions are right, you're on the right band. So it's a combination, really. When I operate portable, I made myself a rule at the beginning of my portable life, and I said, if I can't assemble my antenna in 10 minutes, it's not for me. So it has to go up and has to come down in 10 minutes. Otherwise, I get frustrated. None of this lobbing stuff over trees 27 times. I wanted self-contained antennas. So that was my rule. You also need an efficient antenna as you can possibly make. And the end-fed half-wave, which is what this fella is a great choice. My recommendation to you is avoid tiny, wonderful-looking verticals. The sort of things that you can fit in your top pocket. Until you've learned about QRP and portable and you've had some success, they again will frustrate the heck out of you. So you want to get as much wire in the air as you can. And magnetic loops, I have a magnetic loop. It's pretty good, but by gosh, it was expensive. 500 quid for a magnetic loop that you might use, I don't know, 10 times a year. It's a big investment again. Whereas, 25 quid to build yourself one of those that you can use every time you want with that mast, you get a lot more usage out of that. Quarter wave verticals, you can always fall back to a quarter wave vertical, but please put some radials out with your quarter wave vertical. Don't think the spike in the ground is going to do the job for you. It won't. It'll just frustrate you again. So, as much active conductor in the air as you possibly can. So this end-fed half-wave, there's a bit more about this in a moment. I'll run through the actual working of this end-fed half-wave. 21 meters of wire. This is just hookup wire. This is nothing special. a 49:1 Unan. This one made by a great mate of mine, Colin, MM0PX. Colin and I kind of worked on this one together. Very simple, works brilliantly well. And for 2 meters, for VHF, one of the most efficient antennas I've found is a 5/8 made out of a slim jim, essentially, just made out of dual cable, 450 ohm, 300 ohm. There's lots of things you can do with that. But for starting off the end-fed half wave. Right, so the first task is to thread the antenna, undo all the bits and pieces, and thread the antenna through the end loop here. SOTA beams, wire winders, these things, absolutely great for antenna experimentation. So now we'll undo this little lot and assemble it. The antenna, the end of the antenna, which is a high impedance, being an end-fed half wave, is actually just supported by a tent peg nailed in the ground and some paracord. So nothing really very complicated about that. There's 21 meters of antenna cable on here and about 10 meters of coax as well. What wire winders enable you to do is to unwind your antenna wire without it getting into a horrible mess. This is a set of 3 guys for the mast. Again, 3 tent pegs and some paracord. When you buy the mast, notice that you can buy a guy ring to go with the mast, and I certainly suggest you do that. And you'll notice that the guy support stops. So how many is that? That's 1, 2, 3 sections, just stops and locks there. So here we have the KX2. Okay, immediately 1-to-1 on 20 meters. I wonder if there's anybody on. OE6. Okay, so the antenna with its Unan. I haven't got a counterpoise on here yet. There is a position for the counterpoise here, and I'm pretty sure that will help reduce the SWR, although at 1.2 to 1.4-to-1 the SWR frankly is perfectly fine. So this is the Tactical Mini from SOTA Beams. Very useful mask, packs down really small. You can see the size of the sections, really short sections, so great for portable operation. Takes no space and is perfectly backpackable. The guy ring, very useful. You need a guy set on this antenna when you put it up, but you don't need to support it with anything in the ground. Simply resting the base on the ground with 3 guys and you're away. In fact, you can get away with 2 guys. You might notice this guy's rather floppy, and that's because that's in the direction of the antenna. The other thing to say is that end-fed half-wave antennas, particularly in this kind of inverted L situation, tend to fire best in the direction of the radiating wire. So at the moment that radiating wire is pointing west. The station that I just worked was in Germany, so he's north of me, so it's not the perfect antenna situation for him, and 40 metres wasn't in very good condition. Okay, so I wanted us to just have a quick look at the SWR achieved by the antenna. This is it on 40 metres, and about 1.3 to 1 is the SWR. I hope you could see that. 20 metres we're down to 1.2, which is super duper. 21 we're at 1.5, little bit higher up the band. This is one of the problems with this type of antenna or anything that relies on harmonics. If you're resonant at the low point of one band, then as you increase in frequency, the resonant point is also going to increase from the bottom of the band. And if we look at 28 megs, we're at 1.4 to 1 at 28.5, and that's pretty good. That's probably the best you could reasonably hope for. So it's performing very well, the antenna. The 49 to 1 Annan, 21 metres of wire. It's pretty much exactly 21 metres of wire. I mean, yes, I could probably improve the SWR if I put the counterpoise on. I haven't got the counterpoise connected. Doesn't need a very long counterpoise, 5 or 6 foot, something like that. So I may well do that in the future. Oh, right. Moving on, the Go box. So this is my Go box. It's got a KX3 as the fundamental radio, but the box also contains battery, obviously, a Raspberry Pi, this fella, little one. So with my phone or a tablet, I can run digital modes directly without any physical connection to the Go box. And we'll have a look at it operating. Going to use this along with the KX3 Go box that I built a couple of months ago. So taking it out for a bit of an operate in a national park in France, in southwestern France, in the Limousin region. So I'll now go and set up the kit inside. Okay, firstly to set up a small table, and that's it. Table set up. Not very complicated. Okay, one final bit. I find I have this. I think it's a kitchen mat, but I find it works really well on the table to stop the gear rattling about. And here's the Go box. So it's really very simple. This is the beauty of a Go box. When you open it, take out the 2 metre antenna. I might have a listen. I might have a listen around 2 metres as well. Plug in the vertical. And we're done. So, there was the Faroe Islands. Not worked the Faroe Islands before. There's a new country. And I broke through a pile-up running 10 watts on that occasion. So pretty good. 15 meters. Alpha Bravo X-ray.
Okay, Bruce, no problem at all. Roll 4, Alpha Bravo X-ray stroke possible. United X-ray 7, Italy Whiskey. Good afternoon, thank you. 5x4, 54 to 55, and Cure Mexico on the frequency. How could you, over?
Yeah, 5 and 8 to 5 and 9. 5 and 8 to 9. 5 and 8 to 9. No problem. I'm out in the wilderness. I'm out in the wilderness. So no QRM here. 73s. Thank you for the call. Fox Stroke, Golf 4 Alpha, Bravo X-ray portable.
By 9 for me. Have a nice weekend, my friend. 73s.
73s. I thought about doing kind of live op here. It never works. So you've got canned live op here. That was operating Parks on the Air. Now, Parks on the Air is a slightly competitive process where you register on a website. All the parks in and around have got designated numbers. It's really, really popular in the States. Not so popular yet over here. And in France, where they have huge national parks, I operated 2 of them for the very first time, which rather surprised me. But Parks on the Air, it's great for us 70-somethings because you drive up to it. You don't have to go climb a mountain. You set your gear up, as I did in the back of my Land Rover, and away you go. Put your aerial outside and away you go. It's great. But it also gets you out the house, and with low power, QRP, you know, the world's your oyster. You don't need, that was 10 watts SSB, working the Faroe Islands from southwest France. Everything self-contained with this little yellow box here. It's really not that complicated. Right, portable power. I've mentioned, you know, powering things. When I started portable, then gel cells, lead acid gel cells were the way that you had portable power. And you really didn't have very big batteries because they're so flipping heavy. Now we're into lithium cells. LiFePO 4 batteries is the technology that I prefer. They're much lighter. They've got much better discharge characteristics, and they're much more reliable and predictable. I also tend to use a reasonably small battery, you know, 4 or 5 ampere hours, but with a fold-out solar pack, which I put on the bonnet of the car to keep me. It's amazing how long that'll keep me going all day, provided the sun's out, it's not pouring with rain like it is often here in the UK. Although, interestingly enough, we've just sold our place in France, moved back to the UK, and I worked out that I needed about 4 times the battery capacity that I had in France in order to use the same number of solar panels, just 2 of them in the UK, to keep it all charged up. So the 80-meter contest last week, I actually ran off, essentially, solar and batteries. So it can be done. And I decided that I'd build myself a LiFePO 4 battery. It doesn't look very pretty, but that's a 15 ampere hour battery that will happily run a 100-watt rig. And building it myself, and I've probably had that for 10 years now. So that's a long time ago when LiFePO batteries, LiFePO 4 technology was really new. I think what I like about it is it's intrinsically safe. It's not like the standard lithium batteries that you see that are not intrinsically safe. Any of you that are I don't know, radio control enthusiasts, you can, I was sailing yesterday and they got a bunch of guys doing radio controlled boats, and you have to be very careful with the lithium batteries to make sure you don't get them wet and you don't puncture them. But LiFePO 4 is a lot better. That's a great little battery pack, and it's one I use a lot. That's the solar panel that I use. Okay, I've pinched it from another presentation, so the image is cut off a little bit. Don't believe what they say on the tin with solar panels, by the way. So that's supposedly a 60-watt solar panel. At a push, you might get 35 watts out of it, so don't be surprised. Some of the solar panels work really well and do what they say on the tin, but that was a kind of £140 ton. The really good ones are £600–700. I wasn't going to pay that amount of money for a solar panel, sorry. I've also mentioned the Raspberry Pi, this fella. So this is my, I suppose, portable computer. There's one of these inside this yellow box here, and I can operate it with my phone or with an external tablet. But I use a bit of software from Jason, KM4ACK. Jason has done, if you look at all the symbols, you can see there. You can see all of the different functions that you might possibly want for amateur radio, including kind of FT8, logbooks, etc., etc. Jason has done a brilliant service for radio hams, completely free of charge. He's assembled all of that and just put together with some scripts, and it's dead easy. You download it, put it on the little card, plug it in, turn your Pi on, and you've got all of the communication software that you could ever need. And that's what I use exclusively. This little thing again, one of the problems with being out portable and running digital modes, some of you may know that if you're running, say, FT8, it's a very time-sensitive mode. So it's really important that your time is matched to the guys and girls that you're talking to. And if you're away from Wi-Fi connectivity or internet connectivity, you need a real-time clock. The little module that's at the bottom there is a real-time clock that plugs into 4 of the pins on this little fella here. And for, I think, £6 or £7, it gives you the ability to operate completely away from the internet and have well-configured digital modes. FT8 WJSTX as the software. Again, this is a shot from this. I think that's not from. This is from the G90. So I run the G90 as well as a Parks on the Air rig, but again another Raspberry Pi. Raspberry Pis did get very expensive when for a couple of years, but they're back down to reasonable prices now. And anybody who's scared to death of computing and the idea of programming things themselves they don't want to do, I encourage you to have a go at a Raspberry Pi. It's really not complicated. And with the scripts, you don't need to do really any programming at all. You just download it, you put a few commands in, and away you go. It'll download and operate effectively. There's another little operating bit of software there, Grid Tracker, on the right. So it shows you all the stations you've worked, all the stations that are on, and all the stations that you've still got to work with FT8. So very visual. Makes it actually quite interesting for other people that happen to be in the shack with you, because they can see who you're talking to. That also works quite well. So I'm supposed to leave you time for questions. So now we're in the time for questions. And of course, if you want to come and have a chat about any of these things afterwards, by all means, do that. I've got a website, g4abx.co.uk, unsurprisingly. You can get to a bunch of my YouTube channels from that as well, but there's a bunch of stuff on there, and that's my email address if anybody wants a direct contact. Okay, questions then?
Any questions in the room?
There's never any questions to start with.
There's one over there.
One, and then they all flood in.
Hi, Bob, G4DBW. What displays do you use, portable, for your Raspberry Pi?
I use my iPhone.
Oh.
So just any old iPhone, because you create yourself a hotspot with your iPhone, and you match it to the hotspot that you've created on your Raspberry Pi, and it's basically like sticking a remote display onto the Raspberry Pi. You don't need any connection. So that's what I use. I've tried all kinds of different displays plugged in with mini HDMI and micro HDMI and you know, even smaller than micro HDMI. They're all right, but for any of you that have operated portable, it's always the electromechanical interconnect that lets you down in the end. And the more complicated that electromechanical interconnect and sort of HDMIs and all of those, they're the first ones to fail. So I found the best way is to either have a tablet or to have your phone, and you know, just enlarge the display so you can see it that way. Any other questions? Aha.
Hi, Mike G for CDF.
Yes, Mike.
You mentioned operating QRP from portable sites almost exclusively.
Yeah.
How about from home?
That's all I operate from home. QRP for me is 100%.
Yeah.
So my antenna, I have one antenna at home. It's an 80-meter off-center fed dipole.
Right.
It's at about 10 meters above the deck, and that's what I run exclusively. So I only ever run wire antennas. Portable for me is an opportunity to reduce the noise level.
Yeah, yeah.
The background noise. I live in suburbia, as many of us do. We don't have acres of fields. So reducing the noise level is what going portable. That's really probably why I started.
And you mentioned batteries. One thing that occurred to me is, could you use the sort of batteries that you get on Bosch power tools for this sort of thing? With a regulator?
You can do. In fact, it's pretty inexpensive to buy a buck converter that will take it from whatever those are to the voltages that you use. So on my my solar-powered shack, I have a buck converter on my lithium batteries, my lithium bipolar batteries there, and that will keep it at 13.8 volts, whether or not the batteries start at about 13.5 and go down over time.
I was thinking of the 18-volt ones that you get on Bosch power
no
tools,
problem at all.
They would be good for this.
Yeah, they'd be good for that. And there are a few, I noticed on eBay, there are a few adapters now where you can use them to plug your hand tool battery on and get the 12 volts out. So, yes, there's many ways to do that.
Hello, Dick, G3WRJ. You mentioned using your iPhone for the thing. How do you find the practicalities of logging QSOs on an iPhone screen when you're out in the field in sunlight and things like that?
Absolutely useless.
Yeah, that's...
Which is why I always use paper for my logging.
I do as well. That was what I was going to say, and then I have to transcribe it all when I get back to the shack.
Yeah. No, absolutely useless.
I just thought you might have cottoned on to something.
No, there are no miracles here, I'm afraid. It's, sun and weather and size and eyesight, all of things conspire against you.
Thank you.
And the older you get, the more they conspire against you.
Exactly, yeah. Thank you.
There's one over there.
Keeping you exercised.
Getting my steps in.
Marek M0JUR. So you've kind of mentioned that you're aiming at the less strenuous side of portable QRP, but maybe you do have some sort of tips of what would you go for really the people who do want to do SOTA and stuff like that to minimize the weight.
Okay. So this mast is probably the heaviest bit of my portable kit. It's not very heavy, but neither is it featherweight. It's strong, it's robust. They always fall down, masts. That's the other thing I would say to them. So if you have a weak and feeble mast, you'll probably break the ends off it. So having a robust mast is quite a good thing. So a mast, they do a carbon fiber version of this thing, which is a lot less heavy. You need to make sure, though, that you're not putting a radiating wire up the carbon fiber mast. Otherwise, you'll get coupling between the wire and the mast. You'll get a hot mast and no RF chucked out. But they're fine if you're just going to hold a point or you're going to run coax up the mast. So that's quite a heavy piece of kit. This is my lightest piece of portable kit, 3-band transceiver, Morse code only, of course. And this I can run all day with a little PP3 battery. And I bought a bunch of rechargeable PP3 batteries now. So you can put one of those in your pocket, and four PP3 batteries about the same size as one of those, and they weigh absolutely nothing. So you can do all of that. Other things you can do to make your kit lighter. So this is an end-fed half-wave with a standard kind of hookup wire. And the heaviest part of this is the wire, often the case. So you can run much more expensive, but much lower gauge wire to take the weight of these things down. If you are operating, summits on the air, you want as little weight as you possibly can. I did take out what I thought was a lightweight rig until I got 2/3 up the flipping hill, and I thought, this isn't a lightweight rig at all. I shan't be bringing this again. So weight is really, really important. This one has a dedicated unun with it, but actually this is a little end-fed half-wave tuner that you can use with any length of wire and resonate it. It's got a little VSWR bridge built into it. This is from Kanga Electronics. They've recently kind of rejuvenated themselves. And this is a lighter combination than a dedicated unun. So there are many ways, and of course, if you're going to run digital modes, then the lightest pie you can get is this fella, the 02W. The 02W has enough puff to do pretty much all you need in terms of amateur radio programs, and all of the builder pie, Jason's builder pie will run quite happily on a 02W. So weight is everything.
Thank you.
You're welcome.
Any final questions?
Run.
Where was the hand?
Lost the hand.
Brian, Mike 0 Oscar Yankee Golf. Have you ever actually used your kit from the seafront at any point? From the beach?
Yeah, I have. I have a favourite beach antenna, which I haven't illustrated today, but it's a vertical dipole. It's a little portable vertical dipole, and it's all bands, all HF bands, and with this fella, this is a 40-metre QRP rig that a kit from QRP Labs, around about 60, 70 pounds, something like that for this. So with this and that dipole, done Australia, done New Zealand, you get tremendous gain from being on the beach next to the sea. But also, you don't want to drop your rig into the sea. Seawater and rigs don't mix.
No. And have you tried, you've used the dipole there.
Yeah.
Quarter wave vertical with a ground tuning unit.
Yep, absolutely. I've quarter wave, the Parks on the Air there was a quarter wave vertical based on the QRP guys. This is a 3-band tuning unit with, you just basically put a piece of 17-foot vertical wire on there, up a pole of some sort, and there you've got a 3-band vertical with switched bands. I've got a couple of these, rewound them for different bands, so the one I was using on the video was for 20, 15 and 10. This one's for 40, 30 and 20. But again, very lightweight, and this one actually incorporates its own wire winder. So that's your complete antenna. Lightweight, you just need your coax to connect to your rig from that. So there are many ways that you can do that, absolutely.
Thank you.
I'd just say that with vertical antennas, don't forget the radials. Have more than 4, please. 4 is not a wonderful number. Have more than 4, and you will be happier.
Lovely. I'm going to bring it to a hold there. Thanks very much, ladies and gentlemen. Thank you very much to Bruce for a fantastic talk on QRP. If you have any final questions, do please come up and talk to Bruce afterwards.
Absolutely.
And we'll be back here in half an hour with a talk about radio astronomy. Thank you, Bruce.
You're welcome. Thank you, gentlemen.
Hello and welcome from the Special Interest Group, or SIGRUM as we call it here. We're downstairs, just a few metres away from our live stream studio upstairs, but we've got lots of interesting people to talk to in the next break before we go to our next talk. And with me first is Kathy. I've got to get your call sign right. Kathy, I'm going to read your badge. G1GQJ, and you're from the RayNet team.
Yes, I'm chairman of RayNet UK. And have been for quite some time. RayNet is a group of about 1,600 radio amateurs and shortwave listeners that are based throughout the UK who help with emergency communications.
So how do people get involved then? If you're a radio amateur at the moment and you like to get out and about, or you want to help people, how would they get involved?
Well, we have a website where you can do a joining inquiry. It's www.raynet-uk.net, and you can go on there, put in an inquiry, and we'll put you in touch with your local group.
I think a lot of people watching may think that, is there such a need for RayNet now with modern communications, with cell phones and things like that? Is that still relevant?
Oh, absolutely, particularly mobile communications. We only need adverse weather and your mobile communications will either become overloaded or just not work at all. Very few mobile phone masts have battery backup, and if they do, it's extremely limited. So it may only last for 24 hours, but if that use goes up, it could be even less.
So how does RayNet get involved? Is it just in emergencies when there's a real emergency of flooding or something like that? Or how else do you get involved with the community?
Well, most of our events are community events, so it's providing communications for fun runs, cycle rides, all sorts of things. We do a big event every year at the end of May, which is called the LDWA 100, and that next year will be in East Anglia. So we're looking for hundreds of operators to go out for 48 hours effectively in shifts to cover the communications for that.
Literally hundreds of operators you need for that?
Oh yes. When you think of a big control room and you can only work a limited number of hours, plus 20 or 30 odd checkpoints, it's a massive operation.
Is it just traditional radio that you use, analog radio, FM, the sort of thing we'd be used to at 2 meters or something? Or do you embrace some of the more modern technologies which use things like GPS, for example, with APRS?
Yes, we use APRS quite a bit. We used to be involved with what was called the Tour of Mull, and we used to track all the course vehicles on APRS over the island, and also we use DMR. RayNet has its own DMR server where we can have talk groups for every group that needs it and use that.
And it's still independent from the main infrastructure of cell phones and things like that?
Absolutely. That's our main reason for being in place. We have a completely neutral infrastructure. We can set up our own.
Now, thankfully, we don't have too many big emergencies in this country, but of course we're all aware of the extremes of weather, the way that's changing. Have you seen the activity with RayNet with real emergencies take off in the recent years?
Most certainly. A lot of our work is actually with local resilience forums who have to plan for extreme weather, particularly flooding. I mean, we've seen what's happened in Florida and also the beginning of this week in Bosnia, where we ask amateurs just to steer clear of those frequencies that are in use, particularly in HF, in use for emergency communications. So yes, we are particularly infrastructure independent, and the best thing is we offer interoperability. A lot of our voluntary agencies have their own radio communications, but they can't actually talk to each other. So that's where RayNet steps in.
All right, well, it's lovely. Thank you very much for talking to us today, Kathy. And if you would like to get involved with your local group, look at the website. I think we can put that up for you now. And the group's most parts of the country, I guess?
Yes, all over the UK. In fact, our AGM is going to be for the first time in Northern Ireland in a fortnight's time. So we look forward to meeting the Irish amateurs over there.
And I think you're live streaming it to members who are in the UK who can't make it over to Northern Ireland as well.
Yes, that's absolutely correct.
Kathy, thanks very much for today. Thank you. Now we're going to meet, I'm sorry to interrupt, Don Field from CDXC.
Let me come round there.
Hello, Don. That would be nice. Thank you, Don.
Next to you, David.
Good to see you. So tell us again, we've got viewers who maybe don't know what CDXC does. What do they do?
Indeed. Well, I mean, CDXC goes back a long way to the 80s when it was the Chiltern DX Club. We were a group of people living in the Chilterns area who talked to each other on 144525 saying there's DX on 20 metres or whatever. But as life moved on and technology moved on, the internet came along, we were able to extend our membership base, and now we're an international club, DX Club, mainly UK based, but we have members all over. And we are there not just to encourage DXing and support DXs, but to support DXpeditions. So a lot of our income these days goes towards helping to fund DXpeditions, which have become increasingly expensive over the years, just with travel and so on.
Okay, we're going to put up the website as well for CDXC, so people can see it right now. Yeah. How do people get involved, and what could they expect if they join CDXC today?
Yeah, they get our magazine 4 times a year, which is very, very good. It has DXpedition reports, it has technical articles and so on. As I say, they can feel they're contributing to DXing insofar as they're contributing to DXpeditions. We have an annual AGM and convention, which they're very welcome to attend and have talks and so expedition talks. So all of that. So it's a social. We try and make it a social event, a social organisation as well. But it's more difficult now that we're international. But as I say, we do have an annual get together. We can zoom in people who are overseas members. But a lot of it is just to feel that you're part of the big DXpedition fraternity. I was going to say we've organised expeditions in the past. We have and we haven't, insofar as the big 5-star expeditions were spawned by Chiltern DX Club, but we eventually made them independent just so that, because the financials of those, we didn't want them to impact on the club. But everybody who went on them was a CDXC member.
And what are we got looking forward to next? What are the next big DXpeditions that we need to look out for?
Oh, well, we're now in an era where there's a lot of DXpeditions coming up. In fact, our funding of expeditions has gone up a lot in the last year or so. Why is that? Because the sunspots have come back. And people are taking advantage of that to go off to remote spots and operate on HF. So what have we got coming up? Oh, yeah. Very good question. I can't even remember all the ones that are coming. No. There's going to be another attempt at Bouvet Island in a year or two, and they're going out to Peter the First Island again. But lots of much more mundane ones. I mean, we support some of the islands on the air expeditions as well. We have had applications in for a number of African countries. I'm trying to think. We've got Andaman Islands coming up. As I say, there's a whole lot in the pipeline at the moment. In fact, Chris, our chairman, just this last week sent out to the committee applications from 5 different expedition groups who are planning, and that's literally just in the past week.
So you're very busy.
So we're actually quite busy at the moment, yeah.
Now, I can't leave you without talking about with your other hat on, or one of your other hats on.
One of my other hats, I'm sure.
As editor of Practical Wireless. Yes. I want to just ask you how that's going. Because, I mean, we're seeing challenges with print journalism nowadays. Yeah. Everybody is, with newspapers and things sort of disappearing and contracting. Are you seeing sales of Practical Wireless still strong? Readership still strong?
Yeah, readership is strong. I've been editor for 12 years now. I don't know where the time has gone. But yes, readership increased during lockdown, of course, because people were coming back into the hobby or taking up the hobby. And it's holding up nicely. I mean, one of the biggest problems, to be honest, that we've had, well, 2 problems we've had in the last year or 2. One is the increasing cost of paper, and that's largely due to the Russian invasion of Ukraine, because a lot of the timber used to come from Russia, I gather, for making paper. But anyway, I mean, certainly paper costs have gone through the roof. And the other one is we have lost advertising as the number of traders has reduced. You know, now Moonraker have absorbed Nevada, for example. But we remain viable, and which I'm delighted to say we do, because CQ magazine in the States has failed. We are one of the few independent amateur radio magazines that's still surviving.
And it's important to support.
I mean,
and there's nothing more portable than a magazine, and I'm into technology as much as anybody else, but you can't beat a magazine to take on a plane or, you know, wherever that is, or whether it's an island that you're working or whatever. There's nothing to beat it.
No, I agree. I mean, Warners, who've owned us for the last few years, do have the capability to do an electronic version, and they do. As of all their range of magazines, but a lot of people still prefer to have a physical magazine, and I hope that will remain for a number of years to come. And I personally would love to see it still on the shelf of every W.H. Smith's, because then the public know that we're still going and or at least have some visibility of the hobby. But to be honest, I mean, now that Smiths no longer do sale or return, if they don't sell it, it gets pulped. That's a difficult way of an expensive way of distributing. So if you do want a physical copy, to be perfectly frank, I would recommend subscribing to it, and then it'll come through.
You're not going to find it on the
because you may not find it at your local
Radcom first, of course, but then Practical Wireless.
Sorry, Radcom. Magazine.
Yeah, Radcom.
Radcom. No. I mean, you know, people say to the Radcom editor, you know, do you consider Practical Wireless your competitor, or say no? We're all encouraging the hobby,
and they're different as well.
And we're different.
Thank you very much for talking.
My
to us
pleasure.
Today. Lovely to see you again. We're going to now move along, moving the camera. We're going to talk over here to this camera while Kevin moves our mobile camera, because we're going to meet the team from VMARS. I don't know much about VMARS, but we're about to find out. It's very difficult because we don't want to obviously interrupt conversations that are going on. I'll just get around this side. At least you can see how busy this room is, especially in between lectures when there's a coffee break, and this is when people have a chance to come along. We could do that, I guess, couldn't we? Should we go along? Should we move along to this? Sorry, back to the camera. Is it all right if I come to talk to you now? Is that all right? I'm sorry about this, but this is live. As you say, you're talking to live streamers from wherever. Let me turn around and get the microphone. All right, good to meet you both. Mark. So, sorry, we'll go this way, I think. Okay. Right, we've got Mark Savage, M0XIC, and you're from?
Well, I'm from 145 Alive. I organise 145 Alive together with John.
Alexander, M0XJA.
Good to meet you. Sorry I didn't have time to talk to you before we actually went on air. Now, 145 Alive, I've heard of it, but what about for people who haven't heard of it? What's it about? What's it for?
So 145 Alive, I guess, is to generate interest in 145 FM simplex, sorry. Everyone, you know, you listen to says, oh, 145's dead. It's a dead band. So we have taken on board 145 Alive. It's 3 or 4 events a year, and it generates somewhere in the region of 1,500 QSOs in a 2-hour period on 145 FM simplex. Probably about 300 operators involved, and essentially it's 50 nets running simultaneously at the same time in every Maidenhead locator in the UK. So that's all of England, all of Wales, all of Scotland, all of Ireland, all simultaneously operating as a net, all voluntary. Everyone self-selects as a net controller. We don't choose anybody. Everyone self-selects as an operator calling in. We coordinate it all. John allocates some frequencies to keep them apart from interfering with each other, and we let it run. And we're like a defibrillator for 145 FM. We give it a burst of energy, and then we hope it'll go from there. And from it, we've had spin-offs like 433 Alive and other groups doing other things to get activity on 145 FM.
So John, is this the idea of this, really, to keep the bands alive, to keep our bands? Ofcom have got to hear us using the bands. Is that the main thing that drove you to do this?
Very much so, yes. So coming from, we actually run a net, and we come in and, with great enthusiasm when it was opportunity to take over the 145 group. So yeah, the main thing is to actually encourage people to come out there, and we've had people who have had their radio since the 80s. Right, and they were really enthusiastic, and they said like, oh yeah, I had my radio, 1980s vintage, 90s vintage, whatever, right, and I've fallen out of love with radio, but I was so enthused, I went out there, got my setup, and come back in. Right, and same with M7s, you know. So
I was going to say for beginners, of course, most beginners. Let's be honest, they start. They don't want to spend thousands of pounds initially. They're going to buy a cheap radio, maybe £50-100 for an FM radio. So this is a great way to get to know what you could do with 2 meters, isn't it?
Absolutely, and one of the main things is to say we've had the long-standing absentees coming in, and also conversely the new foundations coming in. Right, and there's lots of momentum and enthusiasm from these people, right? And it's really good to we're enjoying running the actual organisation, right? And we're open to actually improve it and go on forwards.
Yeah, now, Mark, you mentioned I think there was just 3 events a year. Is there a thought of maybe increasing that?
Next year, I've just announced actually yesterday, there's going to be 4 events in 2025. The first event will be the 26th of January 2025. Second event will be in April 25, date to be confirmed, following on July 25, and then the following October 25. The subsequent dates will be confirmed, but the first one in 2025 is Sunday, the 26th of January 2025.
How do people find out more? I think we can put your website up now on the bottom of people's screens, but how do people actually get involved with it? Who do they talk to in their local area?
Well, they don't need to talk to anybody in the local area, really. They need to log on to the Facebook page. It's exclusively delivered via a Facebook page. 145 Alive Facebook group. It's got 3,500 members of that group, and they need to join that group, and everything is communicated through that group. If they want to be a net controller, they just put on there, I would like to be a net controller. We'll pick it up and we'll get back in touch with them. If they want to take part, that's what they want to do. What we want to do, would like to do for 2025 is get a few more clubs involved. Put a club station on the day of 145 Alive, run a net, but run a net as a club. So you may have members who are a bit mic shy, a little bit, they don't want to do a contest. This isn't a contest. There's no tables produced. There's no awards to collect. You can access it easily. As you said, simple equipment, get out there, have a go. It's all about participation. But we'd like a few clubs, more clubs. We have had clubs. We'd like a few clubs. Say, we got 6 members, put them all together. The mic shy, the returners, the newbies, they can all have a little go, and then someone else can take it over.
Well, I wish it all well. It's really important that we all want to keep all the bands that we've had for years, and this is a great way of doing it. Well done to both of you, Mark and John. Thanks very much for joining us. We've just got time now, I think, to go along and hopefully meet VMARS. And I'll see. It's not nice to interrupt conversations, but hopefully they might allow me just to break in to here. So. Excuse me, gentlemen. Could I just? I'm so sorry. We're on a live stream at the moment, but we just want a few minutes, if that's all right. Do excuse us, Martin. Good to meet you. I'm from the live stream, as you know. You're live on our live stream now. Must be careful of that. Do tell us a bit, firstly, about VMARS.
Well, VMARS is an organisation of which there are 600 members worldwide, about 90% of them in the UK, but we also have members in the US, Australia, and also around the world. And we're basically an organisation that's interested in the history, development, and what have you, of radio and electronic equipment of all sorts. So we're a society where we have members who are interested in radar and its development, and other electronic stuff like mine detectors, for example. mainly communications stuff, and we're interested in preserving, if you like, the electronics heritage, should we say, from all sources, both from the UK, America, and what have you. So it's really formed of people who are interested in radio from the very basics of, if you like, transmission line theory to SDR and software defined.
So some of the more modern equipment as well.
Yes, very much so. So although we're called the Vintage and Military Amateur Radio Society, we're actually our members are interested in everything from the very basics, very old stuff, and right up to modern, software defined radio.
How easy is it then to maintain, especially some of these older radios? Particularly, there's a feeling for me as not knowing much about this, that the sort of technology and components for military equipment is always much more superior and rather unusual. So is it easy to get those parts now?
It is. It's surprisingly easy. I mean, some of the equipment, of course, is valves, and there are massive stocks of valves in the world still. Some of the military stuff does have bespoke semiconductors in, and they can be a problem. However, there are ways round, if you like, trying to get hold of hard to get, if you like, semiconductors. There's always a way round, if you like. So basically, all the military stuff can be kept going. It is as simple as that.
It's good to hear. Now, we're going to put up your website on our screen at the moment, which people at home will be able to see. This is the first time you've attended the convention.
It is, yes.
So how's it been?
Yeah, it's been very good, actually. There's been a lot of interest from, obviously, people here, if you like, nominally for the RSGB event. But there was a lot of interest. I must say, I haven't actually I counted up how many people we've been talking to, but we spent all day yesterday, if you like, telling people all about VMARS and what there was, and so what the interest, if you like, what the interest was in VMARS and how it's a very broad church, if you like.
So you've got people, and how do they get involved? Can they join? Is it an organisation that they join?
Yes, they can join, and they can. If you go to vmars.org.
Well, I think we've got the web address as well. We've had other address on there. And what do they get if they join? Just very briefly.
What they get? They get two
these magazines a year?
Two copies of our journal.
Lovely.
Past copies of our journal, which is a very interesting.
Lovely. We've got to go now because we're going to go to another lecture. Lovely to meet you. Thanks very much. We're now going to go to our next lecture of the day, which is about astronomy.
And welcome back to the RSGB Convention 2024 here in Lecture Room 2 for our second talk of the day. And this one sounds interesting, if only by the headline of dark matter from your gardens, which sounds particularly interesting to me. Our speaker this morning is Dr. Andrew Thornett, who is a general medical practitioner in Birmingham with an eclectic interest, at least that's what it says here. He has a passion for all things astronomy. He is a member of the BAA Radio Astronomy Group and the Society of Amateur Radio Astronomers in the US, and of Wollaston Astronomy Group in Derbyshire, as well as the Astronomical Society of Penang in Malaysia. That's quite the list of accreditations. Our speaker this morning, Dr. Andrew Martyn Thornett.
Well, welcome, and thank you very much for inviting me. Let's just see if this clicker works. It does. Look at that. Wow. Does it go back? No, it doesn't go back. No, goes forward. Oh, look at that. Wonderful, wonderful. I might have to resort back to the computer. Anyway, it's nice to see the people who were sat at the table I was at last night. So clearly what I said about the talk today encourage you to come up. I'll live up to expectations. Thank you very much. I had a call from the RSGB that said, somebody went to the International Astronomy Show and heard your talk and came and said how wonderful it was. So a bit like the speaker last night, it's a question of trying to live up to what people expect. And the other thing is I did wonder whether it would just be me and one other, given that this wasn't the main part of today. But still, thank you very much for all making the effort to come, and I hope I will excite you. I have noticed that one of the things that radio competitions tend to do is to see how far you can actually send messages, or at least listen to the people. Well, you do a few hundred or a few thousand kilometres. Today we're going to try and pick up messages, I don't know, 10, 20,000 light years away. So perhaps I'd like you to extend a little bit your boundaries to see whether you can something a bit more than you do at the moment. Okay, right. So now, this was working a second ago, wasn't it? There we are. Right. So you probably all noticed there was an aurora on Thursday night. I've never actually come across anybody else before complaining about a just to put it in perspective. When it occurred back in May, you can actually see this aurora. You can actually see the corona overhead, which is the crown, which is what people go up to Norway and Tromsø and have a look and come back excited about. Normally you can see the aurora sometimes from the UK, from northern Scotland, but you just see it up on the northern horizon and you see a green sheen because it's further north of you, right up there. Whereas this one's been right overhead. So we were trying to work out in my astronomy group when the last time it occurred like this. About 20 years ago there was something like this. So I was trying to work out when the last time it occurred twice in 4 months. And I don't think it's ever occurred in living memory. So, get it to change a little bit, maybe your perspective. Maybe it did disturb your radio work, but it was at least a one-off and rather miracle. If you saw it, it was rather unusual. If you didn't see it, these are different. Turn a couple of these lights off. Turn a couple of these lights off. So these are a couple of pictures from my backyard, just taken on my phone. So I thought that's quite incredible.
Sorry, going for
turn it back on again. There we are, brilliant, right. And of course, this is a radio conference. So this is. I know some of you send signals using ionospheric methods. I have a monitor which monitors the state of the ionosphere at very low frequency, 23.4 kilohertz. It's not what today's talk is about at all, but there was this aurora last Thursday. This isn't actually from Thursday. This is from very recently, because we're extremely active on the sun at the moment. And there was 2 or 3 weeks ago a massive X-class flare on the sun. And that's what that circle shows. Just take it from me. That's what that is. It's what's called a southern ionosphere. It's a typical shark fin pattern, depolarization. You're going to ask me why the rest of it aren't SIDS. For what it's worth, that's a standard morning move. But anyway, these are actually nuclear submarine communications. And the other thing I do is monitor meteors. So this is from Graves, which I know again some of you do meteor scatter communications. I'm not actually. I as you saw there, I do have a call sign, but I'm not active in terms of transmitting, but do more listening. So when it comes to meteors, I'm recording numbers and meteor profiles. So this is Spectrum Lab showing a 3D waterfall plot. And as you can see there, so not waterfall, sorry, 3D plot, sorry. It all, because it's a scatter, it's all in the same frequency, and this line is just showing you where it is on the chart. This is frequency here, this is time, and obviously amplitude up on the y-axis. And you've got a typical meteor there coming through. So that shows where you'd expect it. And then on the right-hand side plot, that's the only meteor that was picked up while that fuzzy stuff was visible on the left-hand side. That's during, and that appeared during the height of the auroral display. So that's actually the auroral being picked up on the radio there. It isn't the carrier, because the carrier would come directly where the meteor is, and it usually comes as a very narrow line. And I do occasionally pick the carrier up, though technically you're not supposed to, but depending on the state of the atmosphere, you sometimes can pick it up. Completely ruins your meteor recording when it does come. So, okay, I was very pleased to be able to record the aurora, a very unusual situation. Anyway, that's not what we're here to talk about today. So instead we're going to talk about hydrogen line observing. This is, that's my shack there, which is my log cabin at the bottom of the garden. A little bit of snow and some nice aerials, and a desperate attempt, unsuccessfully, to do some interferometry. So hydrogen's 21 centimetres, which is 1,420.405 megahertz. That's my website if you want to see any of this stuff and follow it up at all. And it's a project that I really, if you've never tried it and you want to do something a bit different, I would really encourage you to have a go at it. Incredibly robust. You probably spend thousands of pounds on your rigs. This is just incredibly cheap. You'll see about £200 you can get this done. Right. So about the new amateur radio astronomy. I was talking to the bunch we sat with last night, and I was explaining what I mean by that. I first explain, I am Dr. Andrew Thornett, but that's nothing to do with physics or engineering or radio or astrophysics or anything like that whatsoever. So it's a medical doctorate. And my understanding of any of this stuff is to say non-existent would be lying, but to say it's good would also probably be incorrect. I proudly a new type of radio amateur, which is, I'm a bit like the same as my call sign there. It's a foundation radio exam that I've done. That means that I'm entitled to use a radio, bought commercially. I'm not allowed to make one. I can make one to listen to my stuff, but I can't transmit with one. And it says my knowledge is limited. And the same goes for radio astronomy. And we've moved into the world now where you do not need to have a massively detailed understanding in order to have a great deal of success and a great deal of fun. And that, I think, has completely revolutionized the situation. It used to be that the only people who could understand this stuff were people who were essentially communications engineers in a former life, who were coming back to it. And 15 years ago, when I tried to have a go at it, that's what happened. I hit a brick wall. People would try to explain it to me, but I couldn't understand what was going on. But now we have a new breed of people in the media who were communications engineers, but can actually talk to people, an unusual situation, communications engineer, plus being able to speak to the general public. And I'm coming along as a new bunch who's probably quite good at communicating, but without much in the way of knowledge. But my job is to try and encourage, motivate, and actually take it to the next stage, because there's both equipment and software that's out there that means you don't need to have that detailed knowledge, and that's the difference. Same as for radio communication. So just to put it in perspective, I live right in the centre of Lichfield, which is about 30,000 people, but it's in an area in the centre of the UK with about 10 million people, and the Black Country in the West Midlands. We have loads and loads of RFI, 400 metres from major supermarket. I mean, masses and masses of houses being built around our area. I don't have a great big field or anything like that, and yet this works like anything. Right, so we're going to try and map the Milky Way is what we're going to do. Okay, right. So I put these images in for predominantly for astronomers, because astronomers like to take pictures of, and if any of you have been out with a camera or anything, it's just nice to take a picture of the night sky. But when you take a picture from Earth and you're looking out with a camera, obviously, you collect the photons that hit it, and they come from whatever's in the way. And so if there are stars, or as you can see there, large clouds of dust and gas, and they're producing light, which comes and hits your camera, but you can't see what's behind those clouds. or those stars. And that's the major problem with any method of trying to photograph the Milky Way. It doesn't matter whether you've got the 10-meter Keck telescope or even the Hubble Space Telescope. You are limited by the fact that this stuff in the way. I mean that's what makes the James Webb, one of the things that makes it so exciting is it uses infrared, which can actually, to some extent, peer through the dust, which is why professional astronomers are so excited about it. But by the way, if you think the professional astronomers understand all this kit as well, actually they don't either. They hire people who understand all the technology, and they themselves apply for grants and do the actual research bit. But anyway, so that was a professional picture. But just to show you the limitations of taking a picture. So what we really want is, you want to be able to understand the Milky Way. You want to be able to take a picture as if you're outside of it, looking down on it, a bit like a CT scan. So if you take an X-ray, it takes you from one side and you look straight through. But to take a CT scan, you can reconstruct the picture as if you're from the top looking down or from a different perspective. And by doing that, you can actually be able to see the spiral arms or work out the spiral arm structure. And other bits. So a bit like that. So there we are. So it's obviously from my my own industry, as it were. Here's a CT scan of the abdomen, so the actual scanner will have been on the outside, but it's reconstructed the picture as if you're from the top down, which is where the scanner was not. And again, it's a professional picture here, but doing the same thing. So you can see that by doing that, you can create a picture of the Milky Way, and then you can reconstruct where the arms are. And the question is, can we do that from our backyards? And the answer is absolutely yes, you can. And it's something that I have done, and I'll show you in a bit. Gain a bit more professional pictures. And we're going to use hydrogen. Now, hydrogen's interesting. It's a 21 centimeter line. So you only get a photon of light. It's an electron transition. And this particular electron transition's only, it's a hydrogen alpha, is only produced about 1 in a million hydrogen atoms will do this. But the reason that you can pick it up is because there's an awful lot of hydrogen. It is the major constituent of the Milky Way. It's the major constituent of stars. For that matter, it's the major constituent of pretty much everything. And so consequently, that's why people tend to go for it. Therefore, we can use it. The other thing that you can pick up with hydrogen is Doppler shift and movement, from which you can make all sorts of interpretations. So you all understand Doppler, so don't bother with that. That's for astronomers. But just in case for anybody who doesn't, it's this basic idea that if you get, it's like if you stood on the typical one is if you're at a railway station and you stood on the platform and a train comes past you, as it comes towards you, the sound gets higher and higher and higher, and then when suddenly the train goes past you and it goes, and that's because the frequency has suddenly gone from high down to low as soon as it went past you. And that's because as the train, or in this case the car here, is coming towards you, the sound waves get crushed together, and so it actually reduces the internodal distance, so it increases the frequency, lowers the wavelength, whereas when it gets past you, it's going away from you, it stretches the waves out because of relative velocity, and consequently lowers the frequency, increases the wavelength. The same thing happens with light, except you don't get a sort of a change in high to low sound. Instead, what you do get a change in color. So we call it red shifted and blue shifted. I forget whether that's still in here on this picture. Ah, yes, here it is. So this is just a spectrum of light. If you don't understand it, don't worry too much about it. But you get these black lines in any spectrum of a star. And you can tell which sort of chemicals these come from, and then you can tell where they're supposed to be and where they actually are. In this particular case, it's the same chemical. At the top is where it should be. The next one is sort of red shifted. You can see the lines have been moved towards the red side of that spectrum, and down the bottom, they've been moved towards the blue side of the spectrum. And again, that is because of relative velocities between us and whatever lump of hydrogen that was that it was being recorded from. It's why they make such a fuss about putting spectrometers on every new space mission that goes out, because they're so powerful. Okay, so professional images. So this shows something else. It's professional images. So these are velocity or recordings as calculated from Doppler shifts. And you can see here that if you take from the center of the Milky Way in the middle there, or any galaxy, and you go further out, you can see that you're actually getting different velocities at different distances out from the center of a galaxy. You know, an actual sort of cloud of hydrogen might be moving at a relatively different speed, even to one quite close to it. Okay, right. So let's move on to what we're going to use to try and do this project. How are we doing for time? Oh, we're okay. 9:45. Right, so again, as I say, I tried this, well, not this particular project, but radio astronomy about 15 years ago. And at that time, I bought an ICOM or R7000. Anybody here got an R7000 or had one? Look, most of you look like they don't even know what one is. I mean, it's quite a famous receiver, and used to be the workhorse of amateur radio astronomy. So I bought this second hand off eBay for £200 and thought I'd done quite well at that time. But what's completely changed everything now is software-defined radios. So, you know, these tiny little dongles, the size of a USB dongle. They cost you about 30 quid, don't they, off Amazon? It's amazing. I mean, I've got a Yaesu FT817 at home, and so that cost me £500 second hand. And I've got a £30 dongle that outperforms the Yaesu. Absolutely. You can see it because the noise floor is better. It's much more stable, far less variation. And that's important when it comes to picking up weak signals, the radio astronomy, because you want to be able to distinguish the signal from the background, and that's what really matters. And so variation in the background signal is really important. Okay, the Yaesu is quite convenient, and I can transmit on it and whatever, but for radio astronomy, the SDR beats it hands down. The other thing is that you need some method of filtering out these signals, mainly to get rid of the crap that's there from RFI. And somebody else here at this conference mentioned to me, he's been trying to do the same thing. I said, oh yes, I got one of these Noel low noise amplifier / filters. And that, again, is something that's revolutionized it. A firm called Noel, which is Canadian, and they've produced another dongle again called the Noel Sawbird H1, which is 40 or 50 pounds. And again, that's absolutely changed everything. You pop it off Amazon for 40 or 50 pounds, and it's got a very good amplifier in it. It takes it about 30 dB or 40 dB either side of the hydrogen line, plus or minus about 30. It's about 30 megahertz. Is it 30 megahertz? No, I can't remember exactly. It can't be 30 megahertz. Yeah, it must be 30 megahertz, I think. Yeah, 30 megahertz. Yeah, and it's also got a dual cascaded amplifier in it as well, so you don't even need a separate amplifier on it. So that's changed everything. When it comes to aerials, you see in a second, everything's much more flexible. And when it comes to some sort of computing power to run it, any old thing works, as long as whatever you've got hanging around. So, as mentioned at the beginning, I'm a member of the British Astronomical Association's Radio Astronomy Group, but there's an American equivalent called the Society of Amateur Radio Observers, and they've set a project called Scope in the Box. And Scope in the Box tells you exactly what to do with this project. And very importantly, they have an extremely good manual. Very well written in layman's language, which just walks you through the whole process of setting this up. Or if anybody wants to do this and wants some help from me, I'd be very happy to do so. So that's the receiver and the NNA. Aerials wise, we've got well, everybody'd like one of these 3-meter dishes. Not very common in the UK. The Americans seem to pick them up 10 a penny. They seem to be all over the place there, but here, I mean, you don't actually need one. And they're very difficult to mount and move anyway. Plus your wife tends to complain. This is much more practical. So these are a grid antenna. So again, Neolect produced one of these, which you can see up the top right-hand corner. But I mean, there are various manufacturers that produce them. They actually produced one that's tuned directly to the 21 centimetre line deliberately for this purpose. But you can use a 2.4 metre, sorry, 2.4 metre, 2.4 megahertz, sorry, 1.2, I'm getting confused now. Oh, low, 1.4 kilohertz, sorry, 2.4 gigahertz, sorry. Grid antenna will work reasonably well for this. Sorry, forgive me, like bunkers here. So that one comes in at about a metre on the long axis and 60 centimetres on the shorter axis. As you tend to collect the data with drift scans, which means you point it and direct this particular elevation, and then the software, which has been written by a friend of mine called Ted Klein in the States, brilliant, completely free, does it all for you. It actually will pick the data up over a 24-hour period and convert it into a data file for you, all the data points. So as long as you align that east to west on the long axis, you actually get the resolution of the 1 metre axis on that. So it doesn't matter that it's a bit of a segment of the aerial. Again, it's a grid antenna. Again, that doesn't matter. 21 centimetres, that grid is not going to affect the collection through that antenna. I guess if you're trying to do 10 gigahertz, it'd be a bit of an issue. For what it's worth, the exact grid doesn't matter too much, but what does matter, I'm sure most people here will realise, is the boom and the waveguide. So you can actually get pretty much any old one and make yourself a waveguide to go on it. That's just the orientation. One warning, if you do buy one of these commercial ones, they're a bit fragile. Mine got blown over in the wind. So a bit of a Heath Robinson job trying to put it back together again. So do make sure you attach it firmly to the ground. Right, there are alternatives. You don't have to use a 140 pound commercial one. So this is a tin can. This actually works, believe it or not. So not terribly well, but it does work, and you can collect hydrogen with it. So this is a coffee tin, one of those sort of commercial ones. So it's about 15 centimetres across diameter at the top. The bit that matters is the length of the probe at the bottom. The bottom of the probe. That's a paper clip, straightened out and cut to 49 millimetres, and soldered onto the end of it. And then the distance from the bottom is what counts. But the point I'm making is there are various ways of doing things. And just to show, that's maybe not a particularly wonderful signal, but that is actually hydrogen that's being picked up at the bottom. Other things? So people, sorry about the resolution on this. People have made nice little antennae with sort of disc Yagis. And you can go mad with some chicken wire if you want something nice and big with a corner reflector. You don't have to necessarily have one that size, but that's somebody going bonkers. On the other hand, if you've got an old parasol at home, no. So somebody trying to get their 3-meter dish the cheap way. And that's my baby. So that's actually which I'd recommend these, but they're rare as hen's teeth, as Tarmac and Triffid Band 3. It's made a 4x4 dipole array there, so that covers the 1420. Works really well, corner reflector design, but again, you know, I've never seen them anywhere else. Difficult to recommend it when you can't get hold of it. But if you know any spare going around, I would like a second one. But they are, so that's 86 by 86 centimetres. But just to say, you don't need that. It performs about the same level as a 1 metre dish, which is basically anything 1 metre in size, essentially, is what that's performing as. It's got one great advantage when I put it up. My wife was okay with the look of it, so that's quite important. So I said about how to actually use it. The software, you just, as I say, it does a drift scan. So you just aim it pretty much any direction. Give the generally go for south. Well, somebody's had enough. And the software just follows over 24 hours. So, but then you change the elevation every day or two. So this is the rather complicated or rather uncomplicated mount I made for it. There's just wooden thing here. And you probably noticed at the back there's a couple of wooden struts with, I think in the picture there, well, yeah, you can see them now, with some holes in, so I can just change the elevation. We don't want anything complicated here, you know. Oh, that's just another alternative. A friend of mine, Alex Pettit, who's the aerial guru for Sarah, sent this out to me from the States. That's his latest creation. It's a plate Yagi there. And then there's this little baby, which I picked up for £50 off eBay. These are sold as solar cookers. So you can pick up in the States. They're not so readily available in the UK. You can get them off the American eBay site. You just pay about another £50 to get them delivered, or you can get them off AliExpress. Again, I was having a chat with somebody earlier on about this, and they were saying, well, how well are they made? We had a big chat about this on Sarah, and we've ended up with this conclusion, which was it doesn't matter whether there's a 1 to 2 centimetre variation across the wave surface, because you're talking about 21 centimetres. So even if you had 2 centimetres variation in the wave surface, that's still 10th Lambda in terms of the wavelength. So it's still pretty good. Okay, if you're going for 10 gigahertz, that would be problematic, but we're not. So the only real question is you try to make it some way of mounting it, and then a waveguide. Just say my wife was not so happy when she saw that had turned up. So there we are. So at the moment, that cantenna I created is being brought back into service, but this time facing in the opposite direction, now down onto the dish to act as a waveguide this time. Obviously not particularly well mounted there. It's just to get started and try it out. Okay. Everybody tends to ask me about beam width on these things, so just in case you're interested, I thought did some beam width calculations. So I don't know how many decibels you're interested in, but let's say if we took 3 decibels, then we got 14 degrees on a 1 metre dish, and down to 9.5 degrees on a 1.5 metre dish. And if you were lucky enough to have a 3 metre dish, you'd be down to 4.75 degrees. So you can see the difference that it makes. But in terms of the actual question of mapping the Milky Way, it really doesn't matter. And that's what I want to prove to you in a minute or two. Like lots of these things, you can address the question and say, how good can I get? You can ask that question and try and navel gaze. It's a hobby. You can do what you want. There's nothing wrong with that. You know, if you want to try and get the best aerial that you can, and you want to try and get the best kit and the most accurate mapping exercise you can, wonderful. But if you want to demonstrate the arms of the Milky Way, if you want to want to weigh the Milky Way, if you want to pick up dark matter, then you don't need all that detail. And the 1 metre or even anything much smaller will do the trick for you to some extent, more than some extent. So I mentioned it. That's the Sauber, the Noel one I mentioned to you. It's somewhat smaller than that, by the way. And there's just an example of a dongle. I use one of those RTL SDR blogs, not that it matters too much. When it comes to computing power, I went along to that rather fantastic Arduino workshop yesterday. That was quite marvellous. And a lot of amateur radio astronomers are using that sort of small machine for actually monitoring their computers. But that does somewhat involve having to program those computers to do it, whereas I understand Windows and they do the simple bits. So I picked up these little mini PCs, which you get them off eBay for £85 each, and you get 8 gigabytes of RAM and 256 gigabyte SSD and an i5 processor, and it does the trick very well. So I have what's called my stack there, which is a little pile of the little things. I have one running each of my radio astronomy experiments. But as I say, a lot of people just use the Pis and the Arduinos. The other problem I had when I stuck it outside, so I get this box and stick it all in. In this particular case, it's an old laptop that somebody had given me. As I say, any old thing works. So I stuck it in this box underneath the aerial the first night. When the deck data look at it, and there's this pool of water in the bottom, which is dew that's just precipitated on the inside of the box and collected at the bottom. So the white box at the top is this little 60-pound caravan dehumidifiers that you get off Amazon. I guess that produces more RFI. So I mean, I have tried coating the whole lot in silver foil, but honestly, it maps the Milky Way even without bothering. Right, one thing I did come across out of interest is some of the software runs into problems with Windows updates. There's this neat little program called Windows Update Blocker, which is fantastic. Just hit. Okay, right. So software. Okay, so how are we doing on time? Just 3 minutes past. Okay, just for what it's worth, this is actually the hydrogen signal being collected here. Okay. So there's a couple of options. So the Saroscope in the Box project recommends SDR sharp. I don't know if do you tend to use that regularly? So they've got something called the IF average plugin. I don't know if I assume that probably isn't used for what you're doing, but that allows you to collect data over a period of time and essentially stack it all together. Very, very, very neat. So that's definitely one way of doing it. Works very well. The one that they recommend. The other major alternative, I think, if I go on this page, is this one, which is the one that I'm just a massive fan of, which is my friend Ted's piece of software called Easy Radio Astronomy, which is a series of Python scripts with a collection program and a set of analysis programs, which basically does all the analysis for you. Just press a button and goes bang, 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 and 250 plots come out the bottom, literally, including mapping the Milky Way for you, demonstrating dark matter for you, weighing the Milky Way for you, and piles of others. And the issue becomes trying to understand what all these plots are about. But he's quite helpful, is old Ted. So that's what I recommend. It really requires very little understanding to use, and probably quite a lot of understanding to try and work out what's going on at the end of it. But and you don't need to understand Python, you just need to be able to run the scripts, that's all. And it's all available on GitHub just to download. So here's an example. There we are. So that's the collection program. It's worth saying that Easy Radio Astronomy will actually process the data from SDR sharp. So you can use the two together. So again, that's Easy Radio Astronomy's collection program there. The hydrogen signal there being detected. And it shows a couple of things about it. So we're on, for some reason, we're slightly off on here on its major thing. So 1420.05 basically for the main signal. But you can see there's some breadth to that signal. So that's the Doppler shift that's around the central signal. And within that is all the data that tells you about the other arms, the Milky Way, etc. On the right-hand side, you will notice that there's a blue zigzag line here. anything to do with radio astronomy, calibration is very important because you're dealing with very weak signals. So in this particular case, the program's using a rather neat way of calibration. You can stick a 50 ohm, I think I've got a picture in a second, a 50 ohm dummy load on, quite effective. But one of the big problems that happens is that as the night goes on, the temperature of the whole rig changes, and that tends to affect your signal collection as well. In this particular case, what the program's doing is it's not bothering with the dummy load. I mean, probably the best way of doing things is to have the dummy load with an ability to switch it in and out and do that on a regular basis. Here, though, it's doing a sort of proxy for that, which is every other sample, it's switching the signal from 1420 to 1423. So you don't pick up hydrogen 1423. And so that gives you that offset allows you to pick up essentially the same signal without the hydrogen and use that for calibration. And that tells you, says EZ colinteg quality there. That's the number of samples that are being integrated. So there's 31,000 samples are being basically stacked together each time. And then you've got obviously the azimuth and the elevation, tell you what we're pointing at the moment. Okay, again, that's just to show you the Doppler shift. And I mentioned about it, that's just a dummy load on there. And that's, as I say, just the 3 megahertz offset. Okay, so this is what I'm sure you're quite interested in the results. So before we get to the map, so this just shows you the data being collated on a single chart. So the background on this chart is professional data. And it shows the Milky Way at a particular projection. And the green dots are my data being collected. So each line is a different elevation. And you can see there that it peaks up each time it goes across the Milky Way. And that's putting it all together. So it's now starting to produce a map on there. And you can start to see, so there's some limitations to the way this is collected, both in terms of where we are and some difficulty in collecting data from certain parts of the Milky Way, but probably more important, something to do with the mathematics that underpin this, which limits the quadrants that you can get to. So we're mostly limited to our one particular quadrant between sort of 90 and 0 degrees there, and a bit down the second quadrant down here. But on the right-hand side, you can't really get any data out of that. But you can see here that you've got one arm, and if you look here, one very bright arm, and if you look behind it, you've got another arm that's coming out behind it. What blows my mind is that arm is behind that arm. So if you were looking out with a camera or a telescope, you wouldn't be able to see that. And here I've sort of just downloaded a picture off Wikipedia, for a sort of a commons picture of the Milky Way, just overlaid it so that you can start to get an idea of where these arms are. And I've labelled them out for you. So we've got, so the main bright one is Sagittarius. You can see we picked up the Cygnus spur at the bottom, a bit of the Perseus at the bottom. There's actually a tiny bit of the Norma outer arm at the top. And the second arm behind us is the Perseus arm. So for what it's worth, that's over 500,000 observations over 2,000 hours to generate that picture. So it's taken me about a year to get that far. Now, I mentioned before about other things that you could do with it. So again, we've got here the showing some of the different velocity measurements at different distances from the centre of the Milky Way. And importantly here, if we're here down where this this sort of icon is here down here, sort of like a rainbow, you can see our line of sight is the black line here, and you can see that depending on what you're looking at, you will see the stuff moving in different directions depending on where you're at. And so from that you can do some calculations. Now, this is also something off Wikipedia, just an idea to get for you. So when it comes to, this is about dark matter we're moving on to now. And I want you to look at the two diagrams and see if you can see the difference between the two of them. And the thing you want to notice is that the centre's moving at the same speed, but the outside on this side is moving much slower than it is on the right-hand side. Can you see that? Right, okay. So this is what you'd expect to see. Just that one more time. On the right-hand side is the one that's meant to demonstrate dark matter, okay? So they often describe the one on the right-hand side as being like a bicycle wheel, where the outside of the bicycle wheel moves at the same speed as the inside. Now, start off, ignore the right-hand side for the moment. If you look at the left-hand diagram here, so this is, the left-hand diagram is not my diagram. So this is, again, off Wikipedia. And this shows, it's a graph that shows the distance away from the center of our solar system and the velocity around the sun, and it's the planets. And you can see here that planets that are closer to the sun, such as Mercury, Venus, and Earth, are going much faster than planets that are far away, such as Uranus, Neptune, and if you want to call it a planet, Pluto, out there. And so that's called Keplerian rotation, because Kepler, with his rules, described that relationship. And so that's the graph that was on the left-hand side that showed things moving much slower on the outside. If you look at my graph, this is my data here on the right-hand side, just to point out that for various limitations of the experiment, I can't get much closer than 4 kiloparsecs to the center of our galaxy, and you go out to about 8 kiloparsecs, which is the distance of the sun away from the center of the Milky Way. And you can see there that graph is absolutely not what the graph is on the left-hand side. In fact, the graph on the right is probably much approximates a straight line, which is, okay, take with mine from my backyard, which amazes me. So that is the smoking gun for dark matter. The fact that something has to explain why that is not dropping in velocity as it goes further away. Now, I know I've run out of time, so very briefly, what have I got? Just that, yeah. That's just to throw in to say I just weighed the Milky Way while I was about it at the same time. That seems to work very, very rigidly, very well. You can see a nice straight line from center. And let's show you some different types of aerial. Just forget that. Okay, and there we are. We'll just finish with that. So do feel free to contact me if I can help you in any way and you want to take this further. If you want to read any more, there's my website there. So thank you very much indeed.
We have time for about one question, if anyone's got a burning question in the room. Right here.
Just the elevation of the antenna. No, the mic. I'm sorry, mic. Yeah. I'm John, G4NEY. Just interested in the elevation of the antenna you were showing with your wonderful mechanism. Were you just moving that over the period you were recording then, or?
Yeah, so when my original mapping exercise, you only need 24-hour drift scan is what you need. So I did it for 2 days to make sure I got a full 24 hours, and then shifted it. I mean, now I'm repeating the exercise with a week in between, just to try and see if I can get pull out a better signal-to-noise ratio, so I can get a bit more, as it were, brightness, or be able to distinguish more of that outer arm. But yeah, you just really need 24 hours on it.
Thank you very much. At that point, we're going to draw a line under that, ladies and gentlemen. Thanks very much to Dr. Andrew Thornett for a wonderful talk this morning. If you have any further questions, do come up and talk to him after. Thank you very much.
Hello, I'm with Graham Murchie, G4 FSG. He's had various responsibilities of the RSGB and links to the RSGB over many years, but you're here today specifically to talk to us about Bawdsey radar, so tell us more.
I am indeed. Well, Bawdsey is the site of the world's first operational radar station. Built in 1937, experiments went on in 1934, 1935, trying to determine how we could defend the UK against potential incoming bombers should there be another war.
Can we just say where Bawdsey is as well?
Yes, Bawdsey is on the coast of Suffolk, very close to Felixstowe, across the mouth of the River Deben. The initial work was started at Orford Ness, which is slightly further north up the coast, and a small team of scientists and engineers went there in early 1935, armed with not very much. It was a site last used at the end of the First World War, and the building they were allocated had no power, no anything. But they progressed pretty quickly to determine they could use radio, and the fact that radio signals deflected off aircraft became distorted. So aircraft, radio and distortion was the start of how we could detect aircraft. And there's a wonderful story in one of the autobiographies about how little they had to help them, but one of the things that was listed was the RSGB handbook as the technical Bible that they used to work on early radar systems. They moved from Orford Ness to Bawdsey Manor in early 1936 when the Air Ministry bought a huge manor house and 186 acres for £24,000. Very good value at the time. And they, before long, were able to detect aircraft at some 100 miles distance from the stations. But to do that, they had 4 towers, 360-foot high lattice steel towers, 4 receiver towers about a quarter of a mile away, which were lattice wooden towers, 240 feet high, and trying to hide those and explain away what we were doing with these stations was quite a challenge. And the story that was put out by the Air Ministry was that these were radio direction finding stations, i.e. looking for the transmitters in the aircraft rather than trying to detect the presence of the aircraft themselves. And the Germans actually bought that story because maps that were captured after the end of the Second World War showed all the radar stations. By the beginning of the war there were 22 of them around the south and east coast, and by 1942 the whole of the UK coast was covered by 45 stations. But the story of RDF was sufficient to confuse the enemy in terms of what we were doing with these huge towers. So that's the background. We have the transmitter block as our museum. It's a grade 2-star listed concrete bunker, and for those of you that know anything about listed buildings, that poses a few challenges in terms of looking after the building that is listed. But we have a museum in there, fairly modern in term, well, fairly modern. 6 years ago it was completely refurbished, lots of interactive technology. We have, for example, a virtual reality project written by a group of apprentices from BT at the Industrial Park research site nearby. So you put on a virtual reality headset and the users can climb the tower. If they let go, they fall down the tower. We've halved the speed of gravity so people fall gently rather than rapidly. But those are the sorts of things that we have at the museum. Open Thursdays and Sundays until the end of October, then we reopen again at Easter next year. And the important thing is we're currently discussing with the RSGB the potential of discounts for entry for members of the RSGB. So you can all come along next year and get a discount to come. So when you come and visit Suffolk, come and see the museum.
Really good. How much is it for regular entry?
Regular entry is £8. Children up to 16 or maybe even 18 are free. Do get quite a lot of children
encourage children to come.
We
I guess you have school visits as well, do you?
We have school visits, we have private visits out of the normal visiting times, but we do have increasing number of school visits, and we're looking at potentially widening the opportunities. The Manor House itself is now owned by PGL, which is Young People's Adventure Holiday Company, which means that the public can't go onto site or visit the Manor House where all the work was done. So we're trying to arrange for tours, but they will be right in the middle of winter when they don't have any youngsters there for their adventure holidays. But there are a lot of people ask us about, can we go in the Manor grounds? Can we see the building where Robert Watson Watt did the development?
It is a fantastic place. I've been fortunate enough to go there, as you know, and have a look round, and all of the work that you've put into it. For the future, are you planning other exhibits?
We're looking at a number of potential changes to the exhibits. We're not changing them too much because, as I say, we've got a reasonable amount of technology there, and we focus on the story of radar. We don't focus on the technology all that much, and it's those sorts of things. It's quite entertaining. We get people come and visit us, and one half of the couple will say, well, I used to work for the RAF, and it could be male or female, and the other half says, well, I've come because she has said they want to come, but I'm not sure I shall enjoy it. It'll be a bit techie for me. And we try and catch the people as they leave, and they all say, actually, it was nothing like I was expecting. It's the story of the people. And the vast majority of radar operators during the war were female. Over 7,000 were trained at Bordsey. And the operators, the vast majority, if you see pictures of the operators, then the vast majority of them were female. The intriguing thing is that certainly in the early stages, whoever arrived on site as an operator at a radar station, one of the first things they were told to do was climb to the top of the 360-foot tower. And we have some brilliant oral histories recorded 20-25 years ago, when there was still a reasonable number of operators around, who'd been operating time of Battle of Britain, etc. The stories of climbing the tower, both men and women, and quite often the women were more accepting of the fact they had to do it than the men, but some of them were a bit challenged by climbing 360-foot towers. But radio amateurs, of course, are used to having huge towers, and so they would accept that.
You're a trustee of the trust, aren't you?
I'm a trustee.
Is it difficult? I mean, we all know that there are cost of living challenges at the moment for everybody, and so maybe these sort of museum visits and things are the sort of thing people cut back on. But I could say it really is a very good place to go. What are you seeing as far as a attraction to get people in?
Well, post-COVID, numbers are getting close to the numbers of visitors are getting close to the 2019 figures again. What we are seeing are that people are less inclined to pay money to buy things in the shop. We have a shop that's very focused on specific radar related things rather than a generic shop. But that's got better this season than last season and the season before, but we're still not completely back to where we were pre-COVID. The other problem, of course, Bordsey is on the end of nowhere. Nobody goes through Bordsey to go anywhere else, because if you go beyond Bordsey Quay, you fall into the sea. and the sea is getting closer and closer, of course. The east coast is eroding, and
is that going to be a problem for you? Is that a very long way in the future?
Interestingly, someone gave me a USB stick about 3 weeks ago on which they'd shown they'd recorded some drone footage of going up and down the coast, right by where the museum is. We were about 200 feet from the sea. I think we're near 180 feet from the sea in the last 18 months or so.
Oh, that is
so there are the coastal footpath that was there is now more or less disappeared. So it is definitely changing, and we are pretty exposed, but I'm not convinced there will be a real problem to the museum whilst I'm a trustee.
But nevertheless, it's a good place to go.
It's definitely worth a visit, and as I say, because we don't focus necessarily on the technology, then all family members, and quite often we'll, even though we're a very small museum, it being a concrete bunker, then people do stay a remarkably long time and watch the videos and interact with the technology.
Yeah, Graham, thank you very much indeed for coming to see us today and tell us, and do visit Bawdsey Radar. We've shown you the web link to the Bawdsey Radar as well, so you can go and visit it yourself. We've got just time to go for a quick visit to GB3HQ before our next talk.
Nice audio, over.
Oh, thank you very much for the report. It's much appreciated. I hope you have a good afternoon, and look forward to the other logs. His name's Chris, I couldn't remember what I said. So thank you very much. It's a good afternoon, and well done. GB3HQ from M0BQ. Afternoon, sir.
Yeah, okay, Chris, thanks very much for the call. M0BQE, this is GB3HQ, the special event station for the RSGB convention. Thanks again. So, GB3HQ, CQ. CQ40, this is GB3HQ, Golf Bravo 3 Hotel, Quebec, special event station for the RSGB convention, calling CQ40.
2 Echo 0, Bravo, Mike Alpha.
2 Echo 0, Bravo, Mike Alpha. Good afternoon. Morning, even.
Yes, good morning, good morning. I just thought I'd pop in, say hello, and it's a nice convention, as I can see on the GB website.
Yes, it's a very busy convention. Lots of really interesting talks on here today, and lots of local noise, unfortunately, which is causing all kinds of grief with signals, but hey-ho, we'll work around it. This is GB3HQ. My name is Rob, Radio Oscar Bravo, operating at the moment. Over.
Yeah, okay. The name is Chris Cardio Cobra Indicio, and the location is a village of Saxelby, just outside the city of Lincoln, QSL.
Okay, Roger, on the location. All very good. Say, good signal from you when the noise permits.
Yeah, okay. You're good 5 and 9 up here.
Yeah, 7-3, thanks very much for the call, Chris. We'll move along. This is GB3HQ, Golf Bravo 3 Hotel, Quebec, CQ.
Golf Whiskey 4, Norway, Ocean.
Golf Whiskey 4, Norway, Ocean. G4NOO. Used to be in Bedford, if I remember correctly. And you worked us yesterday. Morning, Michael. M0ZPU mobile. No, not mobile. I'm not M0ZP. I'm GB3HQ. Thank you for the barracking from behind. Over.
M34, that's the usually flight. Yeah, did work yesterday. Yeah, used to be not quite as far, not bad. So used to be.
Welcome back to the live stream from the RSGB convention. Now we've got a talk by Noel Matthews, G8 GTZ, on receiving live TV from the ISS.
Good morning, one and all, and welcome to yet another session of the HF convention. We've given up on the health and safety stuff. If you don't know it now, you never will. So, receiving live TV from the ISS with Noel Matthews, G8 GTZ. I'm particularly interested in this one because just over a month ago, I was at a presentation by Tim Peake. But, you know, no pressure, Noel, no pressure at all. Noel has, it tells me here on my crib card, always been interested in the microwave bands, having never operated on HF. No wonder he and I have never really crossed paths. He's also a keen amateur TV operator, has been chair and secretary of the British Amateur TV Club for the last 10 years, and operates home-constructed equipment. Impressive. On all bands from 50 megs through to 122 gigahertz. Wow. Noel, over to you.
Thank you very much, and good morning. Actually, I ought to update that because I'm now on 134 gigahertz as well, so I'll hold the UK record. Yes, good morning, and spend a little time this morning looking at the ISS in general. I want to talk a little bit about the ISS, just refreshers what it's all about. It's actually fairly current in people's minds because, of course, we had the schools, the contact last weekend with the Girl Guides, and the Duchess of Edinburgh attended. So talk about amateur radio on the ISS, otherwise known as ARIS, and what signals are coming down from the ISS, the equipment and the antennas and the challenges of putting equipment up there, and then move on and talk about specifically about ham TV, exactly what is it and how do you set about receiving it. And Tim Peake will feature, actually. There's already a picture of him there. So one of the reasons for that, I was involved in the school's mission when Tim Peake went to the ISS, if you remember, in 2016. I was very much involved in the ARIS team that went round to the 10 schools around the UK doing the contacts. So got quite a lot of footage and quite a bit of knowledge of the Tim Peake mission. So what is the ISS? Well, it's a space station or a habitable artificial satellite in low Earth orbit. And it's been built and maintained by 5 space agencies. So that's why it's international. Not one country owns it or runs it. There are a number of modules which have been put up there over the time by up to 5 space agencies. And it started in 1998. It's apparently the largest artificial body, and it's evolving and coming towards the end of its life. It's like everything, they're trying to put a date on exactly how much longer it will last, but certainly it's doubtful if it would be around in 10 years' time, but quite when the date is going to be, it's not quite sure. And it's very much more a commercial operation these days than it used to be. And you hear on the news about commercial space flight and people going up there on paid missions. So it consists of a number of modules, as I say. The European module is called Columbus, and they're all pressurized, connected together, pressurized. And the most noticeable feature about it is probably the solar arrays, the big golden solar arrays, and that's what you tend to see when people see pictures or take pictures from Earth of the ISS. It's the solar arrays that catch the sunlight. And it's 330 to 435 kilometers above Earth, and it is in a naturally decaying orbit, and so they regularly have to reboost it back up to those orbits. And there's a whole story about the ARIS contact last weekend, because they actually did a reboost a couple of days before the contact, and when they reboost it up, it changes the orbit times. And one of the problems they had with the contact last weekend was that it had a reboost a couple of days beforehand, and so the orbit times weren't quite calculated correctly. And so if you listen to the contact on YouTube, they were fairly late going into the contact. And those of you who listen on the Goon Hilly SDR probably heard the ISS calling before they made the contact. And then it faded out pretty sharpish towards the end. And that's because of a reboot the day before, the orbit calculation data wasn't quite up to date and accurate. So it is, if they don't do the reboots, it will naturally decline. And amateur radio on the ISS, amateur radio has always been around. First used on the shuttle in 1983. And there's an organisation, it's a pretty loose organisation in some respects, called ARIS, which of course stands for Amateur Radio on the ISS. And their goal really is to reach out and use it as part of the outreach to youngsters, to encourage them into STEM by interaction with radio technology. And the amateur radio contacts, particularly for the schools, are organised by ARIS. They don't just happen, but they're coordinated on an international basis. And ARIS is responsible for getting all of the equipment up onto the ISS, and that is no mean feat in its own right. It has to be very, very heavily controlled by NASA, and in some respects, ARIS are very much at the whim of those agencies as to what happens when. And we'll see shortly that ham TV is unfortunately being affected by external influences, if you like, because the environment is so tightly controlled. So there are 5 agencies who run the ISS. There's NASA, Japan, Canada, European, and the Russians. And one of ARIS's job is to liaise with these bodies, mainly through NASA. And all of the ARIS events that you hear, the schools contacts, for instance, are all run by volunteers. And all of the work done in the States to actually get equipment up to the ISS, or rather type approved and then up onto the ISS, is done by volunteers in NASA. A large number of whom actually work within the space industry, which makes it far easier. And one of the reasons why ARIS is so important is because all of the activities on the ISS are very much scheduled. The astronauts' time on the ISS is not. They don't just go to work when they feel like it. This is a schedule for a typical astronaut's day. They will have activities and exercise and meal breaks, and everything is scheduled down to the last minute. And so the schools contacts in particular are scheduled within that and given a 20-minute slot. So that's why you can't just rely on an astronaut being available. The occasional contact that you hear is when an astronaut in his own free time has popped into the shack. So the occasional unscheduled contacts are very much at the astronaut's whim. So the signals on board the ISS are, at the moment, are packet radio, the SSTV images, the occasional voice contact, which is the ones that the astronauts do of their own free will. There are ARIS schools contacts and also ham TV live pictures. And there he is again, that's Tim Peake back in 2016. And at that time, all of the ARIS contacts were done using an Ericsson handheld. So if you listen during the Principia mission to the Tim Peake contacts, he was using an Ericsson handheld for all of those VHF contacts. But I think it was, in 2020, ARIS did a lot of work to update all of the radio equipment on board the ISS. And so there are a couple of Kenwood 710s up there now. You can't just put a Kenwood 710 up there. It has to be approved and packaged. And also the power supplies have to be interoperable with what's on board the ISS. So a lot of work went into developing specific multi-voltage power supplies to run all of the ARIS equipment up there. And this here is the 710 and the wiring looms for it. And the first unit was installed in the Columbus module, which I said is the European module. And that one is used as the crossband voice repeater when it's not in use for schools contacts. Second unit was then put into the Russian module, and that's the one that's used for packet radio and also the slow scan events. The ham TV transmitter sits in the European Columbus module, or will do. That's where it sits. Outside the ISS, well, it's actually not the ideal place to try and mount antennas. There is a lot of clutter on the ISS. The VHF antennas, you can see it here, is being installed. Is a simple, I think that's probably a quarter wave on 2 meters. And the ham TV antennas, the 2.3 gigahertz antennas, are the patch antenna, which is bolted to the side of the Columbus module. But of course, there's a lot of clutter out there. There's solar panels, there's all of the external elements of the ISS. Plus, when visiting vehicles arrive, that can have an impact. So the radio performance can be slightly unpredictable, and it tends to fly. I use the word fly in inverted commas, but it tends to fly slightly nose down to protect the cupola windows from space debris, which has a bit of an effect, so that when it comes up over the west, it will be slightly blocked by the ISS itself, but going out to the east, it tends to be better. But it's amazing coverage. Yes, it's 220 miles up there, so it's fantastic, but it can be slightly unpredictable. As I say, the school's contacts are pre-planned because of the schedules, and they allocate 20 minutes for a voice call. The maximum time you can get on an orbit is 11 minutes. That's horizon to horizon. The actual ISS is visible for 11 minutes. Every year, the space agencies are allocated a number of contacts, which are then allocated around by ARIS. They plan the program for up to 12 months ahead, and a best week is generally identified anything up to 6 months ahead, but the actual date, day and time of any school's contact is only confirmed 10 days ahead because of the astronaut schedules, and even last minute changes can happen, which was another complication last weekend, as John knows. Due to unforeseen circumstances, they had allocated an orbit which was 120, I think 130. And at the very last minute, that got pushed, so they were on the orbit beforehand. So that's 96 minutes earlier. Two impacts of that. One, the royal household minute by minute planning for the whole day went out of the window, and that's very unusual for the royal household planning to be upset. Normally, the royal household planning is the thing that determines the whole day, but they had to be told that this is the way it's going to be. But the other impact was the orbit was not such a good orbit. The ISS on the planned orbit would have been pretty much overhead, but because it was an orbit earlier, it didn't go overhead. And so it wasn't an ideal situation, and those changes only happened on Saturday morning. So they really had all of their work cut out to make that a success, which it was. It was fantastic. And then, as I say, outside of that schedule, there are voice contacts which can be made during the astronaut's free time. They either go into the cupola and look out of the window and take pictures, or they can, if they've got the license, they can pop into the shack, which is why they don't happen that often. So that really is all of the activities on the ISS and what goes on. The thing I want to talk a little bit more about is the ham TV. And this allows astronauts to transmit live video. It's in the 13 centimeter band, so at 2395 megahertz, so just under the Wi-Fi band, which I'll talk about in a minute. The original unit, you can see here, the blue box, was installed in 2013, commissioned in 2014, and was really available for the Tim Peake missions, which we really made the best use of it for. And a lot of you probably saw the live contacts or have watched the videos on YouTube, and Tim really made the most of that then. Unfortunately, the unit then failed in 2019, and this is when it gets complex, because then the unit failed. They had to try and do some troubleshooting when it was still on board the ISS, which, as you can imagine, is not ideal. So within that busy schedule we saw, they had to allocate astronaut time, and they can only do whatever they've got work processes laid out to do. You can't just say, well, undo the back and get your multimeter out and have a poke around and see how many volts you've got on this test point. It's very much what is laid in the process. And unfortunately, they were unable to repair it. So it had to be shipped back. That in itself is no simple matter, because it had to get onto a cargo manifest of one of the returning ships, or at that time it would have been the Russian modules. So it had to be allocated a space on one of the shuttles. Eventually it got back. It then had to go from the States to Italy, which customs and stuff. Eventually it got there anyway and went to Kaiser Italia, who were the company who built and integrated it in the first place. The actual specifications, 2395 megahertz. The TX power out of the box is about 10 watts. But those of you who've played with any of the bands above 1 gig on 23 SEMS or 13 SEMS will know that you can easily lose a couple of watts in a piece of cable that long. And, you know, this is the problem. And so it's probably going to be running approximately 2 watts at the antenna. Talk a little bit more about that in a minute, why it's different from what it was. The patch we saw on the side of the ISS is a right-hand circular patch antenna. It runs DVB-S, which those of you who know about this stuff will know that it's probably not the most efficient modulation scheme, and we could do better today. It runs 2 megasymbols, which is pretty wide, and it also runs MPEG-2 video with an NTSC input. And so Tim's face doesn't look that clear there. Well, that's because it's not state-of-the-art video, because this was built 15 years ago. But it's still pretty cool, and you'll see that later on. So the current status is that the unit was repaired, and it was sent back to ARIS US in 2023. However, NASA had updated the test specifications from when it was originally shipped to the tests they wanted doing before it went up this time. And so an external bandpass filter had to be fitted, which means that the power output will probably be reduced by up to 3 dB from when it was up before. It was eventually taken back on a SpaceX flight in March, and the original plan that it would be commissioned in April/May. Unfortunately, that hasn't happened yet, and the latest we've heard is that in the 5 years that it's been away, some other equipment has been installed in the place where the ham TV equipment was installed. So they used the wonderful phrase, which I can't remember, topology reassessment, I think it was, i.e., we've got to work out where this box can go and still work, so we can then put this one in there, and will it? Yeah, okay. So we are still awaiting. I did this presentation 6 months ago, and it said July in the current estimate, and then I did it about 3 months ago, and it said October, and now I've been a bit more. Somebody said I should have put in their current estimate is before the end of the year and not specify. Yeah. But hopefully we'll be able to have some fun this winter. But Graham Sherville, G3VZV, says space schedules always only move that way. Things never happen earlier than they think they would. So, once it's up there and once it's been commissioned, when will it be turned on? Well, we don't actually know, but there are some good sources of information. In 2016, when it was up there, it was mainly used for the ARIS schools contacts, but the transmitter was left on at other times, but there wasn't necessarily any video on it. But it will be added to the AMSAT status page, which is a page that ANSAT run for all of their satellites, and it will appear in there. And they will also, they're pretty good these days at tweeting status updates on the various modules as to whether the packet's on, as to whether SSTV's on. All of this stuff tends to get turned off when there is a spacewalk and EVA happening. And so it will be added to the ARIS schedule, and you will have a fair idea when it is on. So, given that it's back up there and it will come back on, hopefully one of the reasons why you're here this morning is because you are interested what you could do to receive it. So, a block diagram of receiving ham TV. There are two ways. I presume, is that the laser? Which one's? Don't know. Anyway, above the line is the ideal way that you would do it. First of all, you need an antenna, and I will talk a bit more about that. But you will certainly need a high-quality preamp on 2.4 gigahertz. Not that difficult these days. But the golden rule is, which is why it's in red, you need high-quality feeder and as short as possible. Get that LNA as close to the antenna as you can to minimize your losses. And the ideal route these days is that you come down at 2.4 gigahertz. So use probably a satellite line amplifier to give you some gain. Use good quality satellite coax into your shack, where it will go into some receive hardware and be displayed using there's various types of PC software or other software that you can run, all of which is free of charge. So it looks complicated, but it's not as complicated as it looks, and I'll run through the various elements. The other way you can do it, but it becomes more complicated, is the yellow line. If you run a 2.4 gigahertz down converter, you then run an IF frequency into the shack, and then similar sort of background, but you've got a little bit more choice as to which receiver you can run if you do it that way, but it is actually more complex because nobody currently makes a commercial 2.4 gig down converter. When it was up there 10 years ago, there was a Kuhn Electronics made a down converter, and a couple of other people did. As to whether they will or not, I don't know, but certainly if you were starting from scratch, I think I would advise going the direct route and staying at 2.4 gigahertz. The only advantage of going down is that your coax can be, you don't need quite so much gain, and your coax can be thin coax rather than thicker coax. Antennas. It is possible to receive ham TV on a simple antenna. When the ISS is overhead, it is possible to receive it. Like we've all seen videos of YouTube of people receiving the voice on their handhelds in the, just holding it here. There is always a 5-minute window when it's very, very strong because it's overhead. But what they can't do is receive it when it's out at a horizon. And the same goes for ham TV. When it's overhead, you would be able to use a fairly simple antenna, but you would have less than 5 minutes coverage. If you want to go outside the 5 minutes, you really need some gain on your antenna, and you do need to track it. And the dish that a lot of people tend to use is the RF hams dish, which is this dish here. That's 1.2 meter mesh. That's not as big as it sounds. You can generally get away with that without too much planning permission from management. And it's fairly light to track. A Yaesu GR5600 will handle that. They're not a problem. If you start to go too big, you run into another problem. Yes, you've got more gain, but the actual beam width of the dish comes down, and so your tracking has to be much more accurate Whereas with a 1.2 meter dish, it's probably 5 or 6 degrees. So you've got a bit of room there. The sweet spot seems to be the 1.2 meter. So having got your dish, you then need to do some adopt best practices really for the RF engineering. This is a spectrum analyzer plot taken when the ISS was up, and it shows the ham TV signal on 2395, but it also shows Wi-Fi channel 1 right next door to it. Now, that can be a problem for you, particularly as the satellite receivers that we're using, even if you use a BATC receiver, it's using a standard satellite tuner, and they are designed as wideband receivers. There's no selectivity in those in the tuners. So you do need some good filtering. It's not difficult. The filters are around, either on the surplus market or the designs are around. So a good LNA, preferably with a noise figure below 1 dB and about 15 B of gain, into filtering. Satellite coax, probably not the stuff you buy in B&Q, but the reasonable satellite coax will do. Don't forget you're not transmitting, so you're not worried about transmit losses. Some line amplifier to boost the signal level in the shack. These receivers we're using are designed for use with a satellite LMB, the electronics that goes on the dish of an LMB. Typically, they've got 55 dB of gain in an LMB. So the receivers like to see a nice high noise figure to work properly. It's easy to do. The simple sort of £5 off eBay satellite line amplifiers can be put after a good preamp. And then you feed that into your satellite receiver. So the first word of caution is that standard satellite receivers only cover up to 2.15 gigahertz. So you would need to have a down converter to receive 2395 megahertz. But there is hardware around which covers 2395. So any satellite receiver may work. There was a problem with the ISS transmissions originally, whereby the DVB service information wasn't correct. That has now been corrected, and so in theory, a DVB-S receiver will work, but one of the problems with a typical domestic receiver is that you have to scan for signals. Every time you want to go for a new signal, you all know you have to scan your TV or your set-top box for signals. And the problem is, whilst you're trying to receive the ISS, you've got that 5-minute window, so you can't scan for it beforehand and store it as a memory. And so we don't really recommend using a off-the-shelf DVB-S receiver. Plus, they don't cover the frequency. But BATC do sell a tuner module which will A, cover the right frequency, and B, has got software which is designed specifically to receive amateur signals. And so it's not that expensive. The module you see at the top of the page there, components would cost you around about 70 or 80 pounds, and that will give you a unit which is a USB receiver, and you plug that into your PC or a Raspberry Pi to receive the signals. The actual receivers themselves, as I say, we recommend a receiver that's designed for DATV. We've tested all of our different varieties of receivers now, because when the ham TV was originally on in 2017, we took some recordings, some I&Q recordings. So we've been able to play those back into our current range of receivers and check that they do all work. And so if you buy the hardware or buy the components from the BATC, build yourself a tuner, which is a USB tuner. You can then either run There is 2 sets of PC software, the original French mini tuner, which you may have heard of, or there is now a thing called Open Tuner developed by ZS6RTG. All of this software is free, so they can be used. Or we have our own Raspberry Pi based receiver called Ride, which is the software is free to download to an SD card, and that will give you this type of configuration. So you just plug your USB card into the Raspberry Pi, and it gives you a set-top box type interface, and that will receive the ISS. However, there's one issue we haven't talked about, and for those of you who've been on QO100, unfortunately the ISS is not at all like the QO100, in so much as QO100 stays there at 26 degrees or whatever it is. 26? Yeah, 26 degrees, and that's it. It never moves. Well, it does move. For those of you who know, it does move within its box, but it doesn't move much. This thing moves at 27,000 kilometers an hour, and as I said, a pass lasts a maximum of 11 minutes, and your 1.2 meter dish has got a beam width of approximately 6 degrees. And so you do need to track it accurately when it's overhead. And this isn't rocket science. The AMSAT boys have been doing this for a long time, and so it's fairly common. The antennas will need to be mounted on the XY rotator, either a homebrew, or most people tend to use the GR5600. And then you run some form of tracking software on a PC. I personally run PST Rotator. It's got the ISS as a satellite. It automatically downloads all the tracking data, and it should be relatively easy to do once you've got it mechanically aligned, which can be a bit of a challenge initially. And so testing your system is the easiest way to check that you've got it mechanically aligned and your system is performing is to look for sun noise. All of the rotator control programs will have a track sun mode, and you should be able to, from the beginning of the day to the end of the day, your rotator should be able to accurately track the sun. Now, if you've got a prime focus dish, which is the one I was using, you can optically see whether it's tracking it, because the feed or the hub at the front should cast a shadow over a boss in the middle of the dish, and that should accurately stay like that throughout the day. With an offset dish, which are the ones with the feed at the bottom, you can't do that. And so the best way to check your system accuracy is to use a noise power meter to measure the sun noise. And you can see 2 or 3 dB out of a 1.2 meter dish, so it's not impossible. The sun is a great tool to check your alignment generally on microwave dishes, and there are either software using the tuner that you've got. You can either use software, or the BATC Portsdown system has got the ability to look at sun. Now this was a recording I took when we were doing ISS initially, and I was tracking. This was the cold sky, came across the sun and went off again, and then set it to auto track. And so you can quite visibly see that, and that tells you 2 things. One, first of all, over a period of time, is your system tracking the sun accurately? And also, if you should be able to measure the amount of sun noise you're getting, which tells you how good your system is performing. So that's the way to test your system. Once you've done that, you stand a pretty good chance of receiving ham TV. if you've got a local source of digital, digital TV, you can set it so you can see a signal on 2395, and then all you can do is really sit back and wait until ham TV is turned on. So they're the various elements I've talked about: the XY, rotator, the dish, the LNAs, into the tuner hardware, and into the software options that you've got for a receiver. I've got 10 minutes, 10 minutes. Yeah, I'll quickly show a video. I won't run it the whole way through. This was the Norwich Schools contact back in 2017. Tim was up there. It starts off initially just showing the standard schools voice contact, but then Tim appears on video, and you'll see the difference. It really does make a difference to have that video contact with him. So I'll just play a couple of minutes of this.
GB1SS, Golf Bravo 1 Sierra Sierra. This is GB2 CNS, Golf Bravo 2 Charlie November Sierra, listening and standing by for a scheduled contact with the International Space Station.
Hello, Golf Bravo 2 Charlie November Sierra. This is Golf Bravo 1 Sierra Sierra. I read you 555. Harvey, over.
Hi Tim, this is Tim, M6HDJ. Are you ready for your first question? Over.
It's great to be talking to you in Norwich, and yes, I'm ready for my first question. Over.
Hi, this is Maddie. What do you do if you cut yourself really badly in space? Over.
Hi Maddie, good question. We do actually use knives sometimes up here, so we do have to be careful. If we get a really bad cut, then we could actually give ourselves some local anaesthetic and stitch it up with the help of some doctors back in ground control if we need to. Over.
Hi, this is Austin. Are there any protocols or guidance in place if George Clooney comes knocking on the front door, as he did in the film Gravity? Over.
Hi Austin, well, as far as I'm aware, we're the only 6 human beings in space up here, so if anybody comes knocking on our hatch, I'm not opening it. Over.
Tim, it's Kieran M0XTD. We have you on Ham TV. Give us a wave. Here's your next question.
Hi, this is Sophie. What experiment would you like to add to your mission based on the experiences you have had? Over.
Hi Sophie. I would like to see us doing more of the medical research, investigating some more vaccines and looking into new drug methods as well. I think that's some of the most exciting research we're doing up here. Over.
Hi, this is Max. In what ways does the lack of natural sunlight and fresh air affect you on the ISS? Over.
Yeah, she says he opens
Max,
the windows.
I love opening the windows in the cupola when I'm in Node 3 or in the Japanese module. I love the sunshine coming through the window.
GB1.
Okay. And interestingly, just a point to note, the young guy there who was operating had only got his license 2 days beforehand, and I think that was his first ever QSO. Okay, so that's the story. Scan that QR code. We've got a wiki page which basically tells you everything you need to know, and if it doesn't, let us know what your questions are and we'll update it. So that wiki page will tell you everything that you need to know to get going on Ham TV. If you scan that with your smartphone now, it should, or even on YouTube, it should take you to that link. Okay, thank you very much.
Thank you very much, Noel. Do we have any questions from the audience? Oh. While they're thinking about it, can I ask you, how do you get cables in and out of the space station to all those antennas?
Well, I personally haven't, but I presume there are special cable ducts and actually. So bulkhead connectors onto the bulkheads and which is why the loss is so great or undefinable, really, because nobody's been able to go up there with a bird and measure the power at the.
Oh, thank you for that. Nice to have an expert here.
Yeah.
Anything else?
Not ham TV related, but we noticed on that pass, okay, apart from the beginning and end problems, down in the signal faded actually in the middle of the pass as well. Is that normal?
You tend to get polarization rotation as well. That's one of the big problems. The pass on Saturday, Carlos would have been there.
He was
switching the rotation, which captures the changes of polarity. Particularly as it's overhead, the polarization tends to rotate.
Yeah. Okay. Thank you.
Any more for any more? Oh no. Well, I'm sure Noel will be around later if you want to, if you think of something. But in the meantime, Noel, thank you very much indeed.
Thank you.
Welcome back to the live stream studio here at Kent's Hill. I'm with Lee Volanti, G0MTN from the WRTC. Now, a year ago we spoke to Mark about it, and it was 2026, of course, and that felt a long time away. Now we're a year nearer, and it's starting to get very real, isn't it, Lee? So tell us about firstly tell us about the WRTC, what it's all about.
Hi, and yep, it's great to be here once again. So WRTC, so the World Radio Sport Team Championship, is billed as the Olympic Games of amateur radio contesting. So normally once every 4 years in different countries around the world, so two-man teams or two-person teams come together to operate a radio contest to try to find out who is the best of the best. And we're very lucky to have been awarded the right to host the 10th WRTC in the UK in July 2026.
And it is a big event, isn't it? I mean, we mustn't underestimate the event. And normally there's 4 years. You said usually 4 years, but you've actually only got 3 because it was kind of delayed with COVID, I understand.
Yes. So WRTC 2022, hosted by an Italian team, had a number of challenges, including COVID, and they delayed their event by a year, but it all went off successfully in 2023. But the sanctioning committee, the board that look after WRTC, had requested that the next event be in 2026. So yes, it's been all hands to the pump.
I'm sure you have. So how does it work exactly? You've got different teams from different countries who come and take part, isn't that right?
Yes. So these days for WRTC, the globe is divided into different qualification areas. So there's not enough teams that we can support, so we couldn't have 100, 150 teams from every country in the globe coming. So different geographic areas that might be, say, half a dozen countries or so that have, say, similar propagation. They all compete in a number of qualifying events in the 18 months or so prior to WRTC to try to qualify for a position and be a team leader.
I mean, how do those countries... Oh, let's take Britain, for example. How are you going to decide who is our team? How does that decided?
So we've got 15 qualifying events that we've set up, so major international HF contests, and everyone that submits an entry into those events, we're taking the results when they're published, and then we're tabulating them together. And so over time, over this qualifying period, as the results come out, we can see who is climbing to the positions to be, let's say, the number one in the UK or in a particular qualifying area. So it's quite exciting going along the process.
It is. And when will those teams be decided approximately? Is it going to be the year 2026 or is it a bit earlier than that?
So because we'll have, say, so many teams travelling internationally, and to give them enough time to prepare and arrange their own travel and transport, normally it's about a year, say for us, because we're slightly compressed, it'll be somewhere between 9 months and 12 months ahead. The final qualifying contest will have been held, the results available, and then we'll have our final tabulation. We'll know who our team leaders are, and at that point then that they can start to prepare for their trip to the UK.
And it's July 2026, isn't
it?
I think that's when it's happening. So it's coming to Britain. You've got 50 sites, is that right? You need 50 sites? How do you choose the sites, and do you know where they are going to be yet?
Okay, so overall, say the entire purpose of WRTC is to try to have a level playing field. As we know that for ordinary HF contests, We have big superstations on mountains and people with little low wire antennas in the valleys, and it's not as equitable as it could be. So the idea is that we could make a level playing field, and famously in the UK, the East Anglia region is famous for being very flat.
Yeah, I can vouch for that.
So now our Director of Sites, Andy G4PIQ, assisted by Andy M0NKR, they're looking now and they're starting to identify sites, farmers' fields, local parks, anywhere that people have used for field days in the past, or even anyone that is lucky enough to have a large garden. They may also be, see if we can sign them up so we can have, say, clusters of sites together. We'll be putting up, say, the temporary sites with tents and there's temporary masts and antennas in the week or so before the event. We'll have site managers there to look after them, and then our entrants can hopefully come and then just unzip the tent, set up their stations and focus on the contest.
So, the competition-wise, then, how did the stations vary? I believe you say you arrange for the tents to be there and everything else, but do the teams bring their own equipment, their own radios, their own aerials, or how does that work?
Okay, so the WRTC station, so it's set up with a mast, a tri-bander antenna, and then a 40-metre and an 80-metre wire dipole.
All the same?
So all the same, identical. And then there's a generator to provide power. We provide the tent, the tables. So literally the entrants just have to turn up with their own radios and laptops. And these days are quite interesting selection of filters so that they can use the antennas with the two stations simultaneously.
So there's a little bit of element of competition there that could be that choosing the right filters and everything else. So there's a limit, there's a restriction in a way of what they could use, but the equipment themselves, the radios themselves, they bring them to the...
They bring their own, yes. So I think we recognise that these days a lot is maybe just a personal preference, so we don't see that there's a huge variation in the technical ability of the stations that will be brought. So yes, like I say, it's similar to Formula One, everyone's a similar level, and then we're really hoping that the contest itself is all about the operator skill, how they operate, and the strategies that take place on the air.
Yeah, so they bring this all equipment, and you've also got an adjudicator in each station, I believe, who's got to be there, haven't
yes,
they?
A referee, and so we're getting feedback. I think that there's lots of interest already in being a referee, so it's quite a prestigious thing, but also quite frustrating as they have to sit there, we're almost with, say, sitting on their hands, listening to contacts going on for 24 hours, just making sure everything is all fine and above board. I'm sure they'll be itching to take part and get involved as well. But no, they're there.
Mean, all this for 24 hours, and actually on the day, although I know you said that all the stations are going to be in East Anglia, we all know just in the last few days, as I speak, how conditions can change so much with the aurora that's just been the last few days. So it's going to be interesting, isn't it, how all these teams compete?
Absolutely, yes. And I think, say, beforehand there'll be, say, some strategizing, trying to work out, how conditions might go and be prepared for all eventualities in terms of the operating skill. We may have some people coming across to the UK to experience propagation beforehand, and we're also hoping to do a test run of some of the sites and the equipment next year in 2025, and then we can make all those logs public to give our entrants a better feel for what operating the contest from the UK will be like in 2026.
Good. Now I believe we've got the website that we can put on the screens now. So if people are interested, if they did have a suitable site and they live in East Anglia, you said, are you still looking for sites, do you think?
Absolutely, yes.
Yeah, so they can write to the organisation?
Yeah, www.wrtc2026.org. Yeah, we've got contact form on there. If anyone would like to offer a site or for any sort of manpower and volunteering, also that's very important to us. I think there's no WRTC without an army of volunteers.
No, I'm sure.
And for anything for inside admin, outside logistics and transport, I hope we can put on a good show, and say to do the UK proud, and that'll be a part of our volunteer roles.
Now you need a big headquarters for all of this, because to start with, and I believe yesterday you made the announcement about where it's going to be.
Yes, we've been there, so keeping our lips sealed for a little while, but it was the right time now that we can announce that the Y Boston Lakes Resort will be our headquarters venue. It was a little challenge to find that, as obviously we've got our fairly rural, flat area for the contest, and that's not normally the kind of place where you'd find a large world-class conference centre, for example. But we looked at different sites, and why Boston seems to fit the bill of what we need very well. It's very large. We can have all of the entrants and referees, supporters to come together. We can have large opening ceremonies, closing ceremonies, so have a good party as well. And for the socialising of these contesters that have come from all over the world, that they're the best of friends, but they maybe have never met each other. And an event like WRTC is great that everyone can come together, exchange stories and greetings, and drive forward radio sport.
And you've block booked, I guess, that whole hotel for that particular week?
For most of that, yeah, for the key days. So yes, and it'll be a real hubbub of activity. We should have stations on site as well. And as part of our outreach programme, we're hoping that some of the local community can come in, and I think we're reaching out to schools as well to introduce amateur radio and radio contesting to them.
It's all right to say that both Kevin, Tammy and I, who are doing this live stream this weekend, we're going to be part of it as well, and we're going to provide a live stream from the event as well.
Absolutely, yes. So another goal of WRTC is to improve awareness and, as I say, be a driver for that. So yeah, we're very grateful to help with the media team, and also with a recent new partnership we've announced on the IT front to provide, say, new visualizations of what's going on during the contest. So for hopefully a very large spectator audience online, it'll feel just like you're there with us at the event, following what's going on. So yeah, should be good. Very exciting.
I've just thought as well, why Boston Lakes? I'm sure that's where the HF convention, the RSGB convention, used to be.
Yes.
Before we kind of outgrew that. So there'll be a lot of people watching this, I guess, who will already know that venue.
Absolutely. Yeah. Yeah. For the UK, it's hopefully a lot of positive memories of RSGB convention in the past. So.
Yeah, it'd be nice. So the actual contest is 24 hours, but there's a big build up to this. How does the week going to look then?
So
got an opening ceremony, I guess.
Yes, so there's like an arrival. So say that everyone coming from around the globe. There'll be a big opening ceremony, give some history of WRTC. Say share some of the culture of the UK. Normally there's time for some sightseeing as well. Some people will have travelled many thousands of miles, so we can try and show off some of the local culture and spots as well. And then as getting down to business, there'll be meetings for the entrants, for the referees, just to explain how everything will go. The entrants will visit their sites. Oh, there will be a draw.
So that's how they don't choose where they're going to be.
A random draw is always an interesting meeting, and then meeting up with their referee. And then there'll be like a secret envelope with their unique call sign that is only opened 15 minutes or so before the contest starts. So the entrants will go out, test their site, come back, and then it's then time for the big contest. 24 hours of adrenaline, come back. The results will be processed and made live then for a big opening ceremony the day after the contest. It's a huge big party, and then everyone will then go their separate ways, and then start looking forward to WRTC 2030, wherever that may be.
And you can take a sigh of relief.
It starts all over again.
Yeah, Lee, thank you ever so much for joining us today and explaining more about WRTC. It does sound a long way away, but it's going to be here before we know it, isn't it?
Super.
Yes. I would love. Please keep us updated.
Thanks, David.
Now, as part of the convention, we do have these talks and we have interviews like this, but we also have a bar. And on Friday night, we sent a camera into the bar to see what people were talking about.
Well, I'm very excited because I'm here at the convention for the very first time. I only recently qualified back in July this year, got my foundation license, and I just thought this is a really good opportunity to learn a lot of stuff in a short space of time, and also just to meet some other amateurs. So here I am.
Well, I've moved from Scotland to Norfolk, and I've spent the last 2 years building or rebuilding my shack, setting up a new antenna system, building a tower, and getting myself QRV or active on every band from 160 soon to 3 centimeters, but currently all the HF bands and HF.
So this year I've tried satellites for the first time, and I'd like to progress that further if I can. I've done a couple of downloads from a couple of satellites, and I'd like to see what other satellites I can download information from, but also work a lot of satellite contacts, which I haven't done much in the years I've been an amateur, so hopefully I can be able to do that.
All of it is new. I'm very newly qualified. I got my foundation in July and my intermediate in August. And my partner got their foundation in August, and the hobby's whatever you want it to be. I'm particularly interested in the higher frequencies, into the gigahertz, and my partner's into digital radio, so we can go anywhere with a hobby, and that's what's so great about it.
Well, I've recently changed my receiver. I've been using a wonderful Kenwood TS890 receiver, but I decided I wanted to try out this SDR, software-defined radio. So I got myself a Flex, not one of the newest ones, it's a 6400, but I think it's great, and that's allowed me to use some new software. It's SDC, software-defined connectors, written by a Ukrainian Yuri, and I think it's great. It lets me really get into contesting, because that's what I'm interested in most.
I did a DF hunt with our local club, and I won.
In a moment, we'll be back on the sofa for another interview, but we've got someone very special on the mic in GB3HQ, so we're going to rush over there now.
Charlie Victor, Mike 1 Fox Charlie Victor, to yourself.
Mike 1 Fox Charlie Victor from GB3HQ, many thanks for the call. You're 5 and 9 at the RSGB convention in Milton Keynes. Over.
QSL on GB2HQ. Congratulations on putting the station on, and say thank you very much. Name here is Clive, Charlie Linda, Eva, India Victor Echo in the Cotswolds and in the southwest. Back to you.
Mike 1 Fox Charlie Victor from GB3HQ, all copied. Many thanks for the call. Nice to speak to you. 73 QRZ from GB3HQ.
Yes, that's praise from Mike 1 Fox Charlie Victor.
CQ, this is GB3HQ, Golf Bravo 3 Hotel Quebec. CQ and listening. CQ, this is GB3HQ, Golf Bravo 3 Hotel Quebec. CQ and listening from the RSGB convention in Milton Keynes. CQ, this is GB3HQ, Golf Bravo 3 Hotel Quebec. CQ and listening from the RSGB convention in Milton Keynes. CQ, this is GB3HQ, calling Golf Bravo 3 Hotel Quebec. CQ and listening from the RSGB convention in Milton Keynes. CQ, this is Golf Bravo 3 Hotel Quebec. CQ and listening from the RSGB convention. CQ, this is GB3HQ, Golf Bravo 3 Hotel Quebec. CQ and listening from Milton Keynes at the RSGB convention.
Thanks. So come back to us, because we must let you into a little secret. The lady on the microphone there is Heather Parsons. She's the communications manager for the RSGB, and she's kind of our boss here, even though we're just volunteers doing this. And we saw her working on the radio. None of us have ever seen her work on the radio before. We couldn't miss this opportunity to get it on video and live stream. So lovely. It was really good to see Heather doing that. Now, we're going to talk about something completely different now. Bunkers on the air. I've got Jason and Mark with me to talk about it. I don't know much about Bunkers on the Air. Probably lots of people watching won't either. So tell us what it's about.
Okay, so it's a portable scheme for activators and hunters. It was first established back in 2005. It then got integrated into stately homes and castles, and then after a while it sort of dissolved. Last year, October last year, it was sort of relaunched to what it is now, and yeah, we just go out activating bunkers and hunters, to chase those activators.
But I mean, can you define, Mark, can you define a bunker to me? I mean, to me, I come from Norfolk. We've got bunkers. They're the sort of concrete buildings that you sometimes see in fields and things like that. Is that all we're looking at, or is it other things as well?
Yeah, essentially it is. What we've done is try to incorporate as many bunkers, World War II bunkers essentially, but there's a few other things, and we've incorporated those. It started with Royal Observation Corps bunkers, and then we've added a few more, but it doesn't include things like pillboxes, simply because there's too many of them. There's thousands and thousands of those. So at the moment the scheme includes 2,500 bunkers. So wherever you are in the UK, for UK boater, which is UK bunkers on the air, there'll be a bunker very close to you that you can activate.
And now we're going to put your website up on the screen as well for everybody at home as well. There, I guess there might be a map or a plan or something where these bunkers are all located?
There is. There's lots and lots of information on the site, and I would encourage anybody interested to go there as a first port of call. One of the things that we've developed is we use Google Earth, and then we've developed a KML file overlay that drops on the top of Google Earth, and it gives you a live representation of where you are in your car or walking, but it also gives you the bunker location, the bunker code, the latitude and longitude of the bunker, and the activation zone, which is a kilometre radius around the bunker. So it shows you all those things. So if you're out and you're activating, you can, what I do as an activator, is you can see your little blue dot, as it were, travel into the activation zone, and you know you're then in the zone. And you can operate safely, because you can't generally operate from a bunker itself, because it might be on private land unless you've got approval to do that, and you certainly can't go into a bunker unless it's one of the bunkers that have been sort of developed and
they're safe to
because
go in
generally speaking they could be unsafe, they could be full of water, and they've got a vertical ladder dropping down into them. So no, we never advocate people activate from within a bunker unless it's safe to do so.
Okay, Jason, is there a particular day or days in a year when you do this? Because lots of things like churches on the air and things like that. No, is this an all-year event?
This is an all-year event. We do have special awards, so we have county days. So when a particular county is having its day, we'll put up an award for that county. We have several different special awards that we run out through the year. But yeah, as an activation, any day.
All right, so how do people get involved then? I mean, we've given the website on how do they need to register?
Yeah, so UK Bunkers on the Air website, if they go to that one first, register that will give them the details on the award schemes that we're running, and actually how to go about activating and claiming for that award. The bunker-based site is where they can get the KLM file for the overlay, where they can actually see where the bunkers are to go out and activate. Or hunt.
Yeah, hunt, find them.
Yeah.
So you could do it the other way around, and some people will be activating.
Yes, obviously the hunters will be out, sitting in their shacks. We spot on social media, so it'll see as soon as they see it up on social media, the site is listed, and the frequency the activates on, and the pile-ups start coming in.
I was going to ask, because you said there were no specific days to do this, so when do people know when's best to have a go?
So we use WhatsApp social media channel. We've got like a general channel on there where people will put in what they're planning on doing, and then we've got a dedicated spot channel, so it'll go up on the spot channel, and then the hunters will then tend to move that over to the cluster as well, so that the spots there, and that's it. The hunters start pouring in the pile-ups.
And any specific bands that you promote? I was talking to Mark earlier, obviously promoting 2 metres, 145, but I mean, or all bands?
Yeah, I mean, 40 metres, 20 metres, 10 metres. I would say probably most activators will start on 40 metres. But we've developed, like Jason said, awards to encourage other activity. So there's a specific award for VHF, UHF activation, and we've reduced the number of QSOs for that award that counts towards awards. So to activate a bunker, you need 25 QSOs on FM. On HF. If you want to activate by VHF, UHF, we've reduced that to 10. And people will be on every day all day. There's something called a Night Owl Award, which is for those people who want to activate and chase a bunker after 8 p.m. at night. So there's something for everyone within bunkers, and you don't need any specific skills or any specific equipment. You haven't got to climb a mountain. There'll be one somewhere near where you are. Accessibility is the
And you
key.
said you relaunched it last year. Presumably it's very popular, because I'm from the Norfolk Amateur Radio Club, and there, it is something that people mention now and come forward to. So you've done a good job at publicising it and getting people involved.
Yeah, I've only been involved on the admin side of it since June, really. But yeah, it was launched October last year. This year, because of the popularity, Worldwide Bunkers on the Air has been incorporated into it as well.
Wow.
It's going extremely well.
It is. So we now have Slovenian bunkers, Czech Republic bunkers, Belgian bunkers, and a number of others. North Macedonian bunkers, French bunkers are going to come on stream in November. So it started from UK bunkers on the air, and now we have world bunkers on the air, and within world bunkers on the air lives all of those national bunker schemes. So yeah, probably 300 different activators out activating. I'm the award manager, and I've issued 1,200 awards in 12 months. So it is. If you go on 40 metres, you can't avoid it.
All right. bunkersontheair.org is where to go for more information. Mark, Jason, thank you very much for joining us.
Thank you.
We're going to go back now to GB3HQ, see who they're working and who is working at GB3HQ now.
Over. Yes, thank you. I think it's John. I just caught you at the other. No, it's Brian here. Thank you, John. 5 and 9 plus about 10 dB with me. And we're located in Shrewsbury. Go ahead.
Yes, all copied, and yes, that's correct. John on the mic here. Juliet Oscar, Hotel November. Thanks so much for the call. I won't hold it. There's other people calling as well, but thank you very much, and we'll catch you again soon. G3VWH from GB3HQ.
Yes, I shall be very still.
73 QRZ Golf Bravo 3 Hotel Quebec, special event station at the RSGB convention.
2 Echo 0 India Hotel
2 Echo 0 India
Sierra.
Hotel Sierra, strong 5x9 there. Welcome to Milton Keynes and the RSGB convention, over.
Yeah, 2 Echo 0 India Hotel Sierra returning here. All received there, John. Operator name is Gary Golf Alpha Romeo Yankee. GTA just outside the town of Reading in County Berkshire, and your 5-9 plus 10, over.
Yep, all copied. Thanks very much. As I said, strong 5x9 here, but not quite peaking to plus 10. So we'll give you a 5x9. But thank you very much, and we'll catch you again further down the log from GB3HQ. QRZ Golf Bravo 3 Hotel Quebec, special event station at the RSGB convention. Mike X-Ray 1 Bravo Echo Delta, very strong. 5x9 plus 10 here, peaking at plus 20, over. Seven 3, and thanks for the call. QRZ Golf Bravo 3 Hotel Quebec. Mexico 6 Lima Tango Golf 5x9 here at Milton Keynes.
Get involved with the RSGB. But you have a great day there, my friend. Thank you very much.
Likewise, have a great day, and thank you very much for calling in. QRZ Golf Bravo 3 Hotel Quebec. CQ40, CQ40, this is Golf Bravo 3 Hotel Quebec, GB3HQ, Golf Bravo 3 Hotel Quebec, calling CQ and listening. CQ40, this is Golf Bravo 3 Hotel Quebec, GB3HQ, special event station for the RSGB convention, Golf Bravo 3 Hotel Quebec, calling CQ and listening. CQ40, CQ40, this is Golf Bravo 3 Hotel Quebec, GB3HQ, Golf Bravo 3 Hotel Quebec, calling 40 meters and listening. CQ40, CQ40 from Golf Bravo 3 Hotel Quebec, GB3HQ, Golf Bravo 3 Hotel Quebec, calling CQ40 and listening. CQ, CQ, CQ40, CQ, CQ, CQ40 from Golf Bravo 3 Hotel Quebec. GB3HQ, Golf Bravo 3 Hotel Quebec, calling CQ and listening. CQ, CQ, Golf Bravo 3 Hotel Quebec, Golf Bravo 3 Hotel Quebec, Golf Bravo 3 Hotel Quebec, calling CQ, over. Golf Bravo, please, Golf Bravo, over. Mike 0, Delta Golf Bravo, good afternoon. Thank you very much for calling in to GPGHQ, the headquarters station of the Radio Society of Great Britain, and at the RSGB convention taking place at Kent Hill Conference Centre in Milton Keynes today. You are coming in 59. How do you copy? Mike 0, Delta Golf Bravo from Golf Bravo 3 Hotel Quebec, over.
Mike 0, Delta Golf Bravo returning. Yes, very good afternoon to you. Bit of QSD on the signal, but 5-9. We're located in West London. Name is David. GB3HQ, Mike 0, Delta Golf Bravo.
Yeah, Mike 0, Delta Golf Bravo from GB3HQ. Yes, fine business, David. That's fabulous. You might like to be interested that just after around 3 o'clock this afternoon for a 15-minute period, the president of the RSGB will be putting his personal call sign on air. That's GB4RS. Will be on air. So it's a fairly rare call sign. Doesn't get put out that much. So if you want to get that one in the log, come along at 3 o'clock and make sure you're on frequency with us and have a chat to the RSGB president. Over.
There'll be a nice pile up. Okay, well, I'll let you get on and work a few stations. I'm happy watching the live streams. They've been very good. Enjoyed them.
Yeah.
HQ, Mike 0, Delta Golf Bravo, cheers.
Yeah, cheerio. Yes, we're live. Well, the station is currently live on the live stream anyway, over lunchtime, of course. So, hence the reason for saying about the president coming on air and airing his call, so people watching the stream can actually, can go, ooh, well, I'd like to do that. So we want a nice big pile up for the president this afternoon. Anyway, thanks for calling in, David. Take care, 7-3. Mike 0, Delta Golf Bravo, GB3HQ is clear. Golf Bravo 3, Hotel Quebec, the headquarters station of the Radio Society of Great Britain is calling CQ. Mike India station, Mike India, go ahead. Nothing heard. QRZ? 2 Echo 0, Alpha Delta Romeo, good afternoon to you. You're 5 and 9 into the RSGB Convention Centre here in Milton Keynes, so how copy, over? Five and 9 Middlesbrough, lovely, got you there. Thank you very much for that. That's wonderful. Have we got a name, please, over? Yeah, Steve, jolly good, got that. Thanks so much for calling in. Don't forget, if you'd like to speak to the RSGB president and put his personal call sign into your log, come along at 3 o'clock and make sure you're on frequency with us here. We'll be somewhere on 40 metres for sure. So come a little bit earlier or you'll hear me warming the frequency anyway for him. So 73, and thanks for calling in. Bye-bye. QRZ, this is Golf Bravo 3, Hotel Quebec.
Okay, I hope you can hear me now. Sorry about that. Now we've got another interview back here at the Livestream studio, how to get new people into contesting and what makes contesting fun. And our guest interviewer is Board Director Peter Bowyer, G4MJS.
Thanks, David. I'm here with Andy Cook, G4PIQ, and Nick Totterdell, G4FAL. Andy is chair of the VHF Contests Committee and Nick is chair of the HF Contests Committee, and between them they run the committees that organise contests in the RSGB. One of the topics we wanted to discuss first was, what is contesting? What makes contesting fun? Why is contesting a branch of amateur radio that people should get into? What do you think about that, Andy?
So I think there's all sorts of reasons that contesting's a brilliant thing to do. I mean, people may think that it's just about the competitive side of things. It's just about going on and trying to make the biggest score that you can. But actually, the whole contesting community is a fantastic, vibrant and really helpful community. Lots of social media channels where there's good, healthy discussion about about what to do. So I think contesting is great fun because it's a fantastic way to meet like-minded people inside radio, but have a part of fun while you're doing it, and learn in the process as well as to how to do things better, how to build your station more effectively, how to make really interesting DX contacts in the contests.
Thanks, Nick.
Let me add to that. When I was first licensed, one of the draws to amateur radio was that it was a way to talk to people all over the world. Well, now, of course, I've got a telephone in my pocket that I can do that with. So that's sort of gone a bit. So I think the whole genre that Andy and I are involved in is to provide things for radio amateurs to do. Once they've got their call sign, what are they going to do with it? They might have chats with people they don't know, but it's much more interesting if you've got something to pursue. And there are various things people can pursue, but contesting, I think, is a particular area where it's a very fulfilling thing to do when you've got this call sign, you've got the ability to transmit. Well, now, okay, I'm the sort of person who, if I'm given a newspaper, I don't read the headlines, I go to the puzzle pages. So I'm driven by puzzles, and that's why perhaps I'm attracted to contesting. And again, in amateur radio, that's the draw. The draw is to do something competitive, something challenging, and it is basically a puzzle as well.
I don't know if I can just add one thing as well. I think in VHF in particular, the bands are often quite quiet outside of contest time, and it's really during the contest that the bands come alive. The SSB end of 2 meters on a Tuesday, the first Tuesday of the month, be packed end to end with stations to work. So if you want to get on and make contacts on 2 meters outside of your local area on FM and really cover the whole country and into Europe, contests are the time to come on and do that. And so it's not an antisocial just snapping numbers at people. There's a whole, you build community, you build relationships with friends in that activity as you do it month on month.
So a new licensee or a licensee that hasn't been involved with contesting before, what do we as a society have to offer them as a way in? What should they do first?
So I think you'll see some links associated with the webcast here that will take you to some contesting help pages that we're putting together. But essentially, if you to get started in contesting on VHF, it's largely, most activity is on SSB. I think you'll have most success if you can get on SSB, and people think that's a high bar to get to, but it's not in reality. There's lots and lots of second-hand equipment out there available for low hundreds of pounds that'll get you a transceiver, a small beam antenna, or even just a dipole, and you'll be able to get on and work many tens of stations with that equipment, particularly on a Tuesday night. We also have contests for FM. That works okay if you're in an area of high activity, and we also have a contest for FT8. So if data modes is what you're interested in, again on the first Wednesday of every month on 2 meters and the second Wednesday of every month on 70 centimeters, we have an FT8 contest. Where there's an opportunity to work, again, many tens of stations on FT8 during those periods. So I'd encourage you to have a look at the website to see, what's that basic equipment, but also recognise you don't need to spend a mountain of money to get onto SSB and the data ends of 2 meters.
What would you say a typical entry-level station would be then for those contests?
I think a basic transceiver, something that runs 10 or 25 watts, and as I say, plenty of second-hand stuff available out there that'll do that. Ideally, if you can get a small beam antenna up, doesn't have to be big, 3, 4, 5 elements is perfectly enough to make a start. Some decent feeder on the back of that. Clearly put that on top of a small mast. If you can get it up at 20 feet or higher, that's good. You need to be able to turn the thing. If you can turn it by hand, that's a good start. If you can put a rotator at the bottom, that's a move on. And one of the other things that people often do in VHF contesting is they often go out portable. They'll go to the top of a local hill, because VHF propagation is so much improved by having a really clear look at the horizon, and once you're up on those tops, even small low power radios like 5 watts and 2.5 watts are plenty enough to make lots and lots of QSOs in that environment. So that sort of equipment, small battery, great stuff to get started with.
What about
or even just parked up in a car with your aerial attached to the door. I've seen people locally doing that. That's
certainly how I started. Parked up in a car park on top of a hill with a pole attached to the car, and that was my contest station.
There was a message on our local WhatsApp group where I live, and the neighbours were saying, "Who's this fella who's parked up on the top road with a weird aerial attached to his car?" And it wasn't me, and I said, I can guess who that is, and I had to walk down and had a chat with the chap. He was having a great time working into France on 2 metres from his car. On HF it's a bit different. I think the great thing on HF is that you can talk to people all over the world, but you're not always sure that there's going to be anybody at the other end. Whereas in a big contest, you can be pretty sure that pretty much anywhere on the planet, there will be someone at the other end. And if the propagation window is open, you'll be able to talk to them, or at least be able to hear them first of all. Whereas any day of the week there may be a propagation path, but if there's nobody at the other end, you're never going to know. So the fact that the bands are occupied, full of activity, people making very short QSOs, it's just great to join in. And you can just dip in, make a few QSOs first of all, and then move on to making a formal entry as you get more enthusiastic.
One place people can go to read about contesting is Radcom, and Nick, I know we've made some changes to the format of the contesting content in Radcom recently. Do you want to quickly talk about that?
Well, that's right. There's a contesting column each month in Radcom. It's 2 pages with some photographs, and what we've decided to do is to try and follow a syllabus, basically, almost like what might be the index to a book on contesting, an introductory book. And we've already got some 10 or so articles published. So as the time progresses, Radcom has these interesting articles in it, but then they get moved to the website and are permanently available. This is building up a record. I think we've got 30 chapters planned at the moment, and we're adding to that total. So this will go on for some 2.5 years or so, and then at the end of that period we'll have a full introductory journal, if you like, on getting into contesting, how to take part.
And those articles are all written by well-known and skilled, experienced contesters.
Yes, like Andy and me. No, that's a joke. No, different people. We have some experts in the RSGB who are good at writing, and we're calling them in to cover issues that they have expertise in, and it's working out very successfully, I think. So Andy and I have written some of it, but mostly the more general stuff.
Yes.
But on specifics, we're trying to call on people who are a bit keen on their particular area of expertise.
As people progress through contesting, of course, they might want to join a contest group. There's plenty of contest groups represented here at the convention, and we've had two trophy ceremonies where people are recognised for their achievements. Is that what's important about contesting? Is it the winning, or is it the taking part, Andy?
Oh, I think for some people it's about the winning, but for most people it is about taking part. It's about perhaps doing better than you did last time. I mean, I've recently returned to 2 meters after a fairly long hiatus of having been having family and so on. And as I come back to the band, I'm learning a lot. I've moved from, I don't know, 15th position to 10th position to 8th. I'm slowly working my way up the table by learning more and more about what you need to do to be successful in those contests. It's a real opportunity for self-training.
It is, thank you. Thank you very much, Nick and Andy, and now back to David.
Thanks very much to Peter, Nick and Andy. Let's have a last look at our Sunday programme for the live stream with 2 more presentations to come. HQ to see what our special event station's doing now.
Close down off the station. GB4RS is closing down, passing it back to GB3 HQ.
This is GB3 Hotel Quebec. GB3 Hotel Quebec. There was a little bit of a surprise there of having the RSGB president drop in and do a quick few QSOs. So do come back at 3 o'clock this afternoon where you can have another chat with him if you're lucky. Anyway, CQ, Golf Bravo 3 Hotel Quebec. Uniform Papa India, please. Prefix?
Golf Mike 8, Uniform Papa India. A very good afternoon to you. The name of the send is Dave, Delta Alpha Victor Echo, and the QTH is near the town of Lockerbie in South Scotland. You're about 10 over 9 with me from GM8 UPI.
Yeah, GM8 UPI in Dumfries and Galloway. This is Golf Bravo 3 Hotel Quebec at Milton Keynes at the RSGB conference as we're on the last leg, as it were, of the conference this afternoon. Thanks very much for calling in, Dave. The operator name here is Simone, Sierra India Mike Oscar November Echo. And I'm sorry you missed out on the queue for the president, but he had to disappear and do his interview. So he'll be back again at 3 o'clock, and you'll, if you're around, you'll probably get in lovely signal here in 59 plus into the convention. Go ahead.
Yes, okay, from GM8 UPI. Okay, well, thanks very much for the nice report. I'll maybe be back on around 3 o'clock, and we'll maybe catch the president there. Sounds please, and have fun down there in Milton Keynes from GM8 UPI.
Yeah, definitely, Dave. Take care. QRZ GB3HQ. Echo 0, India Victor Mike. Good afternoon. AR5 and 9 plus into the RSGB special event stations at the RSGB conference in Milton Keynes. How copy? Over.
Good afternoon. You're 59. Location is Lister, just off junction 23 of the M1. Operator name is Ray. Not going over the call because a lot of stations calling you. And thanks for putting the station on.
You're very welcome, Ray. The operator name here is Simone, Sierra India Mike Oscar November Echo, Simone, and my home call sign Mike 0 Bravo Oscar X-ray. So thanks very much for calling in, and hopefully see you around 3 o'clock. 7-3. QRZ Golf Bravo 3 Hotel Quebec.
Golf 3 Zulu November uniform.
It's a couple of stations there. Golf 3 Zulu November uniform won that round. Good afternoon. You're 59 plus into the RSGB convention. How copy? Over.
Yes, good afternoon, Simone. Rather spooky here. I'm watching you on the live stream, so I'll probably hear myself come through first this morning. Name is Malcolm, Mike Alpha Lima, Charlie Oscar Lima Mike, and I'm located just north of the highway to Buckinghamshire from Q30 News.
Yeah, Roger, G30 New, GP3HQ. Indeed. Oh, right, you're on the live stream. Yes, so we are live right now. So, jolly good. Yes, coming in 59 plus, as you'll probably see on the way them coming on the live stream. So, thanks for calling in. I'll take another station. 7-3, Malcolm.
Yeah, cheers, Simone. All the best.
QRZ, Golf Bravo 3 Hotel Quebec. Golf 1 Whiskey Zulu Mike. Good afternoon. 59 into the RSGB HQ special event station. How copy? Over.
Hi, Simone. You're coming in 559 here in South Cambridgeshire.
in Haverhill. Nice to speak to you on this station. Makes a change. Golf 1 Whiskey Zulu Mike.
Yeah, indeed. Thanks very much, Clive. But there we are. I get around, you know. Anyway, thanks very much for calling in. Other stations, so I need to move on. 7-3.
I wonder if I could have a radio signal check, please.
Oh, sorry, I do beg your pardon. 5-9 into the convention centre, over.
Wonderful. Thank you very much. Have a great afternoon. Golf 1 Whiskey Zulu Mike, clear.
Yeah, 73 QRZ, Golf Bravo 3 Hotel Quebec. Got a 2 Mike 0. Two Mike 0 Romeo Hotel Tango. Thank you for 5-9. You are likewise 5-9 plus into the RSGB Convention Centre at Milton Keynes. QSL. Seven 3. Thanks very much. QRZ Golf Bravo 3 Hotel Quebec. Operator name is Simone. Sierra India Mike Oscar November Echo. QRZ.
Mike 0 Kilo Ocean Mike.
Mike 0 Kilo Ocean Mike, good afternoon. 5-9 plus into the RSGB convention. How copy, over?
Yeah, no problem at all there, Simone. 5-9-59. My name is Lenny, and the location of Middlesbrough up in Cleveland. Many thanks for putting the event on, over.
Yeah, very welcome, Lenny. Thanks so much for calling in. 7-3 QRZ Golf Bravo 3 Hotel Quebec. Yeah, Golf 4 Victor Yankee Romeo, this is Golf Bravo 3 Hotel Quebec. You are 5-9 into the special event station here at the RSGB convention. How copy? Yeah, thanks very much for calling in, Gordon, and for all those listening and watching on the live stream. The RSGB president will be back on the station. He had a little impromptu few QSOs 10 minutes ago, but he will be back on the station at 3 o'clock here for between 3 and 3:15. So if you wish to put his call sign, that is GB4RS, into the log, then make sure you're here at 3 o'clock. And you can, if you're lucky, get his call sign into your log. So with that little bit of advertising done, 7-3 Gordon and QRZ GB3HQ.
Welcome back to the live stream studio. We've got something really interesting to talk to you about now. I've got Dave Johnson, G4 DPZ from AMSAT with me. Hello, Dave.
Hello.
Enjoy the conference so far?
It's been fantastic, yes. It's always great fun to come.
Yeah, and when it's been fascinating, and I just couldn't help when we were down in the SIG room earlier, the special interest group, I couldn't help but noticing you holding this thing, and I was so intrigued. And we asked you about it, and you've agreed to come and talk to us about it. And we've got a video as well that will help in a minute and play it back. So, tell us what this is firstly.
This is the AMSAT North America CubeSat simulator. It's the same characteristics to a large extent of what a satellite would be that goes into orbit.
And this size?
This size, it's a 10 centimetre cube. It's what we call 1 unit. We then can have multiple of those, 1 unit, 2 units, 3 units, and grow in size that way, and then grow in size sideways. We can go from 1, 2, 3 to 6 to 12, and that becomes a standard thing that can be launched from a launch ejector. They are launched in an interesting way. Imagine you've got 3 of those on top of each other inside a box. The box will have a lid on it. At the bottom of the box is a spring. Once the major payloads have been launched off the rocket, the prime with the secondary, there'll be then a set of these little boxes around the top of the rocket. And in turn, the lid's open and the spring pushes a number of satellites out.
So it's like a jack-in-the-box,
It is
essentially,
exactly
as I'd
like
call
a
it.
jack-in-the-box.
Well, look, we've got a video that we'd like to play out, and while the video's playing, because it hasn't got any sound on it itself, so maybe you'd help us talk us through it. So if we could start the video, Tammy, please. And you can talk us through the bits and pieces, if you would.
This is the AMSAT North America CubeSat sim. The boards you can see there are representative of what would be inside a normal CubeSat. Something like 6 boards. The image here basically is the kit that AMSAT North America provide to be built by organisations doing STEM outreach, etc. There'll be a battery board, there'll be a processor board, there'll be a sensor board, and there'll be a board to manage all the solar panels that you can see actually on the device you're holding. It also has a camera on board. What you're seeing there is the inertial measurement unit. So basically, it's a gyroscope that can manage all 3 axes. It's also got an accelerometer on board. The idea being that with this particular simulator, you can put it on something like one of the rotating cake stands with a bright light shining against it. And you can actually see the solar panels illuminating as the device goes round. What you're not seeing here is that AMSAT North America, with their Fox series of satellites, built a dashboard to run on a PC. This particular CubeSat sim can use that same piece of software on 70SEMS to receive the data, and so you can actually get the feedback from all the sensors on board, what the voltages are, what the currents are on board.
You mentioned sensors, you mentioned accelerometer. What other sensors has it got?
It will have pressure and temperature sensors. It's limited in what it can do.
Sure.
It typically transmits its information about once every 5 seconds or something like that, which is typical of a CubeSat. With FunCube 1, which is the AMSAT UK satellite, you can see there the assembly on somebody's workbench. In reality, if it was a space qualified, it would be done with a little bit more
with a few white suits, I think, and some dust extraction.
I looked to see that he actually hasn't got an earth strap on his wrist either.
Oh. But still, nevertheless, it really brings science and technology and radio into the hands of youngsters in particular.
Yes.
It shows them these satellites that people talk about are real things, and I mean, I'm surprised how small it is.
Yeah. What I should say is that the device you're holding is actually owned by the RSGB and was used at the Brooklands contact with the ISS
last weekend
as part of the outreach to show the Girl Guides what something in reality looks like.
It is incredible. I saw the word Raspberry Pi camera on part of that, so it's got a camera built in?
It has a camera built in, yes. The camera is...
we're looking at the video at the moment, but I'll show you in a moment.
Yeah, the camera is on one edge. You're peeking through the solar panels. The device can send CW, it can send telemetry, and it's also got some pre-stored images on it as well, which it can transmit.
Absolutely fantastic. So this is the sort of thing, it was developed in the US, did you say?
Developed in the US by AMSAT North America.
Right. And AMSAT UK, though, are starting to use this sort of thing, maybe, or try and interest UK schools?
We actually sell them in the shop.
Okay, really?
Because they come as a kit of parts.
So anybody can buy one of these?
Anybody can buy them.
Rough price?
I don't, without looking at the shop, I don't know.
Your website is AMSAT?
AMSAT-UK.org.
AMSAT-UK.org. Okay,
yeah.
Well, people can go there and have a look as well. This is a fantastic thing, and of course it's also, as well as showing people what a satellite can do and what it looks like, it can help with crafts like soldering and construction and things as well.
To some extent, it's actually it's all discrete components, except for one board, which is the RF board, and that's all surface mount, and basically it's actually bit banging on 70SEMS. So they've got to have a low pass filter, to get.
So that's pre-made, is it? A pre-made module,
pre-made,
basically.
Yes.
Yeah.
But other than that, the components are mainly discrete components.
Well, we can see this video still on the screen, and you could just adding the last bits now. It looks like the solar panels.
Yeah, and the antennas.
Oh yeah, and now they're going to test it, I guess.
Yeah, and it's going through its initial startup.
Now that looks like a lot of fairly expensive test equipment. There isn't HP probably. A spectrum analyzer or something like that, but I presume for somebody building this at home or maybe a school, they don't need all that equipment.
No, basically it'll be a dongle, an RTL dongle or something like that, going into a piece of software. That's it, fully assembled, and you see the remove before flight tag, which I haven't got with me.
No, it's lovely. Yeah.
When that was handed to me by Steve this morning, it had the remove before flight in it. So can I?
Did it?
Yes,
Yeah.
of course
Oh, very exciting. We're going to just show that with that camera. That was here, wasn't it? Where it was going. So I'm just going to show that up close up to the camera.
That's where the camera would live. Yes.
There we are.
Yeah.
So the camera's going to live there. That is absolutely.
You can see some of the internals of the main board. I think the one with the LEDs on it is probably one of the
this one here?
sensor boards. I think. Yes. And lots of light, lots of. Yeah, that is the sensor board.
If I hold it in a bit closer for you there, if you focus in on that, Kevin, if you can. There we are.
I think if you can see, I'm not quite sure if the blue LED. Yeah, the blue LED is actually indicating transmission.
Wonderful. So, anyway, Dave, thank you very much, particularly for talking through this, because I thought that was wonderful to show our viewers. What else about AMSAT? Why people can join? Anybody can join it?
Anybody can join it.
Anybody at all? Right.
Yeah, it's we're going through some change at the moment. You appreciate that you know yourselves that the publishing of a magazine is quite expensive. So we're going through some changes about how we actually produce Oscar News at the moment. But
I was talking to Don Field this morning about the cost of papers just rocketed and things like that. So,
exactly.
So you're looking at, I guess, electronic ways of communicating.
Exactly. AMSAT North America and AMSAT DL have already gone electronic. But I think we've got something like 440 members worldwide. We've got a not insignificant amount of money in our satellite building fund. We are currently working with the University of Surrey and 3 other universities to put 3 of our boards into a satellite, a 6U satellite. But we're also undertaking a design of our own satellite, a follow-on from FunCube. FunCube's now 10 years old and it's still going, but it will die eventually.
Yeah.
So we've got
roughly how long are we looking at? Months, years?
Oh no, we're probably looking another 2 years, probably 2 or 3 years. And we're fortunate that because we tested it so well, we really did test it. In those 10 years, the battery has only dropped 0.2 of a volt in terms of
presumably some kind of lithium technology battery.
Yeah,
but yeah, that's still amazing.
We do little tricks with the battery on board because lithium doesn't like to be charged below 0 degrees. So we put the battery right above the PA.
Oh, just to keep it warm.
To keep it warm.
Dave, it's been lovely. Thank you for joining us today. Thank you for telling us about AMSAT and particularly this wonderful. Well, it's a simulation, I guess, but of a satellite. I think that's really incredible. Thanks very much for joining us today. AMSAT-UK.org is where you can find out more information. We're going to rush back to GB3HQ now, see what they're working.
Yeah, Gulf Whiskey 7, Alpha Zulu Charlie, good afternoon to you. This is Gulf Bravo 3, the headquarters station of the Radio Society of Great Britain. Your operator hit this afternoon is Simone, Sierra India Mike Oscar November Echo. So how copy? GW7A Zulu, Alpha Zulu Charlie, this is GB3HQ, over. Yeah, GW7, Alpha Zulu Charlie. The QSB's got you. QSB got you there, but I've got the report. Could I have the name, please? The name, please, over.
Name's Alan. After Lima, after November. Alan.
Yeah, roger that, Alan. You came out of the noise then. That's super. Thank you very much. All details have been received. If you want to work the RSGB president, then this afternoon he will be on air around 3 o'clock on this frequency. Here, running his own call sign, GB4RS. So if you want to get that rather rare call sign in your logbook, then here's a perfect opportunity to do so. 7-3 from GB3HQ. Bye-bye.
November Kilo Sierra.
Yeah, bye-bye. Right, November Kilo Sierra.
Delta Lima 1, Delta Lima 1, November Kilo Sierra.
Delta Lima 1, November Kilo Sierra. Good afternoon. from GB3 HQ. This is my operator name here is Simone, Sierra India Mike Oscar November Echo. You're coming in 59+20 into the RSGB convention in Milton Keynes in the middle of England. How copy? Over.
Right, thanks for the RSGB convention. Very good. You're 59+10 and then it's Steve. Sugar Tango Echo Victor Echo Steve operating north of Bavaria, Germany. Thank you. Have fun. Delta Lima 1 November Kilo Sierra. Bye.
Thanks very much, Steve. Take care. Bye-bye. QRZ, this is Golf Bravo 3, Hotel Quebec. Over.
Good afternoon from Golf 4.
Yes, Golf 4, go. Yes, station Golf 4. This is Golf Bravo 3, Hotel Quebec. Come back. Nothing heard. A very loud Golf 4, but gone. QRZ, this is Golf Bravo 3, Hotel Quebec.
Mike, 7 Yankee Delta Papa.
Mike 7, Yankee Delta Papa. Good afternoon. Yes, we worked yesterday, didn't we, Damon? Nice for you to call in again. Thanks very much. Over.
Yes, just getting me logged in. Thank you very much for your call. 5 and 9 into Nottingham.
Lovely, thanks very much. Take care, and it's 59+ here into the convention. Take care, 7-3. QRZ, this is Golf Bravo 3, Hotel Quebec. Over. CQ, Golf Bravo 3, Hotel Quebec. Golf Bravo 3, Hotel Quebec. Contest. No, not a contest. Golf Bravo 3, Hotel Quebec. Golf Bravo call signs don't contest at all, ever. Do we? Oh, well, there we are. Anyway. Yes, indeed. GB3 HQ, QRZ.
Mike 5 Kilo Victor Kilo.
Mike 5 Victor Kilo, Kilo Victor Kilo. I'll get it right way around in a minute. Good afternoon to you. Simone is the name. Sierra India Mike Oscar November Echo. And we're live at the RSGB convention. So you are 59+ coming in. How would you copy us? GB3 HQ, over.
59+ from here. Infinite, not too far away from you. Very strong signal. M5KVK.
M5KVK from GB3 HQ. Lovely, fine internet, as we say, just down the road. But thank you very much for calling in. Take care, 7-3. QRZ, this is Golf Bravo 3, Hotel Quebec. Over.
Good afternoon from Golf number 4, Foxtrot Yankee. Over.
Yeah, Golf 4, Fox Yankee. Good afternoon, Golf Bravo 3, Hotel Quebec. You are 59+. Very good signal here into the convention in Milton Keynes. How copy? Over.
Yeah, many thanks, Simone. Handle here is Ray, Romeo Alpha Yankee. You're coming on 59+20, 59+20. And yesterday I was watching the live stream as well and could see you operating. So well done. Keep up the good work there.
I'm here with RSGB President again. So, John, we're going to be talking about the RSGB strategy. Now, John and the Board of Directors were talking to the visitors here yesterday in a Meet the Board session, mostly about the strategy, lots of other questions as well, but mostly about the strategy of the RSGB. And we thought it'd be really nice to just give John an opportunity to just talk through some of the things that were talked about in that session. So, John, I know that the sort of roughly the main topics were the update that you give, or you gave recently in Radcom about how the strategy has progressed, but then also about the growth workshop that was held earlier in February, I think, and what progress has been made there.
Yeah.
And then there was another section really about some of the outreach activities and the engagement activities, I think we might call them, and that's particularly interesting, that area, I think. But would you like to give some sort of summary of, how you see the strategy and maybe the session yesterday?
Yeah, well, maybe the session yesterday, but I could take it back to the session last year, whenever we started this process off, really. Yeah. And whenever I came onto the board, just before that, we'd been thinking about, where was the society going? And there had been a very involved, a very detailed strategy
produced, but it hadn't really got anywhere. I think possibly because it was too difficult.
Yeah.
We had a rather, I think, pessimistic interview that time, way back in 2023. This year it was much better because we've gone a lot further. We really have moved forward now.
I think it was much more positive, wasn't it?
Much more positive, yeah. Things have been happening. We actually got things moving, and it was really good to see that. I mean, whenever I looked at where we were, whenever I came in, I thought, you know, if we don't know where we're going, we don't know what road to take.
That's about 18 months ago.
That's right. Yes, it is. Yeah. If we don't know where we're going, we don't know what road to take, and we really have to map and plan a path forward. We had a very detailed plan, but I think it was so difficult that the board in general found it very difficult to operationalise it and turn it into something on the ground.
And of course you need this sort of overarching strategy, don't you? And then you work down more into the details.
You work down into the detail.
And I think that's where that detail was where it got a little bit stuck, isn't it?
That's where it got stuck. We rationalised, if you like, the big strategy, we want to call it, down into 4 strands, which everyone has seen. I'm not going to repeat them now, but the top one was growth, and that's the one we've really been concentrating on. And we started off then with a growth workshop in February of this year, which really got things going, got things moving.
We invited there some people that we thought could move things forward and have some fresh ideas and things like that. And I know you were at the workshop. What did you think about it?
The workshop was very good. It was interesting when you looked at the way things were formed up. We had a facilitator who was actually very good and showed us how to put things together. And there was one famous thing that she did where we put dots on the things that we thought were important, and getting the right people in the right place at the right time was one of the most important things.
Yeah, absolutely. I think that's true, and of course that goes across staff, volunteers, and everybody. I think, as well as staff and volunteers, amateurs as well, you know, and
engagement.
Engagement, absolutely.
Yeah, getting people engaged, and I think we've started on that, and the real thing, the thing that's really good going is outreach, and we've got a lot of work going outreach and engaging with people, particularly in schools and STEM projects, all that sort of thing, and that really is the way to go. Engagement.
There's quite a few strands of that as well, and we know Ben Lloyd on the board is leading that outreach activity. But there's some involvement from my staff team as well, and our volunteers. Perhaps at the NRC, we're doing a lot of outreach there, of course.
The NRC is a tremendous facility,
But Ben's looking at all sorts of new ways of outreach to add to those things that we do.
We're looking at all sorts of people that we can engage with. I mean, Ben obviously looking at, he's a young director, and he's looking at probably younger things, but we're all sort of tacked onto that. And I'm looking at, would you believe, more mature things?
I find it hard to believe, John. I don't know.
You couldn't possibly guess.
No.
But we're looking at engaging with other audiences, if you like, and mine's the mature audience segment. We're looking at engaging with U3A and people like that, and Provost clubs, and actually had a lot of interaction with them already, with U3A members. We did an advert on Rodcom, and we've got a lot of people coming back.
There was a lot come forward there, wasn't there?
I've actually written an article in Rodcom now, looking at a summary of where we are, and it'll be appearing in December, I think it is. It will be appearing, and I've tried to summarise where we are, where we've got to, and the various things that have happened along the way. And I hope people will find it interesting. And if you remember, back in 23, I promised to tell people where we were going, and we would have reviews every month, and we have kept to that promise, and we intend to do that and keep doing that.
And I think that's a very important factor, isn't it, to keep people up to date, because otherwise they think nothing is happening. Whereas the reality we know is there's a lot happening. But just finding a way to let everybody know about that and get other people involved as well. Because this is not really about the RSGB saying what should happen. It's trying to start some of those things, isn't it? And engaging with people, looking for people with those skills. There's all sorts of things mixed into here. It's not just writing up a plan and having done with it.
It's not.
There's a lot of activity that goes on behind it.
Well, when you look at what we were doing, for instance, we've got Mark Jones, who's recently on the board. He was on the board some years ago, back on the board again, and he is tasked with taking the strategy forward, keeping us all on our toes, which I think is what we need, and keeping the board on their toes as we move forward, and getting everyone engaged, getting everyone working.
And Mark here at the convention has been running some of those programming workshops, which have been fantastic. People have really given us some positive feedback.
He's been running a microcomputer project.
Absolutely.
He's oversold.
It was oversubscribed, wasn't it? Yeah, absolutely. Yeah. But those practical activities and some of the engagement, like British Science Week and National Coding Week, all of those things that are going on are being really well received, aren't they?
It's amazing how things like British Science Week have been taken up, how the STEM projects have been taken up. For instance, if you look at the engagement we had recently, the ISS contact at Brooklands, tremendous. We had 100 girl guides and brownies there for a contact with the International Space Station, where HRH, the Duchess of Edinburgh, was there. And the girls had said, some of them apparently said to them, we don't really want to be involved in something like this. It's a tacky type project. It's not for girls. At the end of it, they actually couldn't drag the girls away. They had the ISS contact, and they were really on high after that. And they came upstairs to the projects, the STEM projects we had running, snail Morse keys, microbits, all those sorts of things running.
It was
and
fantastic,
they were absolutely over the moon.
They loved it.
You couldn't drag them away. That's the sort of thing now we need to move forward with. I mean, follow that is really the where do we go?
But the reason they loved it, I think, is because it was practical. It was hands-on. It wasn't just somebody talking to them. They actually got to do it.
They don't like being talked to. I think they like being in there doing something.
And of course, license changes means you can get people on the air as well. That's a really important factor here. So we can actually take and engage with more people in more different ways. That, I think, is one of the keys of the strategy.
I think the new license gives us all sorts of opportunities. It really does, where we can let people actually operate properly under supervision, obviously, and that gives them a great sort of input into amateur radio in the first place.
Excellent, John. We've got to move on. The next part is coming up. Thank you so much.
Thank you, Steve.
Wow, a year in numbers from the RSGB. We're now going to see our penultimate presentation for the weekend, a beginner's 3D printing for amateur radio.
Good afternoon. My name is Colin Smithers, G4CWH. I'm your MC for this session, which is going to be on beginner 3D printing for amateur radio, given by Tom Wardill, 2E0JJI. A couple of church notices. If there's a fire alarm, it's real, and the minimum order quantity for raffle tickets is going up very rapidly. You must make great haste and buy some more. So 3D printing is a powerful tool, one that's becoming increasingly accessible in recent years. This presentation is a brief overview of how to get started, where it can be useful in your life as an amateur radio enthusiast. Tom will cover as much as possible, including machines, software, tools, and where to find things. He aims to leave you in a position to learn more and get yourself started. Hailing from Sheffield, Tom is new to amateur radio, but has been making things all his life and has been collecting hobbies for just as long. Anything from pack rafting to high-altitude balloons to sewing to adventure racing. Enthusiastic about things, terrible at finishing projects. Tom, the floor.
The aim of this is that ideally you'll go away knowing what to put into Google and to be able to get a little bit more information about and understand a little bit more of what people are talking about, because there are a lot of words, there are a lot of acronyms, it is a topic on the internet, so there's a lot of controversy over which way you do things and things like that. So making robots, make tools. Here we go. Very rapid demo of a technology that is famously unreliable. Here we go. I'm relatively new to amateur radio. I passed my foundation in March, my intermediate relatively recently. And like a lot of people, I started with one of these. It's a Krangchang UV-K6, 8, a number, 8. So I carried this around for a little while, and as you do, I lost the volume knob. Slightly annoying, still usable, but slightly annoying. So, here we go. I'm just going to flash through this, and then we'll go backwards and talk about it, because the demo takes a little bit of time to get going, so here we go. So, this is Printables, a repository of printable things. I went to there, I put in UV-K5, whole bunch of stuff for the UV-K5, and then the UV-K5 volume knob. Brilliant, that's what I want. I want one of them, please. So I press download. My internet stops working, but that's okay. Let's pretend that downloaded. This is what's known as a slicer. I'll go into what that means shortly. But what I'm going to do is, this is very awkward to operate from this angle, but here we go. Boop. I'm going to load my file that I downloaded. I'm going to press slice. There's going to be a bunch of complicated math that doesn't quite fit on the screen, but I'll cover that again in a minute. I'm going to press print, and I'm going to press upload. Hopefully, I've got enough working internet that that's going to behave. If not, I am prepared for that as well. No, okay, so I don't quite have enough internet, but pretend that did the thing. This is where it all goes horribly, horribly wrong. The slightly annoying thing about this being upside down is that it's quite hard to see what it's doing. Okay, that looks like it's doing a thing. We'll leave that alone. If somebody can just keep an eye on that and make sure it's not, caught fire or something. Right, so now that that's going, let's talk about 3D printing. So what is 3D printing? It's a broad topic and has some different things. It's known as additive manufacturing. Most manufacturing methods are subtractive in that you start with a thing and you chop bits off it to get the thing that you want. Additive is the reverse. You start with some raw material and you build it from scratch. There's lots of methods that come under 3D printing, some of which are accessible as a home person, some of which definitely are not. And generally, it's taking a thing, turning it into some layers, and then using some form of methodology to produce a physical object. It's become a catch-all term for a lot of techniques now, but generally that's what it is. So the three big types of 3D printing, again, there are many, but here we go. FDM, fused deposition modeling, that's this type of printer. You stick melted plastic together with heat. You take a glue gun, you turn it sideways, and you move it around a bit. That's literally it. SLA, stereolithographic addition, or something along those lines. You stick resin together with UV light. You have a vat of resin, you shine some UV at it, it goes solid. It goes solid and sticks to something, and then you move the thing up and new layer under it, and you shine UV at it, and gradually it builds a thing out of layers. And selective laser sintering, this is the other one you'll come across a bit. That's sticking metal together with lasers. Vat of powdered metal, you sweep it with a high power laser, you then apply more powdered metal. This comes up a fair bit if you look at, it is relatively natural to say, oh, I want to print things in metal. I would like metal objects. Last I looked, an SLS machine starts at £50,000 and prints a thing this big. When I say not all forms of 3D printing are accessible to the home user, that is one of them. But it does come up, and I would recommend you go and look at it. It is an interesting technique that's doing it's changing a lot of metal-based manufacturing, particularly vintage car parts. But yeah, it's not something you can do at home. So I'm going to briefly touch on SLA printing. This isn't really this isn't a topic I'm going to cover, but it is the types of printing you have accessible as a home user are FDM, plastic, or SLA and resin. It's resin-based, UV-treated, and the machines themselves, the printers themselves, they're relatively stable now. They're between £300 to £1,000, depending on which ones you want to buy and what size you want. It's really good for very fine detail. Like if you play Dungeons and Dragons and you want custom miniatures, this is the type of printer you want to buy. The resin itself isn't particularly durable. You can definitely get engineering resins, but if you're paying £1,000 a kilo, then you probably don't want to be in this talk. And the other major drawback with SLA printing is the resin is pretty toxic. You do not want one of these in your house. Yes, you can buy carbon filters for them. Yes, you can do fume extraction and things. The point to make here is you can do all of those things, and you need to. You can't avoid it. It's contact sensitive. If you really don't want to get it on your skin and go out into the sun, because that hurts. Been there. But yeah, I kind of don't want to put you off. I just want to say these are the risks that it's the trade-off. But the level of detail you can get out of this is incredible. It looks like it's if any of you play Warhammer or anything, you can make those models, and it's easy. But yeah, the reason it's not covered, particularly other than this slide, is it's non-structural, it's not very robust, it's not really the kind of thing you want if you're trying to make things for radios. FDM printing. It's the most common form of 3D printing. This is kind of what people think of when you say, I've got a 3D printer. That's a Creality Ender 3. It melts plastic and sticks it to more plastic. 3-axis movement. there's many options when I say plastic, filament, many options, lots and lots of options. Lots of variations, lots of different capabilities, different capacities. We'll cover some of them. And this is where, if you're looking at getting into 3D printing or you want to buy a 3D printer to make your radio hobby easier or better, you need to make a decision here. Is your hobby 3D printing? Or is your hobby radio or something else, and you want to 3D print for it? That's quite a fine distinction, but if 3D printing is your hobby, like it kind of is for me, then you are going to spend all of your time working on 3D printers and never having one that works. If you are 3D printing for your hobby, then that's the point of this talk, is that that is now completely accessible, but it will change what sort of printers, what brands, what manufacturers you're looking at buying, and kind of how much you're going to spend. Not a huge amount, but for a lot of people, it kind of, you start with, I want a 3D printer to do this thing, and then the 3D printer goes a bit wrong, and now, hey, you've got a 3D printing hobby. That's how it used to go. It can still go that way. It's how it went for me, but it doesn't have to. So, what do you need to do some 3D printing? First thing, you need a thing to make. You need a model, otherwise known as, if you're Googling something or looking for something, going to Google and putting in volume knob, STL. An STL is a type of file, it's a stereolithographical file. They are the most common, 95% of 3D printed things are printed from an STL. There are plenty of places online where you can go and download them. I'll talk about them in a minute. So yeah, what do you need? You need a model. Your next job is you need a slicer, which is the program that takes your model and turns it into something that your printer understands. I'll talk about that in a minute. You need a printer. I mean, yeah. That's not actually true. There are lots of services online now where you can upload your STL and receive a printed file. Shapeways in the US, bunch of others in the UK. Probably a few of you may know friends who have 3D printers. Buy them beer, get 3D print, kind of works. And you need filament, which is the thing to make it with. An illustrative roll of some filament. So, finding models. On the left, we've got a suggestion for places to go. On the right, we've got programs that you might want to do some modeling in. Printables was the one I just shown. It's my recommendation. It's nice, it's clean, it's run by Prusa, the printer manufacturer, and it works generally quite well. Thingiverse is a little bit older, but tends to have a broader selection. The quality of the actual website isn't as nice, but Thingiverse is quite good. Cults 3D is quite an interesting one. That is home of a lot of people who sell their models. So a lot of models people put on for free. I've made this thing. For example, my shower door broke 2 weeks ago. I found an STL for a new hinge and printed it, and done. It was free. Cults is more orientated towards commercial. You're probably not going to find a huge amount of radio stuff on there, but if you want artistic things, figurines, vases, miniatures, that sort of thing, good place to look for that. Google, I mean, it's obvious, but yeah, what you want is Google thing STL, or 3D print, or something like that. There's a couple of accumulation sites of words. Yegi is a good one. It looks at the other sites, so you it's a meta database of them. And designing your own isn't as hard as you might think. FreeCAD, Fusion 360, Onshape, stick those into YouTube. There are academies, there are places, there are courses, there are people who publish tutorials for them. They take a little bit of getting hang of, I'm not going to lie, but there are some really good YouTube series you can just sit and watch. There are some really good courses you can buy that are pretty good. Props Academy do a really nice Fusion 361. OpenSCAD is free and open source and is programming based to create your model. I don't understand it. Blender is on there. Blender is much more orientated towards organic shapes. It's used by the computer graphics industry to do films and things like that. It's got a learning curve. That one is hard. I've never got the hang of it. It's famous for having a user interface that is opaque, but it is learnable. People do some fantastic work in it. Another part of this talk is to try and inspire people to take up 3D printing. It's fun. So things you can print. If you're into packet radio, that's a Nino TNC in a free case. I built the kit. I printed the case. And the best thing is I got to choose what color it was. So it's bright yellow. Okay. How are we doing on time? Cool. Yeah. What is a slicer? So I touched on earlier, 3D printing is layers. So what you do is you get your model. You download your model off the internet. It is a 3D model. What you need to do is work out how to print that. And functionally what that's doing is the printer is going to print a layer of plastic and then move up a little bit, or down in this one's case, and print another layer, and then print another layer, and then print another layer, and until you've got a layered thing. Which is fine, but you need to have those layers. And also what you need is the code to tell the printer where to move. It's moving in 3 dimensions. So you need that code. You can write that code by hand. I don't know anyone who does, but you can. I wouldn't. So a slicer is a program that takes your 3D model, converts it into layers, and then writes the code for you that you then upload to the printer. This is a neat little thing that I found on Printables. They run competitions, like design competitions with themes, and one of them was soldering helpers. Great. This is a little PCB holder. It pulls out, you put your PCB in it, you clamp it, and it rotates, which when I was building the Nino, really useful. Right, so we'll see how this goes. So this is the slicer that I use. This is called Orca Slicer because it happens to have a pre-built profile for this printer. Other names you may come across, Prusa Slicer, mostly for Prusa printers, Bamboo Studio for bamboo printers, Cura is another one. Cura works really well. It's quite an older program, but it's still maintained. It's still updated. It's quite nice, but it doesn't work with this printer, so I don't use it very often. So what I've done here is I've loaded my model, my volume knob for my radio. On this side, I've told it which printer I'm going to use, what material I'm going to use, which we'll cover in a minute, and what settings I'm going to use. So when I say everything's layers, the quality of a print is determined by how big those layers are. You can imagine if your layer is 1 inch tall and your model is only 1.5 inches, that's not going to work. I mean, you can't have inch layers on a printer. But so we work in, it's actually microns, but everybody quotes them in decimals of millimeters because I don't know. So this is 0.22. 0.20, sorry, which is each layer will be 0.2 of a millimeter tall. For a modern printer, that's a relatively standard print. If you've got an older printer, 0.3, 3.5, 4 might be more common. If you want super high quality, getting down to 0.1, 0.2, 0.12 is common. The other flip side to that is the more layers you've got, the longer it's going to take. So there's your trade-off. You can have high quality, but your thing that this is tall is going to take 4 days. Or you can have slightly lower quality, and it might take 3 hours. The thing with the slicers is that they will tell you how long the printer is, they think the printer is going to take. It's not always accurate, but it's close enough. And then, if I can, annoyingly, this won't full screen, so I can't actually scroll down? No. Okay. There are a couple of other things that influence what your print will look like and how it will act. You can do, so, some prints you want to be strong. They're a door hinge, they're a shower door hinge. That means what I want, your initial instinct would be, I want it to be solid plastic. That's not actually as strong as doing it 90% plastic because you eliminate the chance for it to flex. So what I mean from that is the infill in the print. If you imagine a cube, the infill is how dense it is, how much it has filled the inside of that cube. And that's measured in percentage. So anywhere from too low and it won't print, so 7% is about the lowest you can get, all the way up to, you can do 100%, you can print it solid if you want. Again, that also affects how long it's going to take, because you're printing more things. And the other major strength indicator is how many walls it's going to do. So if you've taken your cube and hollowed it, and then you've printed some infill in it, how many times it's going to go round the edges. Because if you only do it once, this plastic doesn't stick together that great. It's probably just going to snap, which is fine. If you're like, hey, I need to see whether this fits, print it as fast as I can. I want it in 20 minutes, go. But if you want something strong, the classic example would be the Voron printer parts, which, like parts of that printer are 3D printed. They do 5 walls with 40% infill. They consider that to be the strongest you can get. I don't know whether that's true, but in terms of things you might need to know as a beginner, when people are talking about infill and walls and ceilings and floors, that's kind of what it means. You can experiment yourself for what you want. But then if we go to a preview, it's not going to show me because everything's massive. Great. You can just see, will that go away? No. Okay. You can just see like the slicer has pulled down and worked out how much time it's going to spend doing walls versus infills versus outer walls, inner walls, tops, bottoms, things like that. So you can see like, oh, if you want this print to go faster, you can see what you're doing the most of and change it. Cool. I appreciate my demo there wasn't ideal. Did that kind of make sense? Yeah? Everyone feel like they might be able to shove some terms into Google and get some definitions. Great. Okay. Oh, no, we did that bit already. Filament types. There's a bunch of types of filament. Different brands call them different things. They're not always true. The standards are PLA, PETG, PETG, depending how you pronounce it, ABS, ASA, and TPU. That's a bunch of acronyms. What does that mean? PLA is what this printer is currently printing. It's finished. Excellent. It's cheap. It's pretty easy to print. It comes in a range of colors. It comes in a range of materials, of mixers. The internet will tell you that it is compostable and biodegradable, and therefore it's fine because it's technically a cornstarch, not oil-based plastic. Yes, also no, in a meaningful amount of time. Yes, it's technically biodegradable if you've got geological timescales. It's not going to compost in a meaningful amount of time, which is a shame. It's plastic. Being mindful about the environment is important, and plastic that doesn't degrade is a bit annoying. Very annoying. PETG, so PLA is quite brittle. It's pretty good. It's pretty dimensionally accurate. It's quite brittle. PETG is a bit better. It's got a little bit flex to it. It's also fairly easy to print. It has a couple of different qualities. But it's also pretty cheap. So in terms of cheap, PLA, I'm paying about £10 a kilo. PETG, probably 15 a kilo. And then you've got the things that need specific printer features. TPU is a flexible filament. Unfortunately, I didn't bring my Brompton, but my Brompton has squishy parts on it to keep the locks in line. And it's genuinely squishable. Like, it doesn't quite work as a bouncy ball, but it's quite abrasives. So TPU needs a specific feature called a direct drive on your printer. Most are now. But yeah, if you're looking to print TPU, you need a direct drive printer. Abrasives, there's a good mix of filaments these days. Like you can buy plastics that have carbon fiber embedded in them, or marble, or wood, or brass. They look super cool, and particularly the carbon fiber, it's much stronger. It has a really nice attributes, but that will destroy your nozzle if you put it through a brass nozzle, which a lot of printers are. They are literally abrasive, and it particularly glow in the dark. Glow in the dark has ground up glass in it. It is literally sandpaper you're putting through your printer. You can get hardened steel nozzles. That's what you want. And harder to print and more durable, ABS and ASA, they're a styrene-based plastic. ABS is pretty common, like injection molded plastic. They are harder to print. They warp as they cool. So you need a printer in a box, and it needs to be heated, ideally. But they are super strong. They're UV stable, so you can use them outside. PLA, don't print a part for your radio in your car in PLA. Its melt temperature is 60 degrees. That's quite easy to hit in direct sunlight in a car. It will melt. Not dribbly melt, but like your box will go like this. ABS and ASA, their glass temperatures are over 100 Celsius. If you're hitting that in your car, you've got more problems. And yeah, someone mentioned stands for radios. That's my G90 with a 3D printed stand. With a little, I actually inverted one of the stands and clamped my Nino to the top of it because I do pack it. Safety warning, ABS ASA contains styrene. That is toxic. And if you're printing it and melting it, that is an airborne toxic. Print them in enclosures with filters at a minimum, or do what I do. I print mine in my garage, and my garage has enough holes in it that it basically counts as counting out as printing outside. Things get hot, and things can move unexpectedly. It's very easy to go, ooh, that's gone a bit wrong, put your hand in the printer while it's working. Don't do that, it hurts. Picture, that's some cable mounts that I printed for fitting solar panels on the roof of my van. How are we doing on time? Yeah. RF and filaments, this is a radio talk. There's not a lot of public information. A lot of companies have done studies for it, but they don't release the studies because it's commercially sensitive. ABS, PLA, ASA, they're generally considered to be RF transparent because they're used all day, every day. Don't put your printer in a 4-foot cube of PLA, like that's probably not going to be transparent, but in terms of putting it in a box, probably fine. Mixed material filaments, so the filaments that have metal in or carbon fiber or anything like that, they're probably not going to be RF transparent. I was having an interesting discussion earlier about, can you 3D print an antenna? I don't know, but now I really want to find out. There are now RF-specific filaments. There are filaments you can buy that have known dielectric properties. People are printing microwave antennas, which I only discovered while Googling this last week, and that's cool. And yeah, you can get conductive filaments. They have a high enough metal percentage in them that you can print circuits, which I don't know why you would, but it's kind of neat. Again, this is a little 3D printed desk cable holder. Sticks on the side of my desk, holds all my little USB cables and such. I looked on Amazon. These are £6 each. That's like 18 pence worth of filament, and probably the same in electricity. Choose a printer. It's 2024. Printers have improved. If you've got or come across MakerBots, the early Crealities, things like that, they're great. They're well-known names. Don't buy one. Controversially, the internet is going to hate me for this, don't buy an Ender 3, which are the common printers. I had a picture of one as a 3D printer. They were released in 2018. And yeah, they've improved them, and there's a whole bunch of aftermarket support. My kind of thing with that is there's a whole bunch of aftermarket support for a reason. Don't get me wrong, if you've got an Ender 3, don't throw it in the bin and buy something else unless you really want to. But there are better options at the same price range now. So things you want. Heated flex plate. What does that mean? Right, well, print beds, modern print beds should be heated. If you've come across a printer that doesn't have a heated bed and you're not buying it for a very specific reason, don't buy it. It's not worth your time. Ideally, don't buy a glass print bed in 2024. This actually ships with one. You'll notice it's not glass anymore because I changed it. And yeah, flex beds. So the problem with printing is your print is on the print bed. It is stuck to the print bed. If you've got a magnetic flex plate, then getting it off, you take it off like that, and you go like that, and your part just pops off. You'll see a lot of talk of people saying, oh, you can't buy a 3D printer without you buying a scraper and a whatever, and like, just buy a flex bed. Just get a printer with a flex bed. So, yeah. There you go. What's that? 20 minutes? And I got to choose what color it was. Because everybody's got one of those radios, so having a green bit on it, it means I know which one's mine. Direct drive. Direct drive means the actual gear mechanism that's doing the extruding is at the print head, which means it's pushing the gap between where the plastic comes out and where it goes in, has all of the bits in it. This is really important for printing TPU because it's flexible. Older printers, or some design printers, this one particularly, are Bowden printers, and they have the extruding mechanism further away from the print head. If you're printing a TPU flexible filament, it can't push the filament into the print head because it just flexes inside and it all turns into spaghetti. Direct drive means you can just print straight through. Most printers these days are. 300-degree minimum hot end. Some filaments need higher temperatures. If you're buying a printer in 2024, buy one that says it can do that. Realistically, it's not. You're never going to get to 300. I print at 220, 250. But one that's, as ever, one that's quoted at 250 will not do 250. Core XY, getting a little bit technical here, that's the architecture of the printer. Core XYs are belt-driven. They're usually distinctive in that they're a square box frame and the bed moves up and down rather than forwards and backwards. They're generally much faster, much more reliable. And it should run software called Clipper. That's all you need to know. You can, if you're looking at a printer and it says Clipper, get that one. If it says Marlin, kind of know what you're getting into. Maybe Google it. Probably implies it's an older printer that they've rebranded. Not always, but on the whole, if you're choosing a printer, look at that. Choosing a printer, part 2, brands. Bamboo Labs, Prusa, Eligo, Creality, Creedy. Bamboo Labs are the internet's darling at the minute. If you don't have a fundamental objection to a closed source ecosystem, which a lot of people do, and that's entirely legitimate, buy a Bamboo Labs. That would be my recommendation as a beginner for a 3D printer. If you, at whatever budget you've got, if you're new to it these days, buy a Bamboo. Prusa are also extremely good. They tend to be a bit more expensive for their capabilities, but their aftermarket support are brilliant. They're like, Prusa are great. For a long time, they were the leading printer company. Eligo, Creality, Creedy. My advice for those is you can definitely get some good printers from them. Do some research, read some reviews, watch some reviews on YouTube before you choose the specific printer. I, for example, run a Creality K1 Max as my big printer, which is this big, 30 centimeter square cubed print bed. And this one, which is a positron. As a beginner, avoid a Voron. Vorons are kits. Well, technically, Vorons are designs that companies then sell kits for. Sounds like a great idea, because, hey, I'll build it from a kit, I'll learn how it works and the rest of it. To build a Voron, you need to own a 3D printer. Or you need to buy the 3D printed parts from someone else. I have built a Voron, I own a Voron. I can't honestly recommend one to a beginner. Know what you're getting into if you're going in a Voron. Again, avoid kit printers, apart from Prusa. Prusa's kits are really good. They're fully documented. They ship you some gummy bears in the box. They're really nice. Large format. So my K1 Max is 30 centimeters cubed. That brings its own problems. The quality I get off my big printer isn't as good as I get off my small printer because physics. It's physically moving things, heavier things around. Nothing to say you couldn't, but as a beginner for your first printer, maybe don't, unless you specifically have a need for a large printer. And again, as a beginner, don't buy a printer from AliExpress. You can definitely buy good printers from AliExpress. Try and buy one from somebody who at least has a semblance of aftermarket, like customer support. My Voron came from AliExpress. That's not true, actually, but yeah. And yeah, in terms of things around the shack and around that you might be useful, this is a system called Gridfinity, Zach Friedman designed. It's basically a storage unit system designed around 42 millimeter square units. So you print a base plate and you print boxes of various sizes and they all fit, which for parts boxes, absolutely incredible. My printers spend most of their lives printing small 42 millimeter variant boxes. But this is a Gridfinity box. This is the grid system with some 5x1, two 4x1s, and that's a Handtech oscilloscope that I found the design online, download, printed. It just slots in it, and it all fits in the box, and the box shuts, and it goes back on the shelf. And that's custom fitted to the kit that I own. Thank you. Yeah, Gridfinity, for me, is nearly worth owning a 3D printer in its own right. And if you are going to do Gridfinity, try to get a fast one. My budgets page has vanished. Okay. Let's go back to this one. I know what I'm doing. I can give talks. Different budgets. At about £300, you can get a very good starting printer. The Bamboo Labs A1 Mini base price is £170. Its print bed is 120 mil. I'm probably misremembering that. Roughly about the same size as that, maybe a bit smaller. That's modern enough to get started printing things. The other thing with 3D printing is there's nothing to say you can't print one big thing in small parts. They also, Bamboo, do the AMS, which lets you put multiple filaments connected to the printer at once, including multiple colors, multiple types, multiple whatever. For the A1 Mini, that's £300. Creality do a bunch at that price. Decent. £500 is kind of your next step up. At that point, you start getting into the Core XY printers, printing 256 squared pretty quickly. And at £1,000, just buy the Bamboo X1C or the Creality K1 Max or something along those lines. So yeah, like you can get started with a good printer for £170 plus some filament. Like that extra £30 to £200 gets you 3 rolls of filament. And the last thing on this slide, accessories you might want. You don't need, but you might want. Filament dryer. A lot of the plastics are hydroscopic. They absorb water. If you keep them in a high humidity environment, and anything over 30% counts as high humidity, and high, we live in the UK. The humidity here right now is about 70. Filament dryers are basically dehydrators that take a filament roll. You can just buy a dehydrator from eBay or Facebook Marketplace. They work just as well. 3D lac is a little spray that people used to use non-scented hairspray. It's basically that. It helps the print stick to the bed a little bit. It's not required, but it can help in certain circumstances. Never use it with PETG. PETG sticks like nothing else. And yeah, if you then add more stick to it, that print's not coming off. Plastic razors or scrapers, handy if you have stuck it to the bed. Hardened nozzles for printing abrasives, kind of useful. Tweezers, generally useful when it's spat out some plastic and it's hot and you need to pick it up. Isopropyl alcohol, yeah, the print bed, like if you touch it, you'll get oils on it, cleans it up, and I'm done.
Fantastic. I don't think I've heard so much new information than any other lecture this weekend. Any questions?
I've actually got an Ender 3.
I knew there would be someone after I said that.
But it is a V2, and I've been very pleased with it, and I've done a few modifications. But for my CAD, I use a thing called Tinkercad, and I found that very much easier for anyone just starting out.
Yeah.
Tinkercad is brilliant. I mean, you can move on to the bigger ones.
Yeah, yeah, that is a good recommendation. I started with Fusion 360 because I'm an idiot. Yeah, Tinkercad is a good place to start. The other one that they've just started removing it, but the Microsoft 3D Builder, I think that ships in Windows 10 and 11 in the App Store, actually surprisingly genuinely good as a beginner. They've just stopped supporting it, but it's still available, I think. Yeah, it's also a really good place to start.
Keep your filament in the airing cupboard.
Also a good tip.
Over there.
Thanks. I desperately need some decent storage. So what's the storage box that you had? What size of printer would you need to do that? Is that printer there big enough?
That particular box, no, it stands about that. I printed it on my K1 Max, which has a 30 centimeter print bed. 256 by 256 is the sort of modern standard, because that's the standard that Bamboo now uses their standard, and everybody's sort of copying them now. So 256 by 256 a lot of models are designed for that size because it's very common. The thing with Gridfinity is it will scale as big as you like. If you've got a printer this big, you can print a thing this big. But yeah, useful sizes start probably over 200 millimeters.
Labs A1 Mini you quoted, would that do that box?
No.
No.
You'd
Okay.
want the A1 full size or going up to the P or the X series.
Right, thank you.
So we're a bit out of time. I'd suggest if you've got more questions, you can ask Jim at the
I'm
front.
more than happy to talk about 3D printing all day. So
Thank you very much.
yeah,
Fantastic lecture.
Thank you.
And welcome back to the live stream studio for almost the final time now. And I'm with the man who's made a lot of this happen with a lot of team, I know, but Steve Thomas, M1ACB, the convention chair as well as the general manager of the RSGB, but you've been here really organising all this convention. So Steve, how's it gone?
Well, I think it's gone really well. And there's always things that go wrong during it, but the thing we try and do is fix that without anybody knowing about it. So if we've managed to do that, I'm really happy. But just before we get into that, then I know the team have been working on a video real time during the convention that maybe explains a little bit about what's been going on. So if we can have a look at that first.
Let's do that.
And then we'll talk about it. Okay.
So Steve, that was what it was like to be here.
Yeah.
And it's really, you can't beat being here.
No.
But of course,
no.
for people who can't be here for whatever reason, or just thought, no, I won't come there, but I'll look at the live stream.
Yeah.
Great chance to tell them what they missed.
We have the live stream really to give people a taster. So if they can't come, or they've never been before and they want to dip their toe in, then if they see some of the lectures, and we very carefully choose which ones we're going to put on the live stream, and it's only one stream out of 4 streams that we've got here, so it is a small percentage. But we try and choose a range of topics, and we try and aim them at people who might want to dip in and find a bit more in future years. And if they then choose to come to a convention in later years, then I think we've done a good thing. But also we use it to try and get people to try something new in amateur radio as well, hence the breadth that we try and choose on that stream. So it might be people who are new to amateur radio or new to a convention or want to try something new. So hopefully they've seen something on there. But having 4 streams here, including the AMSAT stream of course, means there's an enormous breadth. I think it's 50 speakers, something like that. So there is an enormous amount, but the live stream is important to us, And we've had people all over the world watching the live stream. So some of those are unlikely to travel here. But of course, we then spread the word of amateur radio, and let's be honest, we spread the word of the RSGB as well, internationally. So it is a great opportunity to bolster both of those things, really. But the people who are here see so much more, and they get to take part in the social side, which we know is important. We hear that again and again. And not just the meals and the dinner and things like that, but just meeting people in the corridor or in the lectures that you're in. You're going to a lecture with similar-minded people, aren't you, in that room that have gone to that lecture because they're interested in it. And there's a lot of discussions start there and over the coffee pot as well. You know, that's a powerful place to meet and talk, isn't it?
Yeah, and there are things we can't really convey on this live stream. Really,
no. I tried desperately for the opening part to let people know how many people were in the room. I'd got them to all call out their call signs.
Yeah, we
saw
that.
a bit of a pile up. And now I know that that room holds 250 people, and it was absolutely packed. But I don't know whether on the live stream I'm sure they didn't pick out 250 call signs.
You could only see probably 30 or 40 in,
you just
in the
can't.
screen.
So that was the idea, to let people know. So in that main lecture room, and it's only one of the 4, then we had 250.
So how many people roughly have come to this convention this weekend, over the weekend?
It's a really difficult thing today for me to tell you, because we know how many pre-bookings there were, and we well over about 350 I think were the pre-bookings. Then we can never know how many people are going to turn up and pay on the day.
Yeah.
Right, so I can't give you the fine. I wish I could.
I could see the queues though, so that meant there was a lot of people.
The queues caught us out a little bit because a lot of people arrived all at the same time. So we had some things to deal with, but that's what we do. There's always one or two things to be dealt with.
Anything? Let's start negatively. Anything else go wrong? As it were? I mean,
if it goes wrong, then the art is in fixing it, isn't it? We had one of the speakers called in yesterday, had got COVID, so he couldn't come, and that was only with a few hours to go. One of the other people I'd spoken to in the restaurant the night before said if we ever needed to talk, he'd got his laptop with him, and he'd got half a presentation ready. So he was the first number I called on the, on the Saturday morning.
Excellent.
And said, "Could you
really?" And they did just
a couple of hours later. There he was doing his talk, and
it
was very well received.
Was that the one on the different frequencies, wasn't it? Used the Olympics?
Yeah, for the Olympics.
I've heard so many people say about that.
That was with about 2 hours' notice he did that.
That is amazing, isn't it? Well, I've heard, honestly, lots of people have commented on that to me privately about it. So, and then that and many other lectures, of course, will be recorded, and then apart from the ones that we've live streamed, which are there now, and this live stream will be there on the RSGB YouTube channel, but in the future weeks and months we'll be releasing those to RSGB members first.
We will, absolutely, and we'll put those out, different times, and try and match it with things that are happening at the time. We don't just randomly throw them out. There is a bit of a plan to it.
And one of the other things we couldn't really do much justice to in terms of live streaming was that workshop on microcontrollers, which I know was well oversubscribed, a remarkable value as well, subsidised I think by the Legacy Fund, I found out today as well, which is good.
So the RSGB Legacy Fund.
Yeah. What is it? Can you just tell us about the Legacy Fund now?
Well, where people want to donate money to us, and it is often when they passed away, but not always, right? So people can donate to the Legacy Fund. And then we've got a Legacy Fund committee that then look at people's applications for worthy projects, let's put it that way. And we've got quite a substantial amount of money there for projects. And the real thing the real measure for it is if it's for the greater good, then it's got a good chance,
So that helped keep the cost of that course down just to £10.
Yeah, absolutely.
And for that they got a book, and they got the Arduino, and they got a screen, I think an LCD screen, and things like that, and everything they needed for that.
And this was run by Mark Jones, one of the directors, of course.
Absolutely.
Who's very keen on the practical activities. So he volunteered he suggested running that. We were looking for something practical to do, and Mark said, I can do that, and we've had fantastic feedback. Yeah. And he was only going to run it on one day. It was well oversubscribed, so we talked him into doing it on the second day as well. And the feedback has been amazing.
Yeah, and I mean, in 2 hours, he taught people how to just get started with an Arduino, never having touched one or coded or anything before, and get going with it. And that is, of course, one of the great things that the RSGB can do. And although we've got Radcom and other mechanisms to show to people, but there's nothing quite like getting it in your hands and doing it. And this convention's a great place to do that, isn't it?
Yeah, absolutely. And one story about Mark's workshop, he ordered all of the pieces, and when they came, he had to do a few thousand solder connections that he was up, I think it was about 5 o'clock on Saturday morning to get it all ready for when the people came in the door. So he was there with his soldering iron in the early hours, getting it all
because he didn't realise that maybe they needed some.
No, there was some soldering necessary, so there we go.
Good.
That's another one of those activities, another one of those things to fix.
Looking back this year, we can say looking back with just a couple of hours to go at the most. Now, highlights?
I think the practical workshop is definitely one. I always love the gala dinner. Now, people think that's a very formal event. It's not. It's a lot more casual than people think, and it's just a great opportunity for people to sit across the table, talk to perhaps the contest stations that they work every week or every month in a contest, and they don't see them face to face. Talk about DX. Talk about anything. That's always good fun. I really enjoy that. I'd seen some people operate the special event station. We've had GB3 HQ running in Camham's Flossie van at the front, and we've seen some unusual people operating the station that haven't operated
my
before.
Boss here, I've seen operating it. Couldn't believe that.
We managed to get Heather, our comms manager, operating. So that's definitely a first. But other people come along and they want to have a go, because sometimes operating the special event stations, it's good fun. And I know you've been cut into it occasionally, haven't you, as the filler between some of the activities.
And that's another way for people who aren't able to join us as well to get involved and actually get here and see the call sign come up on the bottom of the screen.
You had the frequency at the bottom, I think.
Yeah, we did the frequency and the call signs in the log as well.
Yeah.
Thanks to our friends at Camhams who wrote some clever software to transfer the log onto the screen. Really good stuff.
And of course, videoing all of the lecture rooms, then the team there have been collecting all that video and feeding it through to you for the live stream. So there is an enormous technical element to the convention now as well. And it's building every year, isn't it?
Yeah, it is, and it gives us a technical challenge. We've got a bit of a different...
and some.
There's a lot of special events there this year, so we had to move this studio separate from the special... the special interest groups, and we had to move that. So we've got behind me here, there's a couple of windows open, which makes it cold in here, but that's because we've got cables coming out the windows and down into downstairs.
That was always plan B for if the wireless network stops working. Yeah.
So Steve, convention chair, you'll be convention chair next year, will you?
No comment.
Okay, well, what would the convention chair know when they get back in their office on Monday, be thinking now, ready for whoever's going to be convention chair, do they start planning the next one?
Yes, definitely. We've got to think about location always, because as it grows, we always have to look to see whether it's still the right venue. There's a lot of work involved in changing the venue. I'm not saying we're going to, but we always take that.
Got to review it.
Take the feedback that we get from people about the venue, and we think about the way we configure the convention. Let's put it that way. So on 2 floors, the number of lecture rooms and things like that. Do we need people being able to stay? Hotel services, and how the food's been and everything like that. All of those things get mixed in, but that's as well as that, we then have to get feedback about all of the lectures and the mix of lectures and things like that, and that changes. That we've gone through the COVID years where we had to do it completely online, and then we wanted to make sure the convention carried on, so we had to make it hybrid, and that's developing. But all of those things mean that we've got to keep our eye on how the convention's set up. Are we attracting the right audience? Are we in the right location? There's a whole load of things that have to be taken into consideration. But I've already started collecting lecturers for next year. People have volunteered during this year to say, I can do this. And there's people been saying, we love this, we love that. It's even better if they come along with an idea of who's going to present. But, even having an idea of the topics is great, because we take that from a lot of different sources.
Lovely.
From Radcom articles, all sorts of people that we know.
Okay, Steve, thanks very much for today and for all of the work over the weekend for the convention. We're now going to go back to GB3HQ for the last time, where our president is going to give us a closing address.
Good afternoon, everybody. Welcome back to Lecture Room 1. It's my pleasure to introduce Steve Nichols, G0KYA, who's going to talk to us about Solar Cycle 25, its predictions versus reality. So The talk's going to look at solar cycle 25, how it's panned out, what we've learnt, and what the highlights have been so far. So Steve G0KYA is the chairman of our Propagation Studies Committee. His main interests lie in HF and HF propagation tools. So over to you, Steve. Thank you very much.
Thank you very much. Well, we're going to have a look at what the scientists said we might get for solar cycle 25 and compare that with what we actually got. And we'll see how good the scientists were. Not very good at all. And then we'll have a look at some other propagation tools, and also we'll look at where we are in the cycle, or where we think we are in the cycle now. So I'm going to start straight away, so we mustn't overrun, I've been told. So here's where we are. This is the cycle 25 according to the 10.7 centimetre radio flux progression. There's two ways of measuring sunspots, basically. You either measure the radio coming off the sun at a wavelength of 10.7 centimetres, and we call that the solar flux index, or we count the sunspots. But that gets confusing because if you have one spot, that's one sunspot in one group, so you instantly have a sunspot number of 11, even though you've only got one sunspot. So it doesn't, I don't think it really tells the truth. But the solar flux index, is, for me, is a better way of doing it. But as you can see, we had solar cycle 24, which peaked in 2014. And you'll also notice there's a double hump on solar cycle 24, which is not unusual. Normally what happens is you get a maximum in one hemisphere of the sun and then a maximum in the other hemisphere of the sun. So it's usually double peaked. So if you look at where we are now, is that the second peak or is that the first peak? Hard to say. We'll have to see. And if we look at this under the sunspot number, it's a very similar diagram. It doesn't really change that much. But you can see that we've already had a sunspot number in excess of 200 on cycle 24, cycle 25, and currently 150 or thereabouts. And again, you can just about see there was a double peak in 24. So again, have we got that double peak in 25? Have we had that yet? So there we go. So what did they say? Well, the official line from the NOAA/NASA Solar Cycle 25 prediction panel was that it would peak in July 2025 with a maximum sunspot count of 115, plus or minus 10. And the current behaviour of the sun is consistent with early onset near the beginning of our predicted range. It says if current trends hold, solar cycle 25 should peak as early as 2024, and it should be similar in strength to the relatively weak signal that has preceded it. Okay. And this is one of the diagrams that was used at the time to demonstrate that. So we had cycle 21, 22, 23, 24, all decreasing strength cycles, to be honest. And again, you can see the double peak in each of those, which suggests that this is a thing that we can look for. And this was suggesting that solar cycle 25 would be around about similar to 24, but maybe a little bit lower. It wasn't a very good prediction, to be honest. And it would be peaking around about now, actually, October 2024. Then, there we go. So cycle 25 will be slightly weaker than cycle 24, making it the weakest cycle on record. Boo. Weak cycles are preceded by long extended minima. This is all very negative stuff. We're currently beginning with cycle 24 in the midst of our modern Gleisberg cycle minimum. And so it was a question of, was this going to be the start of a longer minimum, like a Maunder minimum, or was it just a modern minimum? But this was what NASA and NOAA, this is not just one person's idea, this was the collective idea of what it was going to be like. This was another prediction that came about. We predict the maximum of solar cycle 25 will be in the year 2023, so February, March 2023, with a peak sunspot number of 154. Which would have been more than cycle 24, but not phenomenally more. This was great. Livingston and Penn showed that the sunspot magnetic field was getting weaker, and if the field drops below 1500 Gauss, sunspots cannot form. So was this going to be the start of a Maunder minimum coming up? But in the same year, this report came out. It said astronomers just measured the strongest magnetic field ever seen on the sun. So are you with me? At the moment, this just shows you that a lot of the time we don't really know. We can only report what we see, but trying to guess what's going to happen is just that, I think. This was something that Carl Litchelswab, K9LA, prepared, which was a list of 27 predictions for cycle 25. And it's only the two at the bottom there which predicted that it would actually be better than cycle 24. So out of 27, 25 of the predictions were that it wouldn't be quite so good. And this is graphically where it was. So an average cycle was there. The 2 or 3 predictions that said it would be better, and then the rest were pretty much saying, no, it's not going to be good at all. So it wasn't a good sort of forecast, I think, for cycle 24. Sorry, cycle 25. And thanks to Carl, K9LA, who is an associate member of the Propagation Studies Committee. So even though he's in the States, we still correspond, and that's why I used his data today. Now, one prediction said that we would have a massive solar maximum. This was Dr. Scott McIntosh. He's a Scot, but living in America. And his colleagues predicted that solar cycle 25 would be one of the strongest ever recorded, with a peak sunspot number of 184, somewhere between late 23 and mid-2024. And this is based on an idea that an early terminator in the historical record indicates a stronger cycle. Now, this idea of a terminator, I don't know if you know, but sunspots tend to start higher up in the hemisphere of the sun. So they start at a high latitude and work their way down until they get to the middle, near the solar equator, and then the whole process reverts and starts again. So he put his neck on the block, really, and came out with this. He did revise it slightly downwards, slightly after solar cycle 25 started, but he was the only person, I think, or one of the only people who was prepared to put his neck on the block and say, no, I think it's going to be better. And I think this sums it up, really. This is Niels Bohr, nuclear physicist and Nobel Prize winner. Prediction is very difficult, especially about the future. Yeah. So I think it's very easy to look back and criticize people, but it is very difficult to predict what's going to happen. But, as I said, Scott McIntosh was prepared to put his head on the block and suggest that we were going to have a pretty good solar cycle 25. He's now left academia, by the way, and has joined a company called Linka, I think it's called, and they're a space weather forecasting company, and he's vice president there. So he's left academia, but still very much involved in space weather. So, as I said, the sunspots on the sun tend to peak in one hemisphere rather than the other. And this was a shot from a couple of days ago. And they've nearly all been in the southern hemisphere in the last few months. And as you can see, that's 3848, the one there, is pretty much near the solar equator. So does this mean that we are heading towards solar maximum, or we've gone past solar maximum? Well, this is a question that you can't really answer for about 7 months until after you've passed solar maximum. But Scott McIntosh, I saw a presentation he gave recently when he suggested that we may have hit solar maximum in about April or May. But it will be quite a few months yet before we can actually confirm that. So I said in 2019, actually it was here I think, what could we expect? Well, I said the good will have increased maximum usable frequencies, the upper HF bands will be open to DX, bands will open later, fewer coronal hole issues, more long path openings, and 6 meter band would be open. Almost there, not 6 meter band open, no, not really. I was talking to Chris Deacon yesterday, and he said there hadn't been that many 6 meter openings from the UK, but we live in hope. No, they're not so good. This is the boo side. Increased number of solar flares, increased number of CMEs and auroral events, absorption on lower HF bands, coronal holes will increase after maximum, and 40, 80 and 160 meters would not be so good due to D-layer absorption. That was my prediction in 2019, and I don't think it's got it that far wrong, to be honest. I think that sums up what we have had. But we'll look at that in a minute. So where are we in solar cycle 25? Well, solar cycle 24 declined more quickly than was forecast, and cycle 25 started in December 2019. And as I said, solar maximum is defined by the peak of the 13-month smooth sunspot number, or SFI curve. So we won't be able to actually say that we have hit maximum for a few months or until we're past it. So NOAA said that they thought we'd have maximum between July 2024 and January 2025. So in other words, we are somewhere around maximum now. And what does this mean? Well, if you really want to know what it means that conditions are going to get worse. Because on the whole, you get more coronal mass ejections, more solar flares, and other problems on the downward portion of the cycle, not on the upward portion of the cycle. And so another view was that it was the maximum was somewhere between January and October. So I think we either are near maximum or have just passed maximum, but we'll have to see. This was another graph that was prepared by Carl K9LA, Carl Little Swab in the States, and this shows you the smallest cycle, cycle 24, the maximum of cycles 23, 21 and 19, which was 1958. That was a really, really big cycle. And you can see that we are the red line on there, so we're cycle 25 in progress. So yes, we have had a better cycle than cycle 24, the last one, but it hasn't been massive. It's not been a record breaker, and it's not even been that phenomenal. You know, the solar flux index every now and again over the last few months has been very, very good. But don't kid yourself, it's not been a 1958 breaker, you know, a world record breaker. But we live in hope. You never know, it might get a bit higher. We'll see. It's got to go a long way to break 1958's record, though, I think. So how will propagation improve? I heard people saying this recently, oh, conditions are really rotten, they're terrible. Well, I think a lot of it has been the time of year. HF propagation in the summer is never particularly good, other than sporadic E, which is, well, nothing to do with sunspots, to be honest. But this is a VOACAP chart showing propagation between the UK and New York from August 2024 on the left and October 2024 on the right. And as you can see, the MUFs are much, much higher from August to October. So in other words, in August, if you look at that, chances are you definitely work at New York, maybe definitely 20 meters, definitely 17 meters, and maybe the odd sort of 15-meter opening, but no 10-meter openings whatsoever. But jump forward to October with the same smooth sunspot number, or near enough. And yes, now you can see that we've got 28 megs is open, roughly from midday to 6 o'clock. And these charts, this is voacap.com, so you can all go on there and produce these sort of charts if you really want. But it just shows that I think when people say conditions have not been that good, I think you have to take into effect the summer doldrums, as we call them, on HF. And so we're now seeing, when there are no coronal mass ejections and no solar flares, we do begin to see 10 meters really, really opening up. And this is a damn good month for it. So if we should get a few days where the K index will stay low, we should see some really, really good 10-meter propagation. And hopefully this will now, probably extend the whole of next year, probably, and maybe the year after that before it starts to die down again. So yes, over the next year, work your DX, because it's going to be probably about as good as it gets. Now, the big overall event of May the 10th and 11th, 2024, I wrote this script for GB2RS on the Thursday before that happened, and I said there have been 4 X-class solar flare events on May the 8th and the 9th, which have prompted CMEs, which could join together to impact the Earth this weekend. We can expect a strong G3 event, perhaps on Saturday, with the KB index rising to 6 and the potential for visible aurora in the UK. So, got it half right. We did have visible aurora in the UK. It didn't go to 6, it went to 9, and we had a very, very strong geomagnetic effect and geomagnetic event. How strong was it? Well, This is the KP index chart on the right there, which it neared 9. I remember that was, what's that? It was, yeah, about just before 9 o'clock, that one. And I remember looking at that thinking, oh, crikey, that's gone up a long way. Should really go out and see if there's any aurora, but no, I can't be bothered, I'll go to bed. And woke up the next day to all these marvellous pictures. And you can see here on the left, the auroral oval has come down. I can't remember if you, I think if we can see Great Britain is there. So we're right under the auroral oval, which explains a lot. So that was a pretty fantastic event. And I'll show you the effect that it had on the MUF. This was PropQuest's critical frequency plot, an MUF plot, for the day before this auroral event. And as you can see, the MUF over 3,000 kilometers was in excess of 21 megahertz. Now, what does it look like the next day? Yeah, basically nothing. You know, the digisondes, or the Daub digisonde, was not recording anything coming back from the ionosphere at all. And it took until 4 o'clock in the afternoon, or 4 or 5 o'clock in the afternoon, before the ionosphere even started to send any signals back. So yeah, I think that's a classic example of what a geomagnetic storm does to propagation. That was the scene from Quebec, which is very pretty. This was the scene from Norfolk, Roberts G4T UK's location. But of course, someone said to me, well, do you think this will happen again? I said, well, probably will, but quite when, I don't know. Well, as you probably know, yes, it just did. We just had it again. So this was 2 days ago. And this was by Magda, who's the wife of G4 BAO's builder. A Polish lady who shot this in Cambridgeshire 2 nights ago, I think. And I thought, well, we'll put that in. I think it's a good shot. Good shot. So yes, so we've had lots and lots of aurora. I'm not that interested in aurora, but I am interested in HF propagation, which has been dire as a result. The two tend to go hand in hand. So while HF propagation was badly affected in May, it was better news on 6 and 2. On 6 meters and above, it seems there is too much auroral spread for FT8 and FT4 to work. But Tim M0AFJ reported that 2 meters was full of auroral CW, and David G3 WGN, he worked Netherlands, Germany, Hungary. What's S50? That's Slovenia? Slovenia, Yugoslavia? No, it can't be. Romania. Thank you very much. Anyway, lots of places on 2 meter CW. Yeah, yeah, and apparently it was good the other night as well. So while people are out there watching the aurora, they could have been working DX. But while HF people were just crying into their soup or whatever. So let's think about this. What have been some of the highlights of the last year? I just picked 3 or 4 contacts that I just thought were a good evidence of excellent propagation. So this is VK9DX Norfolk Island on 10 meter USB. SFI at that point was 245, the KP index of 2.5. Well, anything below about 3 is good. If you have 2 or 3 days of a low KP index, you tend to get better propagation. So the chart on the right is a VOCAP chart of the path from the UK to Norfolk Island in the Pacific. And I put a line on there just before 10 o'clock. So you can see that the prediction was that 10 meters should be open, just be opening up to Norfolk Island. And they were allowed for hours, actually. It's very good, which just shows you what you can do with a good SFI number, low KP index, and good HF conditions. This similar one here was St. Paul Island, which is a recent de-expedition. The reason I put this on, I worked them on FT8, but that wasn't really what took my, or made it rare. What made it very good was this path on 10 meters, not 12 meters here, but 10 meters, was still open 2 hours after sunset. which was fantastic. It's not often you hear 10 metres still open after dark, but it was. And if we plot it out on the right-hand side with VOACAP, you can see that suggestion is that there should be some 10-metre openings at that point, but it obviously tails off as the evening goes on. But I do remember listening, thinking, well, that's good, I can still hear it, what's going on? And just two more contacts, really. I maintain the 10-metre beacon list for RSGB. We'll talk about that in a minute, but just little beacons that run very little power. This was the 5-watt beacon in Illinois, NS9RC. And yeah, you could hear it very easily and for hours on end, which tells me that 10 metres is really working when you can hear American beacons running 3 or 4 watts. And it's nice to contact these people and say, hey, you've just been heard in the UK, and people get a real thrill out of it. But everyone to each his own. But I do think that hearing a 3-watt beacon out of America is still magical. So that's my particular level of interest. And again, if we look at the VOACAP chart for that, we can see that the 28 megs should be open. I mean, North America in October should be really good on 10 metres. So again, if you have 2 or 3 days with a low KP index, no solar flares, no coronal mass ejections, no aurora, we should get some good 10-metre propagation again. And just one more here, a 4-watt beacon, North Carolina. This guy was very pleased to hear that his beacon was being picked up. And again, that shows you, the chart shows you that yes, it should be possible at 28 megs, or even a bit higher actually. But we certainly haven't got any 6-metre propagation of any great record anyway. Whether we will get some, I don't know. SFI 245 there, it's not going to get much higher than that, I don't think. Maybe maximum 300, but we may have already gone past the maximum, so who knows. And this last one was Vietnam, which I worked the other day on FT8. Why did I work him on FT8? Well, because that's what he was on. I would have had a debate about this with somebody last night. Well, I wouldn't have worked him. If he can't go on CW, I wouldn't have worked him. Well, he didn't want to be on CW, he wanted to be on FT8, so I worked him. That's 2 people here around who think like that. But yeah, I saw him pop up on was it WSJT, and I thought, oh, Vietnam, that's interesting. So put a call in, yeah, came straight back. So that's the sort of thing you can do on 10 metres when conditions are good. So again, SFI was 245 at that point. So it's nice to make the contact anyway. And as you can see from that chart on the right, the fact it goes up and above shows you the MUF over that path was probably more like 35, by 40 megahertz probably. So I think that there is the odd 40 megs beacon, isn't there? Where is there? Is there one still? I think, is there one at Camp Cornwall? Have they got one?
They've gone down on the US licenses.
Yeah. But there are some 40-meter beacons available, and I wouldn't be surprised if you start hearing them, over time as well. How are we doing for time talking of that? Oh, we've got 20 minutes yet. So what can we expect for the rest of the cycle? Well, this is a chart of sunspot number and disturbed days. And lo and behold, you can see that the two really go hand in hand. You can't have one without the other. It's just one of those things. But what you also notice is that on the downward slope of the cycle, you tend to have more disturbed days. So this probably means, and here we go, that the next 6 months may be even worse than we have had recently for solar flares, coronal mass ejections, and aurora. Now, whether that's good or bad depends on what your particular interest is. If you're a 2 meter and 50 megahertz auroral devotee, then you'll be absolutely laughing your head off. If you like seeing visible aurora in the UK, you'll be laughing your head off. If you like working DX on 10 meters or HF in general, you won't be so happy. But there we go. I would say we've got, as I said, at least 12 months of good conditions yet, maybe 24 months. But we're probably either at or have passed sunspot maximum now. So there we go. If you don't get on now, you'll miss it. And you have to wait another 11 years, won't you? So, as I said, we should have good DX for at least another year or two. October's probably one of the best months for DX. 10-meter DX generally needs an SFI greater than 100, but geomagnetic disturbances are generally worse on the downward portion of the cycle. And will we get another major auroral event? I've said possibly. More likely, probably. Whether we'll get another one as good as May, I don't know. But then the other one that was 2 days ago was not far off, I don't think. You just need a number of things to happen at once. You need to have a very big solar flare with a big CME. It has to have the BZ. It's frozen in magnetic field, which is what happens you get with plasma, that has to be pointing south. Now, we talk about the BZ pointing south, and I sometimes wonder whether people actually understand this, but when this solar flare throws off this, well, not the solar flare, when the coronal mass ejection throws off this plasma, it has a frozen-in magnetic field. And if that magnetic field points south, it's a bit like a bar magnet. You know, if you have a north-facing bar magnet and a south-facing bar magnet, they will join together. And that more easily couples with the Earth's magnetic field, and the plasma comes flooding in. If they're both pointing north, it tends to bounce off. So if you have a BZ which is pointing very strongly south, look out for lumps. That's when the problem starts. No, just one other thing. The 10-meter beacon list that RSGB runs has been revamped. It was originally produced by Martin, G3 USF, and we kind of maintained it for about 5 years. But this last year, I just decided, no, it's just so out of date, it's terrible. So I scrapped the whole thing, and we started to use the reverse beacon network to regenerate the list. And so the beacon list is brand new, it's up to date, it's pretty much there. I've got to put some updates in, I think 5 or 6 updates in very soon. But if you use the RBN to do this, it's producing about 50 to 100 spots per minute. And so what I have to do is have the beacon list there and the RBN list there, and you compare the two. And every now and again you'll see a new beacon that's gone up. But if anyone wants to help doing that, then they're quite welcome to try it. And if you find a beacon that you're hearing that's not on the list, then just send me an email to PSC Chairman. I'll show you the email address at the end, and we'll get it updated. And finally then, just some other tools that we can talk about. I mean, do you know that we have now a VOACAP RADCOM chart? Do you know that the listings in RADCOM, which are for HF, well, we've replicated that on VOACAP, and we replicated that on a program called ITU RHF Prop, which we've changed to Proppy because it's easier to pronounce and remember. So if you want your own personal chart of the RSGB locations that you can work, you either go to rsgb.org/proppy or rsgb.org/voacap, and it will prompt you for your station in terms of your antennas, the altitude, the noise level at your location, and then you can print out the colored charts for your particular station for the next month. We always have to keep telling people this because people forget. So that's the two main RSGB propagation listings that we've got. This is another one that I've generated some time ago, which is g0kya.blogspot.com, and on there you've got a short path propagation from the UK, just a small, very small map that you just click on the month that you want, you select the band and the time in UTC, and it will come up with a chart like this that shows you where you like to be or where you like to hear things. It's just a very, very quick and easy way of seeing what's open from your QTH. Also on there now we've got the some of the information that's been duplicated from spaceweather.com. And you've got this other chart in the middle there, which is the magnetic field of the, or BZ component. So you can see when it goes the left hand, I've just got a point here, this left hand one there, when that points south, that means it's more likely to couple with the Earth's magnetic field, and we're going to have more effects. And the speed of the solar wind, it's showing there 600 kilometers per second, which is, I mean, it's normally about 400, so that's an enhanced solar wind, but it's kind of neutral or pointing north, so it wouldn't be a big problem. When that thing swings deeply south and the speed goes up, you know you've got problems. And then we've got the KP index on the bottom as well. So it's just another little tool that you can see, and it's just, I think graphically it's better than reading about where the BZ is and how many nanoteslas. I banned the term nanotesla from GB2RS because we used to say things like, oh, the BZ has gone south and is now at 200 nanoteslas or whatever. And everyone was going, is that good or bad? I don't know, what does that mean? So I banned the term nanotesla from GB2RS, so we now talk about, the BZ is pointing south, which is not good because it means, this, that, and the other. So there we go. So any more details? As I said, if you want to take part in that beacon listing and keeping that up to date for us, feel free. I do it about once every sort of 2 months, spend a whole day on it, just watching the things scrolling by and checking them on the list. But if you are really bored, and there's no Aurora to look at, mind you, and no DX to work, then feel free to join in. So you can send your details to psc.chairman@rsgb.org. And then we've got rsgb.org vocap and rsgb.propy. The difference between those is that vocap has been a propagation prediction program that's been in place for some time now, and the ITU came up with a new version of, based on their models of the ionosphere, and it was called ITU RHF Prop, or Propy as we call it. So if you can choose which one you want. I mean, we decided in the end to have both the vocap and Propy predictions available, and you'll see that on the whole they're both kind of the same sort of similar conditions anyway. But Gwyn Williams, who produces the propagation predictions for Radcom, swears that ITU RHF Prop is more accurate than vocap. But you can take your choice of which one you use. And thank you very much for your time, and we'll go to any questions now. We've got 10 minutes left anyway. Right, we've got to...
Am I right to ask? Steve, where exactly on your blog is the prediction? I've just looked and I can't see it, I'm afraid.
You got, sorry, what?
You said on your blog page there's those charts that you just showed
us.
Oh,
right, on the top right, top right, there should be a link from you can't see it? I can't see it from here. Hang on, right, so scroll down. Oh, it's probably, I know what it's doing, it's reforming it for a phone, isn't it? Should we try and look at it on here? Would that be easier?
That's great.
Yeah, okay, hang on. Bear with, as they say. Oh, right, okay.
It was also filling, I think, the correct thing for you.
There we go. So you've got this one here, and you just click on that now. There we are. So we'll pick October, and it automatically uses the correct sunspot number or smooth sunspot number for that month. And then, let's see, 2 o'clock, let's put it on 10 meters. So this shows you the likely areas you are able to work on each band. So if we put it on 3.5 megas, that will shrink dramatically. There we go. And 7 will get a bit bigger, 30 meters, etc., etc. And 20 meters gives you, oh, look at that, you probably still work New Zealand this afternoon at that time. So it's a vocab-based program that just quickly just gives you a load of charts that you can go through. But as you say, if that's October, but go back to August, this was people saying, oh, conditions have been rotten. Well, yeah, they will be. Actually, if we go to 10, it'll be even worse. Yeah, so August you could work north-south, not a bad month at all for north-south. But yeah, work in the States, it really doesn't kick in on 10 meters until you get to October again. Let's go to October. There we are. And so if we now just advance that a little bit, it's now coming in the eastern seaboard, nice and red. And on a good day, in October, you should be able to work the west coast if you've got a decent antenna and a bit of power, maybe, on 10 meters. Yeah, so we go to 15. Oh, yeah, we are on 15, not 10. There we go. Yeah, and it goes south then. There we go. That's better. Yeah. And so here's the charts I was talking about. So the BZ is just pointing south there, but the solar wind speed is quite low. So I wouldn't expect KP index to be that bad at the moment. And it isn't. Look, it's down here. It's sort of 1 or 2. So, yeah, by the time you get home tonight, you probably have some good HF conditions. Yeah.
Quick question, please. How quickly can the SFI index change? If it's high on a Tuesday, will it still be high on a Wednesday or a Thursday?
That's a good.
How long does it take to decay?
That's not a bad question, actually. It can probably stay quite high. I mean, it is the instantaneous measurement of the radio noise coming off the sun at 10.7 centimeters. So if it's high one day, it's probably going to be in that kind of region the next day. Now and again, they will take a reading just as a solar flare has gone off. So the SFI will look like it's 400 or something. And sometimes they have to throw that one away, but it's just the exact time they've taken it. And I think we had a case recently where it was something like 400. And they said, well, no, it's not. No, it's not. It happened that just there was a solar flare at that point, and the noise just boosted it up. But yeah, I think at the moment we're in that point in the solar cycle where it's going to be high-ish, but also the sun is rotating. So a lot of the sunspots, active sunspots, are moving off, and there might be something coming around the corner. I mean, again, we use solar ham an awful lot. You've just raised a good point. Is GB2RS, that's prepared on. Well, Jim does his bit on Wednesday night, don't you? I do my bit on Thursday morning. That then has to go to RSGB, who then compile it, send it on Friday, and it's read out on Sunday. So I'm writing something on a Thursday that's going to be read on Sunday, but it's going to be talking about the next week. So trying to get it right is very hard. And if we look at this picture here, from that, it doesn't look like there's an awful lot coming around the corner. So from that, would you deduce that the SFI is going to go down? Probably. The SFI will go down a bit next week. So we use that. We use the pictures. We use other information like the NOAA homepage. So if we go to the Space Weather Prediction Center and look at their forecast for next week, I think it will suggest, what's the date today? It's the 13th, isn't it? So there we go, 225, it's 235 today, and it'll drop down to 175, 170. So the SFI is going to go down next week. But this is what gets me. They don't give you any indication of what's happening geomagnetically. They put the solar flux index as 175, KP index at 2. Yeah, it'll take one CME, or one flare and one CME, to completely ruin that. So it's a little bit like this, really. It's guessing, a guessing game. But we do our best. That's the best we can do. So, yeah, there we go.
Hi, Steve. Thanks.
Hi.
Very interesting. Why don't we get reliable predictions for 160 and 80 metres?
160 is that enigma that is very difficult. If you read any of the books on 160 metre propagation, it's a very, very difficult band to get predictions for. You might get really good conditions one night, but not the next, but you can't actually say, well, what caused that? You could say, well, actually, any solar flux index is bad for 160 metres. You could say any geomagnetic disturbance is bad for 160, but it's really, really hard to predict good 160 metre propagation. Other than December is a good month, we can get it to that point. Must have a dark path between them, but much beyond that, it's very hard to predict. Honestly. Yeah. Hello.
ON4UN's book has some interesting comments about trying to predict propagation on top band. So the question I have is, if I remember correctly, at or near sunspot maximum, the sun's magnetic poles flip.
Correct.
Has that happened yet? Because that might be also a good indication to correlate with.
That would be a good. I don't think I've read anything that says they're flipped yet.
Okay.
But you're absolutely right. There isn't actually an 11-year sunspot cycle. It's a 22-year sunspot cycle. Exactly. And yeah, the magnetic field flips, or more to the point, the sunspot number, the sunspots themselves, the field flips. But as I said, they start off at high latitudes and work their way towards the equator.
They show these butterfly diagrams.
Yeah,
as
exactly,
yes.
exactly. But it's not looking too good, I don't think, if we're on the downward side, which may be why we're having these aurora now.
Right.
I'd stick my neck on the block and say it's we're either at maximum now, or maybe we've passed it by a few months, but we'll have to see. Yeah. Ask me in a year.
Okay. The other thing I was going to give a shout out, just in case people don't know about this, but on YouTube there's a channel run by a lady called Tamitha Skov.
Tamitha Skov, yes, Space Weather Woman. Yes.
Yes, and she does some excellent presentations about current conditions and predictions.
Yes.
And generally they're very current.
Yes.
So if you want to get some very good up-to-date information, that's a good source.
Yeah, she's in the same boat we're all in, though, that she's, saying what's happening now, and trying to guess what's happening over the next 2 days or so. I mean, we're getting better at it. If we know there's been a solar flare, the likelihood is there's been a CME with it. If the sunspot was pretty much square onto the Earth, you can guarantee that's going to head our way, and then we kind of work out the speeds.
Wait about two to
3 days.
Yeah.
But to say, oh yes, it will hit at 9 o'clock or whatever, it's tricky. It's tricky. Okay. Yes, sir.
Quick question. I thought there were more
I can't hear you. Sorry.
I'm only getting ground wave.
Yeah.
Quick question.
Oh, yes.
I thought there were now more satellites revolving around the sun, so we could look round the backside of the sun and see sunspots.
Stereo. You're talking about the stereo satellites. Stereo ahead and stereo behind. Unfortunately, stereo behind, I think, failed. So we've only got stereo ahead, which is not much use. Well, I don't know. Well, it's better than nothing. But yeah, if we look on here, you'll see you can actually select stereo, I think. Where are they? There we are, stereo. And search for stereo images. They don't even put them up now. Look, you have to find them. Stereo ahead, and then you can choose extreme ultraviolet light. Oh, we have to put a start. Oh, damn! You can't just get it. You have to, put your times in. But yeah, that's the only ones we've got at the moment. But one of them's broken anyway, so it's tricky. Yeah, and you have to not just look at sunspots in available light. You have to look in extreme ultraviolet as well to look for things called coronal holes, which are areas on the sun which are of lower energy, which have open magnetic field lines. So you don't just have to have a solar flare and CME to get problems. You could have a coronal hole which lets the solar plasma flood out, and that will put the K index up as well. So yeah, there's a lot of things to look for. Good. I think we're just about done now. So any more questions? No, you've all had enough.
That's great then, Steve. Thank you very much for your talk. We show our appreciation, please, everybody.
Thank you. Thank you very much.
And that concludes our last presentation. We hope you've enjoyed the live stream from here at the RSGB 2024 convention. Thank you for joining us. You'll be able to watch back anything you've seen on the live stream from either day by heading to the RSGB YouTube channel. But from all of us here on the live stream, that's Kevin M0UJD, Tammy M0TC, and from me, David G7ERP. Goodbye from us, and now handing to GB3HQ to our President, John.
From Milton Keynes from the RSGB convention. We may have time for one more contact. We'll see how we go. Just one more contact, GB4RS, I think, over.
Whiskey 4, Tango Uniform Delta.
Tango Uniform Delta Station. Tango Uniform Delta Station. Go ahead, over.
Yeah, roger there, John. Very good afternoon to you from West Wales. This is Golf Whiskey 4, Tango Uniform Delta, GW4TUD. My name is Win, Whiskey Yankee November Win, and we're just about a mile east of the university town of Aberystwyth on the west coast of Wales, John. Back to you from GW4TUD.
GW4TUD, GB4RS, you're 5 and 9 at the Milton Keynes. Win, lovely to hear you, lovely signal. And just saying, we're just about to close down. We're closing the live stream, and that'll be the end of the convention live stream. Just coming up now. GW4TUD, GB4RS is clear and closing. Thank you, everyone, for the contacts. See you next year.
73, John. Too bad, Oscar Nancy 5, number 2, India, Papa.
So do you want me to go again? Okay. Just to close down, yeah. Okay, everyone, that's the end of the convention live stream. Thank you very much for all the contacts we've had on the air. Thanks to all the people who came to the convention. It's been a great event, very well received, and we hope that you all enjoyed it. So thank you, and see you next year.